Yes. Do you hear the sound?
Yes. We will start today with Matěj Týč and his Go Big with Supercharged Agile session. Should you have any questions, please feel free to ask them here or in the matrix online, also for the folks who watch us streaming and online. Thank you.
Great. Thank you for the introduction and thank you for coming. It's the first session, not after the party, but still, yeah, first session. So I definitely appreciate that. So what can you expect from today's talk? It will be about adopting existing agile methods for environments that are generally big projects and biggish teams. So in the first part of the talk, I will try to bring us on the same page. Then I will be concrete about how to do this adoption or about the proposal. And there will be then a demo and then some questions and answers. We'll see how the time what the time will allow. At the beginning, disclaimer, agile is a term which covers a big surface. One of the subdivisions can be that it's about doing the right thing, delivering value for customers, and another aspect is to be kind of efficient, to work well, yeah, not necessarily fast, but also in a sustainable pace, predictable, and so on. And in this talk, when I talk about agile, I mean like the second aspect. Yeah, I won't talk about the first one at all, not because it's not important, but that's what the talk is about. So just to be clear. So I am a Red Hat developer. I'm a team lead also of the security compliance team. And when I joined the company like 6 years ago, we were brought to, or the Scrum framework was introduced to us. Yeah. And we were on one of the first teams. And what we found out that it's not so easy. Yeah? It's not a smooth ride. We kind of introduced it, and then we noticed that we still have some issues with mainly like with predictability. And because we are like an open-minded team, we checked out what can we change in order to improve the situation. And we made, I think, our agile practitioners happy because we were experimenting and desperate because we have tried like various things, and we have evolved, and the evolution still continues. And we have simply found out that the problem is a difficult one, so even a good approach is not good enough. We need a great approach. Yeah? So we'll see. However, the main pain points that we have identified are the need to have a groomed backlog, which is like a very important concept in Agile, as far as I understand. Being like a software engineer, yeah, not a person with Agile education. And also, as I'll get to it later, we are kind of a bigger team, so a lot of things are in progress during the execution, and it's like mess to some degree. Very difficult to find out whether things are going good or not. Yeah. So why is it so difficult? Very briefly, it might be that one is not developing a web app from scratch for a well-defined customer, but one is developing a small feature on top of some kind of big product. Yeah. And because the product doesn't have one customer, whom we can communicate and say we will do this and that will be different, but we need to keep everybody more or less happy. then actually a lot of work will be integration and not the deliverable, yeah? Like putting the feature there, integrating it with the rest, and just like the small piece here is like presentable, but the work that has to be done is really huge, yeah? So things are like kind of slow. Also, the team can be big. Usually big teams, I don't think that they are necessarily faster, but they definitely can do more things, and they are in some degree more stable. If the conditions change, a big team can really adapt, take more responsibilities, or even like exploit opportunities, but probably won't be doing it like in a specifically fast way. One offering is if you have a big team, split it into small teams, work much better, but maybe you can't do that, yeah, because the tasks that are coming are kind of changing. They are not stable, they are not always the same. So if you subdivide, then you will find out that you need to rethink the subdivision and so on. So it's not always a possibility to get rid of big teams and make small teams. So we are in this big environment, which means that things are slow. In order to accomplish anything like interesting, the iteration can't be those 2 weeks tops, yes, but really like more time is needed. During the execution, a lot of things are in progress at the same time. As a result, yeah, especially if the iteration is longer. And what suffers is the predictability. And as an engineer, I definitely came across the idea, like, screw predictability. What counts is the work that is being accomplished. What about giving engineers the right tools, the trust, the resources, and they will do the thing in the fastest possible way and screw the predictability, yeah? Why this is not a good idea? Some people know, but some might doubt that. So I have an counterexample. Imagine that you are a student and you are learning for an exam, and you know that you can get like questions from 3 boxes. The green box, 50% probability of the question, red box 40%, blue box 10% probability. Yeah, that you will draw questions from the box. A topic, yeah? And the question for the student is, in which order you will learn for the exam, yeah? In which order? And it looks like that you should start with the green box questions because this is the most likely, right? But the right answer is you can't really know what is the right order unless you know how difficult it is to master questions in the box. And if you know the cost, then you can make a good decision. And in this particular example, it is clear that you should start with red, continue with blue, and then do with green, because red and blue together are also 50%, and their costs are much lower. So where am I aiming at? Predictability basically means that you know the costs. And you need to know the costs in order to prioritize, yes? So whenever we do prioritization, we are in need of predictability. So if we have a big team, big project, and issues with predictability, we simply can't ignore it. Yeah? We need to address it. If you think of the previous example as well, it turns out that we estimate all the time. We estimate when we go shopping, when we travel, when we do pet project software, we estimate all the time. So why is it that the Groom backlog or the estimations that they are so painful? So there is like another example, and we see a situation like that in software development quite often, that how much effort will it require to remove the rock? When we see the top, we don't see the bottom. So those gentlemen might have different ideas, and whoever played Scrum Poker definitely experienced that. Anybody who played Scrum Poker in their lives? Could you raise hands? No, well, about half of the audience. I would expect more. So the other half will experience it, maybe, if they are engineers at least. So what happens is that one person says, I think the task difficulty is 5. of something, yeah. Other person says the difficulty is 15, and then they discuss and they find out that there is nothing that one person doesn't know, yeah. Everybody knows everything, but still one thinks 5, one thinks 15. What to do that? It is a very difficult situation because it's about the unknown. It's not about the known. And it definitely makes people uncomfortable because the number will be settled on 10. Yeah, the number will make it into the tracker. It will be visible to managers, and people are not so happy. So in order to know how to help this situation, we need to take a look what is an estimation. And if somebody says, I think the rock can be removed in 2 weeks, what happens in your brain? Yeah, what happens in your brain if you hear from somebody that they will do something in 2 weeks? It means that probably they won't be able to do it in the first week because it's very difficult to do things fast. It's easy to do them slow, but to do miracles very difficult. However, it is somewhat possible that they will do it earlier, between first and second week. It is, however, most likely that you will do it slightly. They will do it slightly later, because between the second and third. When the third week has passed, you start thinking it might never be done. Yeah, it happens. It happens in software. It happens anywhere. So, what is an estimation? What is it? Yeah, and we know it all. It's a distribution of probability, actually. And the thing from the annotation that everything has been invented, here it is. It has been introduced in late 50s of the last century. And this concept that estimation is a probability distribution, it's called PERT. It's being taught, I think, as a part of project management. And it introduces this concept of 3-point estimation. So instead of estimating tasks with one number, they are supposed to be estimated with 3 numbers, which sounds quite scary because if one number is a problem, 3 numbers might be a much bigger problem, right? But maybe it's not the case. The guidance is that we come up with the optimistic estimate, which should be so optimistic that we think that we can do even better with 1 or 2% probability. Yeah, so it's not completely a rosy dream. It's just like optimistic. The most likely estimate is what we normally target. And finally, we have the pessimistic estimate. It can be like story points. It can be weeks. It doesn't matter, really. And again, the pessimistic estimate is not a promise that it won't be later than that it won't take more effort than is the estimate. But again, there is supposed to be like a couple of % probability that even that will be slipped. Yeah, whether it's 1 or 2%, that probably doesn't really matter. So what does this approach? Sorry, one more thing. Usually we are required to put a single number in some tracker, yeah, in Jira, whatever. And the good news is that as any probability distribution, this 3-point estimation, probability distribution, PERT or beta distribution, whatever we like to say it, it can be represented by the mean, and the mean value is not the same as the most likely value. The mean value is somewhere between the most likely and the long tail. So in this case, we see that the pessimistic estimate has the long tail, so it's like more pessimistic. But if the task would be more like optimistically inclined, that, for example, there will be no bugs to fix after we run tests. Yeah, then we say we think it might be like 5 points, but maybe there will be no work to do. Yeah, in those situations, the expected value would be actually skewed to the optimistic end. So what problem does this solve for us from another point of view? There is this concept that we don't have in check, that estimations or whatever quantities, they can be accurate, they can be precise. Yeah, we don't discriminate that in check. So when we put numbers to estimations, we are infinitely precise. Yeah, number is simply a point, so we are infinitely precise, but as we all know, we won't be accurate. So we are in this unpleasant situation. However, if we substitute the estimate with this interval estimation, we are probably slightly improving the accuracy by using the expected value, and we are making the precision actually less, yeah, or we have lower precision, but it is more proportional to the actual accuracy. So we have actually better odds of hitting the target if we have lower precision. Interesting if you think about it, but undeniably true. So this is like a very interesting theoretical concept. Has anybody ever used it in this room? Has anybody ever used it in this room, apart from my team? Nobody. Okay. So me and my team have been giving it a shot for a couple of months, and there is one excellent news regarding that. That we have concluded that the process of estimating and using the estimations, when you use 3-point estimations instead of like traditional ones, the 3-point approach is not worse. Yeah. The process is not more painful. It's not like 3 times more painful to produce those numbers. So the process is not more painful, and maybe it's even more comfortable. We are not completely sure about that, yeah. But we'll continue our investigations. At the same time, this is a difficult problem. Estimating is a difficult problem. So even a good solution, even a better solution doesn't completely solve everything. So we found out that you need some practice, you need some guidance to estimate using 3-point estimations. And also, it's like difficult to explain. What does it mean that there are like misunderstandings? And we don't know. We don't know exactly. Then the second thing, the second pain point was the execution, which is busy, plenty of things going on, and so on. Sometimes things are in progress for a long time, and it's usually a problem. But if you have a lot of things, in the sprint, then you don't notice. On the other hand, some things are not in progress, and maybe it's okay, maybe it's not, maybe they should be, and so on. So when you have a long iteration, you can't do this traditional approach that you after those 2 weeks you do some retrospection and you say this was wrong. Yeah. If the iteration is very long, then you need to act in progress as soon as the problem is obvious enough. So it's necessary to have some tooling to introspect what is going on, and we will see that in the demo. So yeah, I put here a screenshot of a Jira because this is the only software that we use which basically has a field to input estimations. I'm not really sure how Jira can be configured. However, I think that for big teams which have more challenges regarding estimating and so on, having this small field next to some other stuff, like having this small field basically invisible when you are not looking at the issue, that it's something which doesn't make the estimating easier. And for some reason, at that time when I realized that, I thought like, oh, might be a great idea to try to develop a software that would kind of address this issue, that would provide an interface to the data that might live in Jira or whatever. Yeah, GitHub even doesn't have like a field for estimations. GitLab has something, I guess. And that would the software would allow the team members to estimate, and it would allow them to see the execution of their own long sprint, and maybe even do some stuff like deliver forecast and so on. So the project exists. I wouldn't advertise it as something that works generally. It's like a demo. And if you are a Red Hatter who uses Jira, then it might be a good idea maybe to reach out if you like that. In other case, I would suggest waiting or maybe using the Gitter channel that the project has. However, I hope the demo will work. What we will try to model? We will try to model like a sprint which has two epics, if we say it like that. One is that we do an upstream release, which includes fixing bugs, running tests, and writing a blog post. And then we do the downstream release that includes, again, running tests and then making the package, the downstream package out of the upstream source code. So, yeah, 5 minutes delay, but I guess we will manage. So let me see one. So what do you see right now is like the interface of the program, and it allows us to estimate, to track the execution, and also to simulate that the execution is in progress. Yeah. So we go to the planning interface. And there we can see that somebody, it was me, input those two epics. Yeah, it's like not a software used for that can be like seriously offered. Yeah, it's like more something that works. So we have this fixed blockers issue, and somebody already puts that it's 5. Yeah, the cost of it is 5, and we can make out of this 1-point estimate. We can make the 3-point estimate. So if we say fixed blockers, usually it's like pretty difficult. So we say optimistic estimate is 4, pessimistic estimate is 8. Yeah, then I click save, and it kind of it stores it somehow, and we have this plot. So I will do it. I will do this for that issue. Releasing upstream. Again, yeah, probably it will be easy. So I will say pessimistic 3. Otherwise, it will be the same. Writing blog post. 3 points. Yeah, sometimes people are very nitpicky. Yeah. So we say optimistic 3, most likely 4, pessimistic. I would say it can be 8. And let's estimate the rest 2 issues. Fixing issues in downstream tests, running downstream tests, and fixing issues in downstream tests. I think that they might be nothing to fix. Everything will work. So I will say optimistic estimate is 2, and pessimistic estimate I would say can be like 5, because there might be a problem with infrastructure. Yeah, and so on. So if we take a look, it all can be added. Like the individual estimates can be statistically correctly added together. So we see that the cost or the aggregate estimate of the entire sprint is somewhere between like 15 to 22 story points, something like that. All right, and what we any question to that? Might be a good.
I have a question. So the points are basically measuring complexity of the task.
Yeah, so the question was what the points are, what the points mean. Yeah. It's like story points that are supposed to be proportional to objective complexity of the task. One could estimate in person weeks, that's not a problem, but estimating in points is like an alternative. Yeah? Fernando?
Yeah, so does your team have a story point definition written down?
Yeah.
So that every team member understands what
Yeah, the question was whether we have a story point definition there. Well, we don't. We don't at the moment. We use currently the basically conversion ratio to our earlier units that we have been using. Yeah, the plan for the next planning season, not the current one, but to the next, is to come up with this definition table and so on. Yeah.
At the epic level, we also have the least probability and the most probable estimate. Does this take into account each task just mean time, or each task even optimistic and less values?
Yeah, the question is about like epic level summaries, yeah, whether they just reflect the expected value, which is like the traditional work, or whether they reflect the whole. What you see now, it reflects everything. Yeah, it reflects really all those three values. It's like a statistical process, sum of random variables. 10 minutes left, so I will proceed with the demo of the execution. Yeah. So what we can do here, actually, I can say in a separate tab in that same web app that the team will deliver certain amount of story points, and there will be some progress. So I choose that that the team works on fixing blockers, and they deliver 2 story points. So I click next. Hopefully it won't crash. And I will refresh the web app. So the not burned down chart, because burned down chart doesn't distinguish between states. Yeah, the not burned down chart basically says that nothing has been delivered yet. Yeah, that's correct. So I continue. Let's say 1.5 story points. The team delivers. Refresh again. Yeah, so it shows that something is in progress, but still not done. So continue 1.5 story points. Yeah, and we have our first task complete. Oh yeah. So what we can see in this not burn down chart is that the burn down is not linear. Why is that so? Because there are like deadlines to those epics, and we don't expect to work on something at certain time, and conversely we expect to work on something else the other time. Yeah, to make it clear, individual epic burn downs look like this. We suppose the upstream release to be finished early, and the downstream release to start a little bit later. All right, so one thing has been finished, and when a task is finished, it already makes sense to talk about velocity of the sprint or in the sprint. So we can see that because one task has been accomplished, then the team at that time, when the task was in progress, had a velocity of the cost of the task divided by how long it took. Yes, so this is like the velocity, measured velocity at that time. I continue with the upstream release. So 1.5 story points, 1 story points, and we have an upstream release done. Yeah, and again, we see that something happening with this kind of burn down, and we also see, yeah, that there is like some velocity increment around the upstream release. Because we have some data regarding the velocity, and we have also some data regarding the size of the task, we can estimate when the task, when everything will be completed. Yeah. So right now, if the team continues like that, it looks like that they will be done somewhere after the second week. Yes. The 95% confidence is before the sprint is supposed to end. And this vertical line is where is the day of the simulation. So I will just click some numbers here to have time for questions. I will put 2 everywhere. Hop, hop, hop. Oh yeah. And the team has delivered everything. They did it fast because I put 2 and there were like 3 weeks, and the total cost was like 18 story points. So that was very comfortable for the team. But this chart gives you some information. Yeah. You can imagine that if there are not 2 epics, but if there are like 10 epics, and the number of tasks in the sprints, which is maybe like not even a month, maybe 3 months long, it can be quite big. This chart gives you an overview whether things are in progress, they are being done or not. At the same time, this velocity plot, of course, when one works on one task only at a time, it looks like teeth, yeah, well, not the very good teeth, so to say. And technically, it's possible to somehow compute the estimated completion based on data. All right. You have seen something, so I guess that's pretty good. Better to give you a couple of minutes for questions, if you have some.
So, have you already done any, you mentioned you implemented this like a couple of months, or have been going for months? Have you stopped and did any exercise to see like your estimations match with what you are actually completing?
Yeah, the question is, we have been using this for a couple of months, which is kind of correct, and whether we have been able to validate that the things kind of match, yeah, the estimations match. So we, as we are using the story points, the only thing you really match is the proportion, right? You measure the capacity based on previous executions. So the only thing that you need to be sure of that you estimate consistently. That's a task which is 2 times more difficult to get roughly 2 times more story points, and so on. So definitely there is, in our concrete case of the team, there is like definitely room to improve. 1 quarter is a little bit better, and the other quarter is a little bit worse, and that's usually a symptom that things are not clear. So we have identified, we have done other mistakes, yeah, like for example, like decomposition of epics, that it was not really matching the execution and making it easy to collaborate. So we are not even in a position to conduct it and hope that it would give like a positive result. Yeah, so we are mainly removing the big problems at the moment, if it answers roughly the question.
So no one answered the question. So this is outputs. The team is doing this. What is the role of because this is output, and what about the outcomes? Something that would come from product owners and product managers. Do you have those? How do they work with you?
Yeah. So we prototype. Yeah. What are the outcomes of using the tool? Yeah, if I summarize, we definitely found out that it has value using during our secondary iterations. Our primary iterations are long, but every 2 weeks we kind of reevaluate, but we don't have any deliverables, so it's mainly internal event. And on those secondary iterations, this tool is undeniably providing good overview of what's going on and whether there are problems that should be addressed. Yeah, this is what really works. It's not so more about 3-point estimations. It's more about like these charts and taking a look and saying, yeah, this doesn't look so well. Mainly decision support. Yeah, the outcome is that it provides a decision support for those interested in completing the work, and also, as I mentioned at the beginning, like there is probably a little bit less friction during the estimation process. And we hope that we'll be able to use this completion projection and to see how whether we are actually slipping or not. So we are out of time technically. I'll be around. The tool, the slides will be online. The tool is open source. It can connect to Jira, whatever, and so on. So you will know what to follow. Yeah. So thank you for your attention, and have a great rest of the conference.
know, right? Okay, hello. I believe we can start. And at the beginning, I would like to share some organizational stuff for you, mainly for the folks in Brno. There will be an after party tonight. You can get your tickets at the noon at the reception. There is also a nice fireworks and drone show at Rigel tonight. So it's also worth not to miss it. And tomorrow, I would like to invite you also to the win-win-win session. It's the last session tomorrow as the closing of DevConf, where you can win some very nice specs. So thank you. And now we will continue with another session. I will hand over the word to our speakers.
Thank you very much, and welcome to our session, How to Contribute to the Ansible Community. We are Anwesha and Carol, and we'll do a brief intro of ourselves. Yeah. So I'm Carol Chen, and I just listed a bunch of dates because I just wanted to show that I have been a Linux user for a while. My first distro was actually Red Hat Linux, not Red Hat Enterprise Linux, but it was it was Red Hat Linux 6 point something. So I actually finally joined Red Hat, one of my dream jobs in 2016. So such an honor to be here. And I started contributing to FOSS projects around 2004. I'm actually a bit hazy on the exact time because I had to check my own LinkedIn page to find out when that was. So, and if I had seen such a talk before that, I probably would have contributed earlier because there's actually many different ways to contribute, not just code. So we'll go into that a bit in the talk. And the rest are just, showing how much of an old geek I am. I started using IRC a long time ago, and nowadays I am on Matrix. Believe it or not, I can learn new tricks. So I joined the Matrix. I actually heard about Matrix in 2016-17, and already signed up for my ID, Matrix ID, like around then. So. Find me on both my work and personal Matrix IDs listed there. And I'm going to hand off to the much younger Anwesha, who, despite her youthfulness, has a lot of open source experience. So don't be deceived. Plus, she has legal chops to back her up. So very powerful combination. But I'll stop talking now and let her continue.
Thank you, Carol. And welcome. Welcome everyone to the talk. Hello, my name is Anwesha Das. I'm a lawyer by education and technologist by passion. I am the one of the newest addition to the Ansible community team. I'm a software engineer at Red Hat. I help free and open source communities around the globe with my technical, legal, and organizational skills. I'm a proud PyLady. I don't know how many of you know about PyLadies over here. I am a PyLadies organizer at PyLady Stockholm, and also I led PyLadies efforts in India. I have a blog, anweshadas.in, where I translate legalese to English, amongst many other things. And I'm a fellow at Python Software Foundation. Wow, I'm representing Red Hat. Amazing. Okay. Okay. I want to share a story with you. It was 2020, during pandemic. I was talking to a friend of mine who is a senior technologist who maintained kernel.org for a decade and who is an ex-Red Hatter. I was curious that what he is doing during pandemic. I was like, what are you doing? And he said that he's Ansibilizing his whole infrastructure. I said, why? I was curious. And he gave me an answer which actually changed the whole perspective for me for Ansible. So he said, if something happens to me, then people will able to understand what and why about my infrastructure. Ansible helps you to think declaratively. The comment indeed was deep, and it's a fact. But thinking declaratively, is it the only feature that makes Ansible cool? Not really. There is a lot of things in the list. Agentless architecture, cross-platform support, easy way of deploying and deploying in the server. So there are like many in the list, and also it enhances the security and mitigates human error and makes so easy. Like I started learning my system administration through Ansible, or like lately in Ansible. So that is how we are pretty cool actually. So no wonder why Ansible is the most popular free and open source automation project. Now, when we are talking about Ansible, we are not talking about a single project. Rather, we are talking about a whole ecosystem. Right now, we have 20+ projects inside Ansible ecosystem. And like every other successful open source project, there are certain things which lies at the very core: open source ethos, collaboration, and community. What is Ansible community? Rather, who are Ansible community? You are Ansible community. We all are Ansible community. Whether you are a user, developer, or people like us who gets paid to work on Ansible, all of us together form the Ansible community. Now, if you are an Ansible community package user, or you use automation platform, or you are a Red Hat partner, you are part of the community. Also, if you contribute via content or code, or if you evangelize and like tell other people how cool Ansible is, you are a part of the community. Ansible is blessed to have a very strong community in regards of contributors. Ansible used to be the 10 most popular open source project in GitHub before 2020, before Ansible core and collection splitted. Now, if we talk about in terms of users, there are millions of the user base is in millions. And when we want to see that how big is our contributors base, let's use this chart. So this proves how big is our contributor base. This is a chart dated April 2023. This shows the contribution like staff versus non-staff. So if we see here, it's 57% of the contribution has been made by the staff, and the rest of it by the community. Now, if we see the unique authors in this set, 184 has been staff, and a staggering number of 4,170 being non-staff. We have used and we have considered PRs and review comments for the last 3 years on GitHub, where we have indexed like 50,000 plus items and covered 376 GitHub repos. Now, is it actually the graph which shows how big is our contributor base? Actually not. We haven't considered the 30,000 plus roles and collections on Galaxy. We are pretty big. Now, are you interested in Ansible, and do you find our ecosystem interesting? And maybe some of you want to start contribution, or you have started your contribution towards Ansible. Let both of us give you certain pointers to that. Like, how can you contribute to Ansible, and anyone and everyone can become a hero in the Ansible land? So, how to become a hero in the Ansible land? There are many options for you. If you want to contribute via code, which is generally, which is a norm, which is the first thing it comes to the mind. Of course, you can. We are a Python shop. Majorly, our code base is in Python. As I mentioned, we are a free and open source project. So, and it is licensed under GPL v3. Now, collections. If you want to share your plugins, your roles and modules, and you think it can be helpful for the community, please come and share it. One of the major reasons why Ansible is so successful and has been adopted by a large number of people is because of its documentation. I am a living proof of that. I have learned Ansible by learning from the documentation. Now, this documentation, our documentation not only describes the tool, rather it gives you certain practical examples, which is very, very helpful. So if documentation is your passion, please join our documentation team. Ansible meetups. So meetups is a place where upstream and downstream, the users and the contributors, the whole community collaborate with each other. We have 139 plus meetup groups and 52,000 plus members all over the globe. Find one and join one of such meetup groups and share your automation journey. If you're interested in web design, currently we are trying to build a website. We are in dire need of website designers, UX and UI. Apart from the need which we have in our Ansible ecosystem, please join our group. Carol is going to tell you more about this in her later part of the talk. And most importantly, run Ansible meetings, share your knowledge, share your user journey, share your stories. This is your chance to give back to the community. Now, in this section, in the next part of our talk, we are going to describe each of these in details, like how can you do that? Like how can you contribute via code? Now, as I said, Ansible is a big ecosystem. So you can ask Anvesha, there are like, it's a big ecosystem. How can I find that which are the spaces I should look for if I want to contribute to Ansible? So these are the spaces you should look for if you want to contribute to Ansible. 3 GitHub organizations and Ansible Galaxy. Then the next question comes, there are so many projects in the Ansible universe. Now, which all are the projects which might be interesting? You might want to go and check our new Ansible ecosystem page where you can find what is the definition and what does each of the project does. I have actually mentioned few of them over here, but you can go and find about all of them in the Ansible ecosystem page. As I said, we are a Python shop, so if you are a Python programmer, please consider contributing to us. You can fix bug or you can report something which might be a problem for you. You don't know, it might be a problem for others as well. So please start contributing by fixing bug or adding a new feature. Now, how to find out like if you want to start contributing, how to find out? So look for these labels, easy fixes and good first start issue. Like easy fixes are the good first start issues. So these are the labels you should look for when you want to start to contribute. Now the next part is Ansible collection. If you want to start contributing to Ansible collection, it is a very good way of like a place to start with. So Ansible collections is what gives Ansible the superpower. And why I say that? Because Ansible, there are thousands of collections, as I mentioned before, and which is maintained by the domain experts, which keeps Ansible ahead in its game and also gives us agility. So if you want to start contributing to collection, it's great. Now, how to do that? There's a link contribute to collections. If you want to contribute to collections, it's a document which will guide you step by step for that. Also, you can upload your collection to galaxy.ansible.com, and there you can share your collections with the bigger audience, with the community. Now, and that is how you can become the guardians of the galaxy. Now, if you want to start contributing to any of these projects, I would strongly recommend you, please do come to our booth and talk to Andre and a majority of the Ansible engineers over here. If you have any questions, you can turn around and talk to Adam and Chad, who are sitting over there, and so please do that. And now Carol is going to tell you what are the other ways you can contribute to.
Wow, thank you, Anwesha. There's so much great information in there. So let's continue. All right, Anwesha already touched a bit on documentation. And one of our main docs person is over at the Ansible booth. He's Don Naro. So if you have any documentation questions, you can go talk to him. And actually, tomorrow we will have a talk at 2 p.m. And it's about some of the progress and things we have worked on this year. And one of the major things is using personas to define user journeys in the documentation website. And Don will be the person who will be at the talk talking about the details. So I'll let him do the honors tomorrow. So please come to the talk if you're interested. Then, oops, my speaker notes. We think about documentation, and sometimes like you're thinking, oh, I'm new to Ansible. How can I help in the documentation? And actually, new users can be great help, because as you go through the documentation to get started, you will probably notice ways to improve, to make things clearer, that some of us who have used Ansible before take for granted. So, if you find some way like, oh, this is actually missing a step, that if it's specified, it will help in the process of learning it, of explaining the steps of using Ansible. So, you can create an issue or a PR to bring that to our attention, to the community's attention, and we can improve the documentation with your help. If you're interested, we have a documentation working group, Dogs, DAWGS, and with a cute doggy mascot there. It's every Tuesday at 1800 UTC, and it's on Matrix at the docs.ansible.com matrix room, which is bridged to the Ansible-Docs IRC channel. And actually, this room is also bridged to a Discord channel, because we actually have a group of writers from Nigeria, I think, yeah, who are also contributing to Ansible Docs. So it's definitely a global, community-wide effort to improve the docs. Similarly, with code, there are some issues you can find in the DocSite repo that are easy fixes that you want to get started with. You can search with these labels to find these issues. And the bit.ly link below, Ansible Docs contrib, outlines the process of how you can create a pull request and submit it, and what information you need to contribute to the documentation repo and improve that. Again, Anwesha has touched a bit on meetups, so I'll mention a bit more about how you can contribute by organizing a meetup. These are great numbers, tens of thousands of meetup members, more than 100 meetup groups. But honestly, not all these meetup groups that we support are active. Partly due to the pandemic, partly due to various reasons. Some people started the meetup group, changed jobs, lost interest, things in life happens, so they may have abandoned it. So please, if you know of a Ansible meetup group in your area, you can go to meetup.com, search for it. If you find it and it's not active, and you're interested to make it active again, come talk to us. If there's no meetup group in your area and you want to start one, also come talk to us. And if you find a meetup group with NC Bull as one of the organizers, that's probably supported by us. So, and also besides meetups, which are more kind of local and regional, sometimes in your different languages, depending on your audience, we also have presence at many major FOSS events, such as this one. So, but as much as our team would like to be everywhere all at once, meeting all of you, we actually depend also on the community, such as you, to represent us, represent the community at events. So I want to give a shout out to Daniel Shire, I think his last name is, who actually did that specifically for Chemnitz Linux Days in Germany. We were not there. He approached us. He said he would like to have a Ansible workshop or a talk or something, and even had a booth. And we sent him some stickers, and he was there just sharing about Ansible community, contributions, the use of joy of using Ansible, and things like that. So, these are little things that, if you have the interest, we want to support you and help you to do things like that. Sure, sometimes, oops. Yeah. Sometimes organizing a meetup, it is a lot of work. Not sometimes, it is a lot of work. But there are ways that, even if you don't have all the time and to do the main organizing, you can help in many different ways. If you have a space for a meetup, you can help to host it. If you don't have time to take care of all the organization, but you have a topic you want to talk about, approach a local organizer and offer to speak at their meetup. And even by attending a meetup, you are contributing, you're helping, because a meetup is nothing without the people, right? Without the audience. So there's many ways that what you can do to make meetups happen and be a part of the community. Another thing we want to mention is we're working on, Anwesha is leading this effort. We're working on a meetup toolkit for organizers. There's like sample emails to find locations, speakers, templates for social media posts, and something to get you started. And of course, this thing will also be open to contributions, because we realize that many different regions have different challenges and variations about how meetups are organized. So you can also, as a meetup organizer, help other organizers to improve their meetups. Oh, and also, one example is if you want to do a presentation on how to contribute to Ansible, we will upload these slides to the schedule shed.com after this. And that if you notice on the first slide, there was a Creative Commons license. So feel free to use these slides and at your next meetup to talk about how to contribute to Ansible. Chatting sounds like a fun, easy way to hang out with people you share common interests with, right? How is that contribution? Well, by chatting with people in the Ansible space, we have a matrix space, space on matrix, similar to the DevConf space that some of you are now in to participate in this event. You can help by answering questions, because a lot of users come on these chat channels to ask questions on basic usage or on contributions, code questions, event questions. So, a lot of you have a lot of great knowledge to share. And even if you don't know everything, well, because I usually don't know, I don't have most of the answers, but I know where to look for the answers. So I help, like, oh, maybe you can talk to Anwesha for this. You can talk to Andre for that. So, you can be the person connecting more people in the community. That's a great way to not just help each other, but also build the community spirit. So what's a community without these strong connections and links to each other, right? So just by chatting is a great way you can contribute. And if you're watching or chatting on Matrix and having questions, we'll hopefully be able to answer them soon. And I'll look at the Matrix room after this talk. Oh, this is actually XKCD comic that, by the way, the slides were put together by Leo Gallego, our teammate. So I actually found this tweet that somebody tweeted to me a while ago, because I used to be a hardcore IRC user. I'm like, I'm going to stay here for life. But I got converted to, and now I'm a main Matrix user, although I do have my 2 accounts bridged to IRC Nix. But anyway, join us on Matrix. So now it's audience participation time. Hopefully you'll be able to scan this QR code. Take out your phones now. Start scanning. I'll give you a couple of minutes. And again, this is because Leo put together this initial set of slides for Red Hat Summit Ansible Community Day last month. So thanks to him for finding a bunch of cute cat pictures. So if you scan it, you find out what I'm talking about. Please vote. And like Leo said, don't just vote for the cutest cat or funniest cat you see, but think about what you might be interested in contributing, or what are your strengths and interests. I'm just going to pause for a while. If there's any questions at this time, we can maybe take one. If not, we can wait till the end. All right. So we've gone through quite a bit of many ways that you can contribute to Ansible project. And there's definitely not an exhaustive list. There's definitely other ways that we have not mentioned. And there are also a couple of things we're working on that gives you more opportunities to contribute in the future. So if you are aware of some of our strategies from the beginning of the year, we talked about how, Ansible, like Anwesha said, Ansible is a large growing project. There's a lot of different sub-projects and different parts of the community. And one of the growing pains is that things can get fragmented. So in order to kind of address this fragmentation, 2 of our kind of main strategic items for this year are to create a new website and to create a new forum. And we've definitely discussed this very thoroughly with the community. We have had meetings and GitHub issue discussions and things like that. So just curious, how many of you here knew that we were working on a new website? Good, thank you. So it's a work in progress. There is a repo that's we're doing this with the community, and you're welcome to join the website working group on Matrix at website.ansible.com. As with website, there's a lot of content that needs to be added, and there's a lot of visual designs that needs to happen to kind of pull everything together. And we have great engineers and writers and stuff like that, but unfortunately we are lacking in some UX, UI designers, people who have that ability to create engagement through through online presence. So if you have that interest, it's an easy way to showcase your talent and also help this Ansible community. So, and as the website launch in phases, there will be additional ways to contribute, like writing blog posts, creating video content, and if you have great ideas, please come talk to us and also join the website working group to share your ideas. The other thing I mentioned is the forum. So it will be based on discourse, and it's just a way, because we have many, how many hundreds of GitHub repos, right? So each of them have discussions and issues, and sometimes it's really hard to find, if you're looking for something specific, to have a central place to find that discussion that's happening. So we hope that this forum will be able to kind of address some of that and pull the community together in one central place that you can share different ideas. And it's almost close to the end, where we're in the finishing race to the finish line here, and hopefully within the next couple of weeks, or at least the next month, we'll be able to share the availability of the forum. It's 99% probably is going to be forum.ansible.com. So once it's confirmed, we will let you know. And please subscribe to the Bullhorn if you haven't already to stay updated of this. So how do you subscribe to the Bullhorn? How do you, follow all these things that we've said? For now, since we don't have the website ready yet, we do have an ansible.com/community page that has the Bullhorn information, has some of the project information, and so in the meantime, please keep your eyes on the page to stay on top of the updates. Once the website's ready, it will definitely be announced there, and you can continue following us and interacting with us on the website and the forum. And if you have any questions and want to reach out to us directly, of course, Matrix is one thing, Ansible Space, and also ansible-community@redhat.com is another way to reach our whole team directly. And speaking of the whole team, Anwesha, would you like to tell us about this?
Okay, Carol and I might be present over here, but this is a work of all these wonderful people. Carol and I also included in those list of wonderful people though. But you can see many of them in our booth, and some of them who are part, as I said, of the bigger Ansible ecosystem will be there in our booth as well. So please join us in our booth and if you have questions, we love to be interrupted. And so whenever you find us, grab us and ask whatever you want to ask about Ansible. So here is our wonderful team. So this slide, as Carol has been mentioned a couple of times, has been made by this person with a red hat, Leo, and thank you, Leo, for that. And many of the questions which we said in this talk, answered in this talk, has been answered by them. We are just echoing their thoughts. So thank you, our team.
One more.
So every project, as we were discussing, every project advances and progresses. And it is very essential that we work on the core of that project. What is the thing what we are working for? The mission statement. So we are working for our mission statement. If you can go to this QR code, and we are having a feedback, we want your feedback, we need your feedback from for describing and having our new mission statement for Ansible. Please consider giving a feedback over there. We would really appreciate it. And with that, do we want to say thank you?
Of course, we want to say thank you, but before that, any questions from here or online, perhaps? No. Thank you very much. And again, if you haven't scanned the QR code, it will be available at the booth as well. Please come talk to us. We would love to hear from you. Enjoy the rest of DevConf. Thank you so much.
Thank you so much. Thank you.
They can try it.
हेलो वो करेंगे अभी मैं तो hey check good.
Hello? Hello?
Thank you. Yeah, hi all, good morning. Thanks for coming and attending this talk. Today we will explain you how program and tester can be productive. So in this we will share our experience. Like me and Nancy, we are working from last 9 to 10 years on multiple projects. So we face a couple of challenges. We like what are the things we are doing, like what are the principles we follow so that everything will be on the time and we deliver the good product. Okay, so mostly like we will share our experience in this. And let me introduce myself. I'm Anush Singla, working as a principal software engineer in Red Hat. So mostly I work on the front end technologies. And like apart from my work, I also share my knowledge and educate to the people on the YouTube.
Good morning, everyone. I'm Nancy Chen. I'm Quality Engineering Manager at Red Hat, and I have over 11 years of experience in quality, software quality. And as a QE manager, so me and my team, we both are responsible for overseeing the development and implementation of quality control processes, and we make sure that our products reach highest quality and standards. So that's my quick introduction. Now Anuj will going to talk about like what we will going to discuss today, along with why we choose this topic.
Okay, thanks Nancy. Okay, so today our agenda is why did we choose this topic? What are the top 5 conflicts and how do we resolve these problems, and collaboration between developer and tester when the developer and tester collaborate with each other, and the couple of case study like we follow in our projects, and the couple of suggestions from our side, and then Q&A. Okay, so now why did we choose this topic? Like the developer and tester collaboration is very important. Okay, so we need to work together, and if they are working together, definitely the productivity will increase and the customer satisfaction will also increase. Like if we say in 1990 or before the agile, the waterfall model was used. So in that, like developer and tester has very less collaborations. So like I didn't get a chance to work on the waterfall model, but one of my friend Deepak Kohl, he has shared some experience with me because he has worked on that. So at that time, like the tester and developer, like tester is working in the end and the developer working in the starting. So in that, like once the requirement comes, so there is one SRS document is prepared on that time. So one is shared with the developer, one is shared with the tester. So there was very less communication between them, and the tester is working on like as per the SRS document, they working on their use cases. But take example like if in the end the tester is testing the bug, testing all the product, and some critical bugs is found, then maybe it requires some infrastructure change. Okay, so at that time it was very difficult to make the changes because tester is already testing in the end, and it will delay the productivity or delay the production. Okay, so that's why like the agile process come, and in the agile like everything is on the collaborating, and we are working on the sprint. Like we follow every 4th week, we deploy our changes to the production, and there are a lot of meetings is going on, retrospective, stand up or grooming meetings. So it helps to grow and deliver our product on time.
So before I jump to the top 5 conflicts, I would like to ask a quick question to our audience. You guys might work with the different development teams or might be like interacted with the QE team and program teams. So as per your experience, what do you think? What are the reasons which creates conflicts between programmer and tester? Anybody in the audience? Yes?
Maybe the scenario like, where do you see that feature? It's a bug that maybe leads to miscommunication and short deadline between the release that we, so.
Yeah, right. I totally agree with your answer. Miscommunication, some like pressure on the releasing, because like we always have some deadlines where we need to like release our changes to the production. So if that's the reason, like miscommunication, time constraint, pressure, so what do you think, like how does this impact team's efficiency and productivity? Anyone? Yeah, please.
For developers, it's very hard because when you write code, it is sometimes very, very long. And when you try to test it, it was every time only one error. You fix this one error, and 2 lines down, you have another error. But you will not see that this error is multiple times in the same code.
True, you are right. So yeah, so the question is, how does this impact the team's efficiency and productivity? And she said, like, yeah, so we sometimes happens, right? We found some bug, then we tested, then again, it's kind of a loop, right? And do you agree, like, it will create some kind of environment where, like we feel like it increase a lot of errors, right? And along with, like, it also impact the overall job satisfaction, associate morale. Why? Because we have that kind of, like, because these two teams have conflicts. So, these are the 5 top causes which, like, conflicts, which I feel, as per my experience working with different teams. So it's not accurate to say, like, testers and programmers can never become productive or friends, but yeah, there are few challenges, there are few scenarios or situations where the relationship impacted because of the challenges. So the first one is competing goals. So, you know, like when it comes to the programmer, so programmers and testers both have different goals and priorities, and as per their job, right? And programmers are mostly focused on delivering and developing the software, and on the other side, testers are mostly work on like testing finding the bugs and make sure that, like, their software reach the highest quality. So I will take a quick example of, like, how this works, like quality versus delivery, bug-free versus functionality, functional software. So let's take an example. Tester usually they try to find bugs as much as possible, and aiming that, like, we will going to have a bug-free software. And but on the other side, programmer really wanted to have, like, release the changes on production as quickly as possible. If that's the case, if they found some bug, the tester said, like, okay, we have one bug which is related to UI and UX, like some font or some alignment is not good because they are prioritizing the customer satisfaction priority. But when it comes to the programmer, they said, like, we can take it that later. Let's work on the quickly release. So here the conflicts arise. So next one is blame game. So that is very common, blame game. So what it means, here I will also give you a real-time example about new feature testing. So when it comes to the new work, like, we already have existing system and we are just adding a new feature in the system. So what testers usually do, they pick that chunk and test. So when it comes to the new feature testing, we also need to test the regression part. So regression is nothing but where you're checking that with these new changes, there is no impact the existing functionality, which is very, very important. And if they found some regression and they're reaching out to the programmer saying that that's a regression, they might argue with, no, that's not, it's not the part of, you need to focus on the new feature. Why you are going to the regression? And I'm sure this is not because of my change. So that's kind of argument, it's very common. So the third one is communication gap. So I like that's a very major point. Communication gaps happen, like tester found bug, they write the bugs, they log the bugs in the different technique mechanisms. We have Jira, Bugzilla, and sometimes happen, like, they not explained each and every details and information. So how this will impact, programmer pick that bug and they're unable to address what's the problem because they're not able to, they're saying, like, it's not working on my machine, right? That's again very common. So conflict arise because they say testers haven't shared the exact steps to reproduce so that they can work on the solution. So here, the again conflict arises when like they don't know, and due to the lack of the information, it delays to the resolution. So then the last one is, the another one is limited interaction. So limited interaction is basically depending on team structure, depending on the project. So there may be the high chances both programmer and tester teams got let very minimum chances to interact. And if they are not interacting, how they will going to understand the end-to-end business strategy behind the work they are working on. So they might work on a silo basis. If they are working on a silo mode, so there are high chances they have a minimum opportunity to connect. So again, limited interaction also create conflicts. Time conflicts. Time conflict, both roles have a totally different priorities and goals, which we need to think. And when I already explained, like when it comes to the programmer, they mostly focus on delivering the things, be on time. And when it comes to quality engineer, there may be a chance for, they ask for like, okay, we are not ready, we are not confident to give the acknowledgement to release the things. And they need extra time. So they again conflict arise because tester needs more time to release. So these are the top 5 causes like which creates conflict as per my experience. And this is very basic scenario you guys can like relate, like where developer and tester, like tester is saying it's working on my machine, and developer no it's not working, you are wrong somewhere. And the another image is saying like, okay, tester is giving a bug to the developer, and developer is saying no, it's not a bug, it's a feature, it's an improvement. So yeah, so this is how it works. Now how we can solve coming through these points, a developer, I think it will create a more impact. So Anuj.
Yeah, so Nancy has shared like couple of problems. There are a lot of problems between developer and tester. Now we will see how we will solve these types of problem. And like as per me, like developer testers should be friends. They sit together. Like after the COVID, it's not possible. Maybe we are not going office, but at least we should go office, contribute, collaborate with each other. Okay. Yeah. So like the first step is supportive language. Always support your tester or developer. Okay, so like take example, if tester is find some last minute bugs, okay, so don't blame them. What are you doing, man? Why you didn't find in the starting? Why you are coming in the end? At least thanks them. At least we find that bug before the production. Or if the customer come up with that bug, it will create a negative impact. So always support them. Second way, and okay, and one of James Bass, there is a testing guru who tell always like tester don't hate developers. And it's like means the wife tell to her husband before going out, if there is some stain on his shirt, so he will not feel embarrassed, something like that. So developer and tester roles should be productive, should be friends. They know each other. They know their strength and weaknesses. Or take example one more, like if the tester is not able to reproduce an issue, but help them to reproduce the issue, give some system logs, because as a developer we know what are the input. If we provide that input, maybe it reproduces the issue. So provide that information so that they find the issue and they can log the issue. Okay. So second one is defect triage meeting. So we follow this like every week. The bugs will come from any places, like the tester, from developer, from multiple places, from customer also. So every week we do one meeting. In that meeting we discuss what is the priority, either it's a bug or not, or what are the solution. The basic things we just provide that in the ticket also, and the story points also, like the difficulty level of that bugs. And the code freeze, it's very important, guys. Means if we, like tester is a human. He don't test each and every part of the app. Okay, so if we are pushing our code till the end, like we have the production which tomorrow and we are pushing our code till now, then how the tester will test each and every part? Because they need to test a regression like each and every part. Like right now we have the automation, we can do it, but still we need to do some manual testing also. And like what we follow is we have the every 4 weeks we do our production push. So 3 weeks we are pushing our changes to the in the testing environment. Last week we give full week to the tester to test each and every part, but we give, like if they find any critical issue, just we fix that issue and push on the testing environment. Apart from this, full week we give to the tester to do it. And next one is a resource alignment. Like in IT world, resource alignment, resource currency is very normal. Like somebody is joining the company, somebody is leaving the company, okay. And the most standard ratio for developer and tester is like 3:1, or as per the product, as per their experience. But mostly this is the standard ratio. So sometime if there's some resource crunch, so always like as a tester as a developer push less code in the production or in the testing environment, so that they will get a time to test the things, or like help them, like as a developer we can test other developer code, or the second one is also test our code. So we are also follow these things. Sometime is we have the little bit crunch in the resource.
So as a part of resource alignment, I would also like to the resource balance in the both development QE ratio is very important. Why? Because of like if we don't have a balanced team, like for example, we have five QEs on one developer. Not good, right? And on the other, like vice versa, 5 developers, 1 QE, there's a lot of pressure. There's a lot of pressure to work on the things. So being like as a QE manager, I always sit together with the project team and decide like how the ratio should be. So when we are talking about the industry ratio, about the dev versus QE, it should be like either 3:1 and 2:1, depending on the project, the complexity of the project, the timelines, and the like what we committed to our stakeholders.
So always like don't go to your manager, we have a crunch, and just we need to help, like manager can't do anything, right? We have the crunch, so we need to manage ourselves. Okay, and the pair program and testing, like I follow this one. Like I always try to share my knowledge, architecture knowledge with the tester, because if we share our knowledge, definitely they will not come with the small bugs like the data issue, or some if some field is not showing in the UI, then they will not come to us. They analyze from their own self if we share our knowledge with them. Or they can directly ping to the backend team, I'm not able to see this field, please take a look. So it saves a lot of time between developer and testers. Yeah. So now we have seen like how we will solve these problems. Now at what time the developer and tester collaborate more each other. Okay. So like the shift left testing, and in the shift left testing, like always try to involve the tester in the initial phase, so that like once the requirement comes, so we analyze, we figure out, okay, how we will deliver that product. So at that time, if we involve our tester, then like tester is feel like a customer. Okay, they think like a customer, how the customer will use this product. So in this way, if they provide their suggestion, then as a developer, when we are designing our architecture, then they share our knowledge. Okay, and we use their knowledge, we use their use cases while designing the product or while designing any feature. So it helps, like, and if we are thinking like all the scenario in the starting, then it will definitely help us to grow in the future also if the new things come. And defect reporting and resolution, it's a normal thing. Like always developers say, I'm not able to reproduce this issue. So like when the tester is reporting the bug, then definitely provide all the things, like attach the video, attach the screenshot, provide the proper steps, so that like when the developer start working on this, he has some information. Okay, so I need to do these things, and I'm able to reproduce this issue. At least he will not come to the tester, oh man, I'm not able to reproduce this issue, what can I do with that? So it saves a lot of time between developer and tester. Okay, so next one is resolution, recognition and appreciation. So like in Red Hat, we always recognize anybody if somebody help us. Like in Red Hat, we give some reward points, and thank you note, so that the next person will feel satisfied, like he help us and we recognize him, something like that.
Yeah, so now we will going to discuss about the different case studies. So before I will discuss the case study, I would just like to call, like, these case studies are the result. We are actually actively, these are the real-time scenarios which we are actually using in our teams with the help and collaboration from like our development team along with the program team. So the first one is, Okay, the first one is implementing a CI/CD pipeline, which result improving the software quality. So I will going to, as a part of this case study, I will going to discuss like how these two roles actually helps, like how the tester can help the development team during the development phase. So the first one is like you can see like how usually developers works. So developer build the work, they usually work on the requirements they build, and so how the team testers can contribute during the building or during the development phase with programmers. They can like add a automation suite. So automation suite is nothing but it's a smoke suite which gives us a confidence like the basic functionality or basic critical functionality of the software is working fine. So what we will do, we will here like when the developer is building their code, before like merging into the master branch, at that time we will integrate our automation suite with the unit test. So along with the unit test, our automation suite will going to run. If it's working fine, like the basic functionality which we added in a suite is working fine, it will ready to go with the merge request. Otherwise, it will detect the problem and share the report with the developer. So that in the early phase, developer can take a look what are the problem, or you can consider what are the regression with this new change, and it will be also solve the time tester. They no need to like much worry about the basic scenario because we have already tested as a part of the building process. So the next one which we have is like cross-functional collaboration for comprehensive testing. So comprehensive testing is very important. Why? Because we in Agile module, like we do like quick changes, move that changes to the production. So how we can achieve cross-functional collaboration? So we usually conduct the bug bash. So bug bash is the event where like we invite different teams, different representatives from the development team, program team, as well as different QE teams. So they keep their normal, they set aside their normal jobs for some time, and they start testing on a piece of the thing which we are planned to release. So for that, we can take an example of an e-commerce site which they are planning to release a major changes in the production. So we will conduct a bug bash event where we are like a representative from the development team, QE team come together and doing random testing to make sure that like to find the bugs or testing different scenario. For example, shopping cart workflow, payment workflow, to make sure that like we like give a cover all the scenarios related to the UAT. So at the end of this event, what we will do, we will call out few winners on the basis of the defect quality, their severity, and like and the details which they have shared. So it could be like every organization have some mechanism to appreciate their resources. It could be rewards points, it could be some gifts. So this is how you can encourage the cross-functional collaboration. So the next case study we have is about the actively participation of feedback loop, like how you can involve tester in during the feedback loop. So customer satisfaction is very, very important when it comes to the software development. And if we act on the customer feedback on timely basis, we can increase the overall customer satisfaction as well as the product quality. And as you know, testers, QEs are known as a customer advocate. And if we are involving them, it will definitely going to have a very good impact on the like as a feedback. So let's say here, let's take example. Every team, every software had their different mechanism to gather the customer feedback. It could be an email directly, it could be a form attached on the system, it could be a account TAM who connects with the customer and customer directly share the details. So we gather all the feedback in a one place, and we usually have a monthly based meetings where we discuss the overall feedback which we receive. Now on the basis of like then developers and tester both contribute and share like what are the things which you need to prioritize. So we log the tickets in our ticketing mechanism, and testers start working on it. On the parallel side, development will going to work on the fixing the things, and tester will start working on the test plans, and then they will deploy test and inform the customer like, okay, these are the feedback we receive and we fix this and now it's ready to use. So this is how tester can also contribute as a part of feedback loop. So I'll hand over to Anuj to talk about the overall development and build work.
Okay, so Nancy has said like all the three principles which we follow. Guys, if you are not follow, try to follow these things. Like the CI/CD, it's very important. like means before pushing our code changes, we try to like test the thing so it will not create a regression. So we follow this same feedback loop is very important. We follow these things. Okay. So now we will discuss like how we build and deploy the features. Okay. So this is a full diagram I try to make and try to explain you guys. So how we are doing, so how we are involving different people like the tester, developer, UX engineer, or the PM level. Okay. So like the first one is requirement. So requirement come from many places, PM level, analytics level, or the customer. Okay. So after that, like we analyze the requirements. So in that like all the team members like who are tester, developer, UX engineer, or the PM level managers, everybody is there. So in that we decide, okay, either we need to do these things or not. Okay, we are doing these things, then what is the priority of that, or how the customer will use these features. So the tester is giving their suggestion, they think like a customer, and then like as a developer we think, okay, so either it's possible or not, or the backend team also decide, okay, so how we will deliver or how we will give to the UI. There's some, if we need some backend support or some data from the backend. So in this way, like we analyze each and every part. So once we figure out, okay, then we go for the build the feature. The UX will give us the UX design, and then we build the feature. And after that, we like the tester test the things, and like in the testing phase, we are also helping the as a developer, we also help the tester to test the things, share our knowledge, and then after that, like the customer demo. So after that, like before going to the production, we give the customer demo, and like if it's a critical feature or the new feature, we give some UAT, like give some pre-prod environments and give some URL so that they can do some UAT testing, and then after that, like deploy the features, and we continuously take a feedback from the customer. It's very important. So like in this way, like we try to build our product and try to build the quality and improve the quality and all things. We follow this role. Okay, so guys, like these are the couple of suggestions from our side to all. Okay, so try to build a network with all the tester and developer. Means try to go for offline meetup, try to go for conferences. Like I'm here, so I meet a lot of people. Like in this way, like we get to know, okay, how the people other people are using the technology, different products and all things. So continuous learning, like it's a very difficult, like as I'm a front-end developer, every day coming new things, the new library come, like there are a lot of framework in the UI. So it's very difficult to learn the new things or continuously learning, but try to update whatever tool you are using, try to think, okay, maybe means try to, the new feature is come, try to think about, okay, the new feature come, learn the new things. So it's always like, always try to update yourself. And be kind in stress. So like in IT, the stress out is a normal thing, right? So we have a lot of works to do, and but try to come out, take a break. It's always a good thing. Don't starting blaming. Just take a break. It's a best thing. Or take a feedback in a positive way. I always follow these things, so I try to take a feedback from multiple people. If somebody give you the negative feedback, take it as a positive, because thanks them. At least he gave you the negative feedback and he finds something bad in you. Try to improve that, and definitely in the end you will feel yourself as a positive way. Yeah, make personal brand. Means I follow this rule. Means try to write a blogs. Like I try to educate via YouTube. So related to web development, but means try to do these things, and means it help you, if it helps a lot, means definitely.
Okay, so with this quote we will wrap up our talk. So the quote means that testers and programmers should work together rather than, or instead of like competing with each other. By sharing and collaborating their knowledge, their skills, they can create a better and productive or good product. So thank you. Any questions?
I have a question on slide number 13.
13?
Yeah.
Wait a minute. Yeah.
So my question is like, I see that you deploy the quality during the first 3 phases, what about when you merge the code and we deploy the code, how do you ensure that the quality is maintained? Is there any quality feature step as well, David?
Okay, so the question is like how you are maintaining the quality while pushing the changes, right, on the QA. Okay, so like this is diagram. If you see here, what we are doing is when we are merging our changes, okay, when we are create our MR, okay, so in that time, once build the code, everything is fine, then we run this unit test and the automation test. So tester give us one URL, like tester also doing like running their automation test, right? So in the GitLab, we are also running their unit test on our GitLab. So in this way, like suppose you have make one button change, okay, so we are 100% sure this button will not create any regression, at least in the existing or the critical functionality. Or the unit test, we are also follow this rule, like every time we try to write the unit test, otherwise we don't merge any code. So this is like we follow this rule, and in this way, like once everything, like at least the existing functionality is working fine, then we go for the merge request and then deploy to the testing environment. And then tester will also do their own testing, manual or whatever they want to do, and after that we go for the production. So this is way like we follow. And if you see here in the red sign, a problem detected in the unit test, like if there is some issue in while running our changes, then we go to the developer will take a look. It's either because of me or there is some issue in the other unit test or the automation test. So we connect with the tester, and in this way, like we follow this rule.
So as of like in this section, like, you know, like when we execute our automation run, right, we do have some report which explain like what are the things is not going well. So developers can take a look, because we have already shared all the workflow and all the framework with them, along with their like integration with the unit test report.
Thank you.
Yep.
Thank you very much for the talk, super interesting. I thought that the challenges that you presented were very much on point. And my question would be, how can you actively promote this collaboration culture and like nurture this collaboration mindset between developers and testers when things are a bit rough? Like, how do you actually start being proactive in overcoming this challenge?
Okay, the question here is like how we spread this collaboration across teams, because there are high chances there are teams which not following this, right? So, you know, like we usually have a flow where we have a QE team, or development team, and programmer team. So we usually have one monthly or twice in a quarterly meetings with the leads. So over there, we usually have a bi-directional discussion and feedback on the QE team as well as development. So like as a QE manager, I have one-on-one with my team members, right, to see if they do have any feedback for the developers, because they're open to share, like they can share the feedback if they are facing any challenges. So they discuss with me, and because I don't want like their developers and QEs directly have some relationship conflicts. So I act as a manager, act as a moderator, and they connect with the development manager as well as program manager to make sure like this is what we are facing, like how we can fix, how we can fill this gap, and vice versa. If development manager have any feedback like, okay, we have a resource crunch, or last release we got a critical bug on production, so how we can like improve this in a better way. So being a leader, so we discuss internally and make sure that like it should be a bi-directional call. So we usually keep like, I usually follow the monthly connect. Why? Because we usually you follow the agile and or Kanban, which has a like 3 week sprint or 2 week sprint. So this is how we usually work.
And second way, like we have the retrospective meeting. Okay, so if something is not going good, so we discuss in that retrospective and discuss, like provide some points and action item also. We follow that. Okay, so we will take care in the next time. Okay, so like first time mistake is a normal thing, but if you are repeating the things, that's a bad thing. So so the retrospective is a good thing, and we have the weekly grooming meeting, daily stand-ups. So we follow these things, and at least like we are maintaining the quality and all things. Yeah.
So you also have this? Anyone else? I think you were raising your hand.
Okay.
Anyone in the back? Anyone? Any other question?
I do have another question. Yeah. You mentioned also pair programming, like pair programming. Yeah. You also mentioned testing, like pairing testing sessions. How would you approach that? How do you approach that?
Okay, so I will share my experience, maybe Anuj will share. So the question here is like how we can encourage peer programming or peer testing. So I'll give you few years back, me and Anuj were in one team, and just like before the release, I found very critical bug. And when I found like, it's like I think within a few hours we were supposed to release, I was just doing the smoke testing. And when I informed Anuj said, okay, Nancy, come at my desk, I'll show you what is going on. So he explained me the code, like Nancy, and he told me like, Nancy, you sit and you fix it. I was like, how I can fix it? That's your job. So he said like, it's just a mistake of full stop. We missed that is why it's a blocker is coming. So I sit on his desk, he explained me the whole code, and I fixed that bug. So this is how you can encourage. So if it's coming, like if developers should like explain like how, there are very small tips, like we also encourage that culture in a team, like they explain like how the console and how the network logs tester can understand, right? So because if there's something is failing without directly logging a bug, what we usually do, which firstly check console, is there any errors going on? Is there any, what's the network logs? Because there may be a chance it could be a internet issue, right? It's you have a like network connection problem, that is why it's failing. So just like learning these things and collaborating with developers, it helps a lot. So yeah.
Okay, so I follow this thing, like I always share my knowledge. Okay, so somebody tester come up, I'm not able to see this field. I ask him, have you think about this? Why you are not able to see these things? So have you checked the network call, or are you getting any console error? So he think like this, and then I explain him, okay, we are doing some these things, and that's why you are getting this issue. So at least in the future, he will not come up with the same question. And the second way we like every month we have the one guild meeting. So in that meeting, like everybody share their own experience. So like if somebody did something good, so like in that meeting he explained, okay, I did these things, and everybody is in that meeting, like the developer, tester. So this is also the second way we follow these things. And the third way, we try to automation test, right? So we help them. Maybe I have some bandwidth, 1 day or 5 hours, 10 hours, then we told them, okay, could you please give us one automation test? Maybe I help you. Or we review their code also. They review our code, but sometimes they are not able to do, but we ask them, okay, is there any scenario is pending from our side? So we can write the unit test for that, so that it will not come up with because they think like a customer. They have a lot of scenario. We don't think like that, right? And in this way, like always help them to decide the framework, which framework is good, and what are the benefits if you are doing these things, best practices. There are a lot of things like we follow. This is just my suggestion, guys. Yeah. Thank you.
Thank you.
If you want to discuss more, we will discuss offline. Yeah.
improve.
I don't know where my actual screen is relative to that or that one. Okay, there. It's decided that that one's the screen it wants to put things on. It's all right. Yeah, hold on, I'll put it. Yeah, and then my it's not a race. Okay, and now.
Okay, hello. Welcome to our next session, this time with Matthew. At first, I would like to say a few of reminders. One is, please do not forget to pick up your tickets to our after party, DevConf party. They are at the reception for you. And also, I would like to remind that tomorrow's win-win-win session with a lot of swag, so this might be also something you do not want to miss. And now, please, Matthew.
Thank you. Okay, welcome to 35 Fedora releases in about 30 minutes. I have timed this talk and gotten it in 30 minutes, but I have to talk really fast. So I asked for more time here so that I could talk a little bit more slowly. I still will try and go very fast. It won't be comprehensive even with that, but we should have ability to hit some important highlights in the history of the Fedora project and some questions after. And I think hopefully this will be fun for people who have gone through all of this, informative to people who are newer in the project and or just interested. And I think there are some lessons that we've learned along the way that hopefully we can not repeat our own mistakes and we can maybe other people can learn from them. Dan, all heckling should go later at the end of the talk.
Which re-releases you're not covering in the talk?
I have a slide on that later. You'll yeah, as I said, heckling should be saved for the end. Okay. This is me. No time to explain. If you don't know me, come talk to me later. I'll be happy to. But you know, I'm from the internet and stuff. I have 85 slides here, so I'm going to try and get through them. There's a whole bunch of stuff about the history of Red Hat Linux and the split to RHEL and all of that. That's a whole nother talk, somebody else's talk. I wasn't there for the behind the scenes, so this is going to start with Fedora Core 1. This is the basic format of the slides, release name and number at the top, a little bits of information around. Since I'm showcasing like the desktop wallpaper over here, it's kind of a visual focus on things. Desktop's always been important to Fedora, but it isn't the only case. A lot of people are using Fedora for server use cases, for other things, for IoT on small devices. There's a lot of non-desktop cases as well, so this shouldn't be left out, but there's the visual flair of the wallpaper, so that's kind of a big thing. I have the kernel version over here, and things like that, system, like which init system is there, kind of to put some technical things in there. The actual number, like that's not important. Over here in events, that's our big headline events. We've always had a lot of different smaller events in Fedora as well. Those aren't listed. Fedora Activity Days, Fedora Women's Day, that kind of thing. And then I also have most active on the devel list. That's kind of a way to kind of get some people's names up on the screen. You may recognize some of those names as we go through. That doesn't necessarily mean that's the most productive person that release, but sometimes it is. And there are also obviously a lot of quieter people who've done lots of work who don't get shown up here, and a lot of people who deserve credit. I also put the Fedora project leader's name up there, which means my name will show up a lot. Doesn't mean I am the most important person, but I get to be the face of things, so there it is. Here at the bottom, I have from some of my metrics the release popularity over time. It's a little bit of a spoiler here, but we'll go through that as we go. And then some pop culture things there just for reference as well. All right, I'm going to take a sip of water because here we go. So you have flowers in a pond here, nice quiet beginning for the background here. So this is Fedora Core 1, and it was really basically what would have been Red Hat Linux 10 if that had been produced. So it was basically made entirely inside Red Hat with the same mechanisms. It wasn't really a community release. It was open source, but all developed internally. It's basically just the name Fedora Core put on what would have been a pretty nice Fedora Red Hat Linux release. And then there was extras, which were a collection of add-ons that you could basically put on top of it. And that was like that. The community was welcome to maintain these extras on top of that. But actually, during this release, a really important key thing happened, which I think kind of set the tone for the project overall. So AMD 64-bit extensions for Intel architecture were brand new, and it was kind of a server class like enterprise feature, and so Red Hat was thinking that'll be a differentiator. RHEL will have 64-bit, Fedora will be 32-bit, and people will obviously want to pay for that distinction. There was a lot of worry about how people will understand like why to pay for RHEL, why it's different from Fedora at the time, so they were really looking for these differentiators. But then someone in the community, actually Justin Forbes, who's still kernel maintainer in Fedora now, went and just, working from under his desk in Texas, I think, went and just rebuilt everything for x86-64, built a version of it. And so I wasn't there, I didn't work for Red Hat at the time, but as I understand it, this caused a lot of people were unsure what to do. Should this be allowed? Should anything, should we say anything about it or whatever? But eventually, the decision from Red Hat was, okay, well, look, this Fedora community people are doing this. We should accept this, and so it actually became part of. It actually officially released at some point as x64-bit version of Fedora. And I think that kind of set things both for multiple different architectures and just for the Fedora community as an independent, not just the community doing add-ons, but something can actually make fundamental change in the project. And that was a really key early thing. Also, I want to point out the logo here, which is a little red hat thing, which is funny to me because we're not supposed to use hats in Fedora for, again, that differentiator reason, which is funny because, Fedora. And also, it looks like Red Hat's new logo that they, after much expense, changed the Shadow Man thing back to this little icon here. So the next one, Tetnang. There's a complicated process by which these names are derived, and they have to relate to the other one. And I've explained up at the top what the connection theoretically is there. This is basically another, like what would have been a Red Hat Linux release. It actually looks very much the same. There were some important technical changes under the hood. Had the 2.6 kernel. Back then that was a big jump. And SE Linux was enabled. Dan Walsh is here in the corner. He can do a talk about that. Right, I actually have in my notes, that's a whole nother talk, and Dan Walsh is the one for that talk. But yeah, the big question here is, what does this community stuff mean? Is it like, how involved is the community here? And so actually a lot of people talked to me about this IRC, like it was actually an email mimicking a chat log here that Mr. Icon, Konstantin Rubetsev, sort of sent to show, like, this is how people are feeling. Red Hatters don't seem to get it, but like it doesn't really, we don't know how the community is going to engage here. So yeah, in the release announcement here, like it's kind of presented by Red Hat here. It isn't quite clear what the open source community as executive producer, it says in the release announcement. Like, what does this mean? So yeah, from the outside, as a community member who was interested in this stuff, it was all pretty frustrating. People who are involved in CentOS and seeing CentOS stream and Red Hat's communication struggles with that may experience some deja vu with this. It's the same kind of thing in a lot of ways. Okay, so FC3. This one's a little bit of progress. It says in the release announcement, I have the release announcement up there. Nope, I don't. But it says the Fedora project and Red Hat would like to announce, rather than Red Hat announcing. But the core is really still an all of a Red Hat thing. There were some things happening. The Fedora extras, the add-ons, were actually now, you could get them from the same download server. It wasn't a whole different thing. There wasn't actually a central build system. The build system was you would send your spec file to Seth Vidal, and he would build it for you and then put it there. But things are happening. There's like 4 times as many packages in extras as there were before. So people were kind of coming together and working on that. Then FC4, same wallpaper. It's the only time we've ever duplicated the wallpaper, and it's kind of a boring wallpaper too. So oh well. This release was, I think, the worst, probably the worst ever. It took forever to show up, and SE Linux was in a horrible state. It wasn't usable. It was very frustrating. Reviews were like, this is all about features, and no one cares about stability. This is all the. It was probably all true. Also, the release engineering process wasn't very good, and actually there were changes like midway through this long thing, which meant that you couldn't install it anymore. You had to install the original one and then do a bunch of updates. Like, it was a whole horrible thing. But there was a lot of exciting community things going on. I may be biased here because I personally helped organize the first Fedora conference, the Fedora User and Developer Conference in Boston. And I think that was actually, again, I'm biased, but I really think that was an important turning point because it was a lot of Red Hat people came and a lot of people who weren't Red Hatters, and it all felt collaborative and friendly and fun, and there was no like Red Hatters telling people what was going on. It was Red Hat engineers talking to other people in the community and trying to figure out and deciding what we're going to do, and people in the community presenting about how they wanted it to go, and it kind of felt exciting and collaborative. So that was a really, really nice moment there, I think. I'm really fond of this background. I don't know, I'm not a graphic designer, but I looked at this and I'm like, oh, look how fancy that is. It's so, I don't know, somebody who is an artist made this one. An artist made the other ones too, that's not fair. But so graphic designery, I guess. I like it. So the big news with this release really is a story about Yum, which the precursor to DNF, now the Meta package manager. So before this, in the olden days, like there was just RPM, and if you wanted to update your system, you basically had to download a bunch of packages and hope you got all the dependencies, and it was a whole mess. So there were some tools that you developed to do that, and Red Hat had a huge investment in a thing called Red Hat Network and UpToDate, which I think was just discontinued like several years ago. But it was supposed to be, like, this was going to be, again, a monetization thing. This was going to be the product, and they put a lot of effort into it. And then meanwhile, people, Seth Vidal took this thing, an open source project and put it into Fedora that did this idea of, rather than just having to download themselves, it would actually like figure out what you needed to do an update and retrieve all of the things and get them from the mirrors and do it in a kind of a nice polished way. So you could actually you just run an update and it would update your system. It was amazing. And so again, as I understand it, there was some inside Red Hat like consternation about this. Should we allow this thing? What should we do with it? It got put into Fedora, and then eventually Red Hat realized, okay, this is actually better than the thing we have tried to develop internally, and it ended up going into RHEL and being the update system for RHEL as well, which was a huge kind of thing as well. There was a letting go of the not invented here mentality and say, okay, like the innovation can come from the community. It doesn't have to be something that we've designed at Red Hat. Even if it was something that was like contrary to where we thought we were going with our business plans, we're going to take a leap with this and figure out how to work with it. So that was really important. Although still, like Red Hat has this director control, I think in the release announcement, that may have talked about that kind of thing again. All the decisions for engineering, those were Red Hat internal decisions made kind of, I don't know, I imagine some sort of shadowy back room, but actually not. One funny thing happened here when this release came out, that all the Fedora systems were on the same network as Red Hat. Red Hat was a small company at the time, and the release was on like an end of quarter, some sort of important business day, and all the downloads for this totally broke the network and ruined everything. And Mike McGrath tells the story better than I can. Mike McGrath is now the VP of Linux or something, maybe even fancier title than that now. Big Cheese, says Dan. Yeah, and at the time he was the Fedora infrastructure lead, but he didn't work for Red Hat. He was a community volunteer. He worked for a different company in Chicago, and he was, the main sysadmin. And the CEO of Red Hat at the time called in the FPL and was like, "Who did this? You need to get your sysadmin networking people right in here." And so then Max Spivak explained, "Well, I could, but." He's in Chicago, and also I can't tell him to do anything. He doesn't work for us, doesn't work for you. So at that point, very shortly, I guess Mike was hired and then told to fix the problem. So I don't know, that's one way to get a job. This is where the now classic actual Fedora logo was designed. This was actually made by like a brand consulting thing, and it took these ideas, like the Red Hat marketing. Red Hat marketing used to actually like do marketing stuff for Fedora, and they came up with the slogan of "Infinity, Freedom, Voice," and that's where this, this come together to make the classic logo there. I have some fondness for it, but yeah. Here, this is a wallpaper that a lot of people love. When I was talking about that, people like really, oh, that 3D underwater rendered one. Wow, this is one of people's favorites here. People also like the name Zod. It was a whole in-joke thing. We've got lots of in-jokes, but this release actually happened on exactly the day that my second daughter was born. So I don't remember much about this or several months after of that personally, but I went back and looked. There was still a lot of time happening between releases, 218 days, that's a lot more than 6 months. There's a whole long story about why there was no Fedora Foundation. That's probably also a whole nother talk. But at this point, the Fedora board became an official governance body. Before that, there was a thing called the Fedora Advisory Board, which was really just a mailing list where anybody could give opinions and nobody made any decisions or whatever, but they actually made a constitution for the project that had the Fedora board as the governing body for it. It was a mix of people who are elected by the community and appointed by the FPL, and the Fedora project leader had veto power over it. That's the structure there. And now finally, we actually have a mirror manager system, which let me get a count so you can start seeing the statistics starting to happen at the bottom of the page there. Another nice wallpaper there, Moonshine. So this is a big thing here was core and extras got merged together. So having that split, not only was it starting to be kind of actually problematic practically, it was showing all the frustration in the community and the stress between like who can do what and so on. So Red Hat made another big decision. Again, a lot of lot of fighting with the internal wrangling that I don't know all the details of, but eventually the decision was made. We're going to merge these things together into one unified project. We're not going to have this core and extras split anymore. And it actually turned out to be easier to move all the stuff from inside to extras. So basically core got merged into extras. Extras became the thing, and core went away, and it became a unified release. This is also the first release with live images. Fedora wasn't the first distro to do that, but it goes way back to this. Cool. Also, at the FUDCon we had again in Boston there, we talked about this new file system called ButterFS. Thought, should we make that the default? And at the time we decided, well, it's going to be about 2 more years before that's ready. So in about 2 more years, we'll take a look at that. Werewolf. So 7 was where these were brought together, but 8 was really the first community collaborative release. This really felt like this was, in some ways, this is actually the first Fedora Linux, because it was not just released as a unified thing, but it was actually planned and put together as in the open as a community project. So this was a really fundamental release here. This is where the feature process, which we now call the changes process, or change process. Ben Cotton wants me to say it one way or the other, and I cannot remember. I'm sorry, Ben, plural or not. So that was introduced, and basically the idea is not that we should have a big bureaucracy, but stop surprising each other with changes. If you're going to do something big, let's talk about it first and what impact that will have. It's not meant to slow things down or stop, but just make sure that we're all talking together so that we can make things work the best they can. This was a very, very popular release. There are still at least 100 systems out there checking into the mirrors every day to see if we will release any more updates for this, just in case. I enjoy that. We also, this is where the idea of Fedora Spins came out. Spin is kind of a version where instead of just, this is like the official one desktop release, you'd have different ways of putting together the software into a different, different desktop, different installation. I think this is something that's kind of fundamental to what's interesting about Fedora as a distribution. We really try to, instead of saying, oh, you wanted to make it different, well, you can fork it and make your own project that's based on it. We say, hey, come into the project if you wanted to make your different version of it that works this way. Cool, we can try and find a space for you to do that. This wallpaper was the first one, I think, with a time of day feature, so it changes over time. This is the evening version here. Sulfur. The features process brings us new features, I guess. We had a new init system here. So this is another really interesting story. So a init system is, after the kernel boots, it is the thing that brings up everything else and is responsible for making sure all your services are running. Desktop, the desktop starts, all of those kind of things. And so the old thing, System 5 init script, System V, I don't know. Somebody can correct me on that later. But that basically used a bunch of shell scripts that were kind of slow and buggy and inconsistent. So at the FUDCon, which was, I think, in Raleigh that time, a guy named Casey Dolan stood up and was like, hi, my name's Casey. I'm going to replace the init system. If you want to stop me, come to my talk. And so people came, and I guess no one ended up stopping him. So Casey was an intern at Red Hat. So he was a Red Hatter, but this wasn't his job. It was just something he was kind of doing for fun. He wasn't working on the OS at all. So this is kind of a community-led improvement. Replaced it with, did I say here, Upstart here is the system that was used there. And so that was an interesting thing that also went into RHEL releases, is an improvement coming from the community that wasn't something that was started as a Red Hat decision there. Cambridge. Cambridge was actually going to be, as I understand it, the code name for what would have been the Red Hat Linux 10 release. So there was some wrangling to get it to be the Fedora 10 release behind the scenes, even though nominally there's that link there. That's actually the real reason this is called Cambridge. This release is important, I think, because this is where the Fedora foundations came from. There was that infinity freedom voice that had been, basically somebody external to the project invented that and thought that would be nice, which it's fine. It's nice to have that support, but it didn't really reflect, who we are as Fedora. And so there was some work on, talking about who are we as a community, and out of it, these 4 foundations, which we still kind of use as our guiding principles today. Freedom, friends, features, and first were there. So I think that's nice. That was, yeah, I think Paul Frields helped finalize that, and I think Max Spivak as FPL really started us down that road there. Yeah, this is a special wallpaper. I actually never had seen this lion before I went and did this. You had to have 2 monitors and a widescreen. The lion didn't show up unless you had the second monitor there. So this is those icons for the 4 foundations. And also around this time, we did talk about ButterFS again and decided it's probably going to be ready in about 2 years. And this is actually, it took us exactly 196 days, 2 releases in a row here for this one. Okay, I'm going to go kind of fast through the next few ones here. We had the first FUDCon in South America. This is a pretty nice but boring release, which boring can sometimes be good. Here, I have a note that we had a beautiful new website, and I also see that I did not take a screenshot of the website, but of Wikipedia. This is actually not my screenshot. I stole the screenshot from Wikipedia. There's CC license information at the end of this talk. It's not stolen at all. I took. Yeah, a lot of stuff going on, but this wallpaper, very dramatic, and I got a lot of people like, is my screen broken on this one? I love our community process that develops wallpapers, but for some reason there's a tendency to make things that look like a broken LCD screen, and this one got through here, but yeah. So behind the scenes in this release, Jesse Keating, who was the release engineer at the time, did a big thing of switching everything over from using CVS as our version control to dist-git. So that was a lot of big work there, which is actually pretty neat technology at the time because Git does not do a good job at storing large binaries. So that's like, at the time, Git was starting to take off in popularity, but there wasn't like everything is on the Git forge somewhere. There were people's various things everywhere. So just like today, our primary way of packaging things is getting the official tarball. And so you have this official downloaded binary somewhere, and those couldn't really be stuck into Git. So he has a clever system for that. It's all pretty neat. It was innovative things coming from Fedora, and I think Jesse got a job at GitHub on the strength of all this work. So that's, and then also because in that transition, I say we, but I don't know, Jesse, probably somebody made a tool called FedPackage that basically, instead of using the CVS commands, it kind of abstracted all of the package managing things, so it didn't really matter what transition you were what you're using underneath. And we still use that FedPackage tool a lot as well, and it kind of hide some of the implementation details. And I think that's actually also kind of a nice lesson because change is hard. So yeah, you can see it's not like huge growth here, but we've got a nice growing growth trend around there. Things are going really well. Yeah. So this really lovely wallpaper for this release. This release is going to be great, right? I hear laughter from the audience here. Yeah. So yeah, goodbye to half our users here. So there's not enough time to talk about whether systemd or GNOME are good. That's we could have a whole yelling fight about that. This was a lot of change all at once, and I think if you look at these technologies today, I think they're good. This was the right choice to go in this direction, but wow, they were not ready and people were not ready. And I went back and looked and I was like, well, could we have documented things better? Like we actually put a lot of work into making this smooth. There were videos about all this, and it was like, we tried, but it was just too much change. I think, in retrospect, like that FedPackage tool, if we would have worked on some things for compatibility and done some user experience things and whatever, it would have been a much better experience. And it's always kind of a trade-off. So one of the problems with that, we switched to Upstart as an init system before, but there was so much emphasis on making it compatible that basically not only did you not notice any of the change, we ended up just keep writing the same shell scripts for it, and we never took advantage of any of the possible improvements from it. So there's something where if you're focused too much on the compatibility, it can hold you back. So going ahead is sometimes important, but maybe let's not do it this way again, because that was not great. This wallpaper, obviously a reference to Jules Verne and 20,000 Leagues Under the Sea, but I kind of can't help but feeling that the just sort of murky depths and gloom was just kind of the feeling, as my kids say, the vibe of the project at the time, and it was kind of depressing, and so we got a depressing wallpaper here. Jared Smith, who's the FPL, said, oh, yeah, that was the awkward teenage years. So yeah, that's maybe something to it.
And you managed to lose a whole lot of architectures off there.
What? Did I? What? Architectures? There's. Wait. There was. Yeah. Sorry. I'll fix my slide later. I don't know why we dropped. Anyways, the comment from the audience was, "I've accidentally left ARM off the list here, and I should not." We did consider ButterFS as the default file system this time, and we decided in maybe about 2 years that's going to be ready. There was actually one big important change that happened here. Before this, Fedora had a contributor license agreement where basically you said that you were giving your license rights to Red Hat to control. And since at this point, and since that, we've changed to a contributor agreement, which basically says I've got the right to submit this code and it's under an open source license, and if it doesn't have an explicit license, you can treat it like it has MIT or Creative Commons license. So it's not a thing that gives away any rights. And so that was a change that I think made being a contributor, not working at Red Hat, to Fedora much more equitable. There are a lot of open source projects which have a thing where you have to assign your rights to the company or to some entity that works on it. And often that's kind of a unilateral thing where everybody outside of the special entity is bound by copyleft. It means, if you make a contribution, that contribution can be shared with anybody and so on, whereas the entity can say, oh, I'm licensing this as proprietary software, I'm going to charge a lot for it. So even your contributions that are GPL for everybody else, for us, they're special. So we don't do anything like that, and I think Red Hat doesn't do that for anything. I think that's pretty important that we got rid of that, and I'm glad we did. Actually, we're even looking at if that contributor agreement is even necessary for a lot of things. There's a lot of cases where there's a concept called license in, license out. Basically, the assumption that when you're making a patch for something, it's under the right license just by making the contribution. But that's for legal to figure out. I would like to point out that on the devel list here, we have Adam Williamson as both the most prolific thread starter and the most prolific replier to those threads there. I think that's, so things can't all be murky depths here. So we had this release, Beefy Miracle. The mustard indicates progress. And the naming process, again, you can see that people were not afraid to bend the rules to get what they wanted in this one here. Yeah. Right. So, I'm so sorry that I've dropped the architectures. Well, what am I missing now? Oh. I think maybe that's supposed to say ARM64 and ARM HFP. Okay, whatever. I told them to save the heckling. I told them to save the heckling for later, but it's not working. Anyways, many people described this as their most favorite release overall, and I think there were a bunch of features, but I think the important thing really was just kind of the camaraderie and the friends foundation of this kind of fun themed release that was very kind of a silly mascot and everything. It kind of, even though things felt a little bit depressing, kind of brought everybody together, and the community felt like, we're doing something here. And so I think that was really a nice moment there. In this release, these tiny dots are actually circles because it's an idealized physics problem, cow, in the name. That's in nerd jokes in here. This release was kind of a mess, actually. The installer code base, Anaconda, had gotten kind of horrible and needed some serious refactoring, which it got. But that features process was very geared on what happens release to release. And it turned out that rewriting the whole installer was something that needed more than one release to go through. And we slipped all the way around from the fall release to January, which was not great, to say the least. And also, the Anaconda team that does the installer works on both Fedora and RHEL. And RHEL didn't have an upgrade feature. That's actually being worked on for RHEL right now. But at the time, no upgrade feature. And it was pretty important to Fedora. But oops, somehow that hadn't made the requirements. At the very last minute, we realized, oh no, there's no way to upgrade. Hey, we kind of need that. So Will Woods threw together something called FedUp, which is a name that I love dearly. I wish we still had that. And this actually is going to kind of accidentally set us on a good path, really, because it actually was a better upgrade process. And from this, we've really worked on making sure that the upgrades are a really smooth process that you don't have to stress out about. It's not a, oh no, Fedora's short life cycle means I need to give away up 2 weeks of my life every year, making sure the upgrade works. It's just a, hey, do the upgrade thing, and you'll be on the next release, and smooth sailing on. So I think it actually turned out well through serendipity there, but it wasn't the intended result. Another thing that happened around this time is we had a lot of pain with release engineering, and I will not name names, but one person had been doing most of the work in that area for a number of years and had ended up just from being very overworked, the person who knew how to do all the things and no one else did, and also some amount of pride in that, like I am the person who knows how to do all these things, which is totally reasonable, and a lot of things in open source are kind of driven by that, like, yeah, I have ownership of this is my thing. But it can also be pretty unhealthy for that person and for the project, so there was a lot of frustration, and I don't blame the person at all. This is a systematic, this is a Fedora problem that we hadn't really addressed very well, because we should have found ways to support the person in that and found ways to make sure that they could have that pride in being there in a way that was about the team and the sharing and success of everything. And so that's, it was definitely causing problems around that time, and that's kind of a thing that has been kind of a repeated theme a little bit here. Yeah, again, we've got nerd jokes here, and these are boxes to put cats in.
No, not the jokes,
the problems? Oh, yes, right, yeah. Yeah, here you go. So this is the QA thing. It turns out that putting Unicode in the name exposed a lot of exciting things everywhere. And actually, I think this was the first name we had a space in it, which actually turned out to be worse. Apostrophe, yeah, right. I think we solved the apostrophe by making it to a Unicode apostrophe. Yeah, great. But yeah, so all that is kind of fun. But the biggest thing that happened around this release was really an immense tragedy. So Seth Vidal, who I mentioned before as a really important early contributor to the project, was killed while biking home in a hit-and-run driver. Seth was very humble, and he would have downplayed this, but he was so important to making Fedora what it is, both in the community and in technology. When we were both university sysadmins at different universities, and he helped convince me that it was worth the effort to be part of the community and give things back rather than to work on my own and do things there. And yeah, he was kind, he was funny, he was brilliant, and he was a dear friend. And Seth, we miss you very much. Okay, sorry. This wallpaper, it's a 20, XX for 20 there in the background, very subtle. This release had a lot going on. I was actually going to put a picture of myself wearing the 10 Years of Fedora shirt there, but I decided if I was going to cut something out, the vanity could go. The badges aren't actually in that screenshot. I just decided to plaster them there because they're fun. So we launched the Fedora Badges gamification thing, which is and something we're working on again and kind of putting more central a way to both bring people into the project, find easy ways to get people hooked in different areas, and also, to some people are very much driven by, can I get a digital sticker for doing a thing? So we have digital stickers. It's very fun. This is also a place where we decided, we're at the 10-year mark. It's time to do some strategic planning. We'd started out great, and then we had this big drop, and now things are kind of taking up again. We wanted to make sure that the next 10 years would be awesome, basically. So as a flock to a Fedora event, we changed from this FudCon to this, and the idea, Robin Bergeron, my predecessor as the FBL, had this idea that rather than having these little distributed events with no real focus, we'd bring everybody in the world together to have one big event where we would all talk about what we were going to do, plan the next release, and bring it together. And so that was a focus of a lot of the strategy there. Tom Calloway, Ruth Seeley did a lot to make that be a reality. Somebody's dropping names, and I probably shouldn't because I know I'm missing a lot of amazing, important people's names in this. So if I've left out a name, I'm sorry. You deserve to have your name mentioned as well. But yeah. Release engineering comment here. Like this was hard because of all the changes we were making around this. But also at this time, the Fedora board had kind of faded into the background and kind of become. There weren't a lot of big decisions to make, but occasionally there was something like, is this open sourcey enough, would be raised. And then the board would go off and have a debate and maybe come to a decision and then give a prophetic announcement that wasn't the question asked. And it wasn't really very functional. So actually FESCO, the engineering steering committee, ended up driving a lot of the strategy work here. This was, so this thing called Fedora Next. We came out with having different editions. One of the big problems that was kind of causing a lot of stress in the project was the earlier strategy had decided that the desktop release was called the default offering. And then we had a lot of people who were contributors in the project, and I mentioned way back at the beginning that there are a lot of people using this in server use cases, not the desktop. With the desktop being the default, a lot of the decisions were being made, okay, well, that's what we're going to do, make a desktop-oriented decision. And so it ended up that people who had sysadmin interests basically felt like all they could do was complain. That saying, no, 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 was their role in the project. And sysadmins tend towards being grumpy anyways, so it was easy to exacerbate that. So part of the idea here was, let's not do that. Let's give a positive way for people who want to have these different use cases to work on Fedora Server, work on IoT, work on what are these different cloud use cases, and say, okay, you can make the decisions that are right for your use cases and have them, even if desktop can also not have to try and say, I'm going to make sure that I placate the server needs for this very different use case for here, so we can have these different decisions. So I think that's worked out really well. Some of the other things, Fedora rings, not quite there yet, but stuff there. Did I get all the architectures right this time, Peter? No. Okay, awesome. Did not. Still got the list wrong.
May I ask a question?
Yeah, go ahead. Let's do it. That is another talk. But the three editions is what were Fedora Server, Fedora Workstation, and Fedora Cloud at the time. And so we've expanded from that, but that's basically that decision there. Yeah, that's so actually, because of the release engineering problems and all that, this is actually, we decided to stop, and actually we skipped a release for the first time and probably only time ever to kind of give release engineering QA time to recover from that hard release and get the tooling up to shape to do things. That turned out okay. I think that probably staying on the cadence is something we should keep to. That's a whole another big conversation. Yeah, a lot of people were skeptical about this editions idea, which is very fair. It was a big change. I think that idea really worked. We can kind of see as these things go up here. It was a hard decision, but I think it has been, see a lot of growth in the project. And that strategy and approach made things better in the community and made the release a lot more popular. This is where, as part of that strategy, we decided to have a brochure site, getfedora.org, and we're going to also have something that went hand in hand with this, a contributor-focused site. That was going to be a thing called Fedora Hubs. The idea was there were like 1,100 IRC text chat meetings every year, and a lot of stuff on mailing lists. But if you looked at our website and everything that maybe somebody who is new to the project might come and look, it looked like we were dead. It would look like there was no activity on the internet happening, because the internet had changed from being something that was a lot of these different text-based protocols to the web and social media, and those kind of things were really becoming the focus of what people thought was the internet. And so the project didn't really show up. So we wanted to have kind of a social media-y view of showing all the activity. That turned out to not work so well, but that's another talk. But we kind of come back to that idea later of making sure that the project is visible and activity is surfaced. Josh Boyer says that he was to blame for killing the names here, but really, so we stopped having the fun code names. The reason is we were coming up with these lists with these tenuous links. We would take them to legal. They would review the 10 candidates and say, these 2 that are the worst possible ones, you can use one of those. And then that was like, we were using up quite a lot of legal resources on that. So finally, we decided, okay, it's fun, but it's not worth it for that. We have to find our fun in other places. I'm sorry. I mentioned that the board wasn't really working. Not just that it wasn't very active, but it wasn't very connected to the project. So we had made this 3 editions decision. The board actually approved that. We went through this whole process of that. And then at the Flock conference a little bit later, we were in a room like this, and a lot of people were like, no one made that decision. That wasn't official, and it was supposed to be official. So clearly, when you have a community-led project, a community-driven project, you can't have top-down decisions that just declare things. It's got to be something that's connected in, and people need to understand. Okay, here we have a process for decision making. The decision has been made, and it wasn't really working very well. So we came up with a new structure called Fedora Council. It maybe also could use some improvement, but I think it's worked pretty well, where it tries to draw people who are involved in different areas of the project into leadership and to have a more active, not just a behind-the-scenes governance and dispute resolution, but actually active involvement in leadership in the project. We also got rid of the exclusive veto for the Fedora project leader by going to a consensus model where effectively everybody has an equal veto on something, and we have to figure out how to all get along on things, which actually has worked very well. We have never gotten to a difficult situation where we haven't been able to reach a consensus. How to do consensus, that's a whole nother talk I would love to do, but again, I'm actually running way over my time here because I am going much slower than I was going to. One thing we did add, we have a thing called the FCAKE, the Fedora Community Action and Impact Coordinator. That is something Robin set up, and is one of the reasons I've been able to be Fedora project leader for so long. It is no longer just one person isolated. There's a kind of another full-time person to help with community building and activities in the project, which is very, very, very helpful. I can talk also about why that's not called community manager in a whole nother talk, which I will not do right now. Change things up. Fedora KDE Plasma Desktop here. Got a diversity and inclusion advisor. I think that's a thing. I would like that to be a fully paid role. I can't convince Red Hat to do it. If anybody else can come up with funding for this, I would love to have that be a fully paid role. A lot of things going on here. I'm going to go here. XFCE spin here. A little bit of working in marketing. Fedora loves Python here. One of the things that happened around here, though, the docs team kind of got into a situation where it turned out where we hadn't been paying attention, and one person had become the docs team and had all the docs team knowledge and docs team work, and that person got burned out, and suddenly we didn't have a functioning docs team in the project. And again, this is not that person's fault. It was something where structurally, it was going along so well, we weren't really paying attention and giving them the support and the team the support that they needed. That's it. Yeah, here it was a really short release cycle. This is something we decided on purpose because previously when a release had drifted, we said, okay, well, we'll go 6 months from now to the next release. And that was causing releases to rotate all around the calendar and be unpredictable. So we decided, well, we're going to stick to the fall, the October, May release cycle. And even though this will be short, it turned out to be an okay release. Despite that, there wasn't a lot of change, so that all worked out well. And people actually really liked this one. It got a lot of really good press, which was very encouraging to people who kind of went through those awkward teenage years. You can see in the graph here, there's a big upshoot there. Kind of, I think, the things we were working on, people started to take notice and be like, hey, this is interesting things going on in Fedora these days. Peter Robinson, I have you name dropped here, you said you made yourself redundant for secondary architectures. We got rid of this idea of having a whole nother process for some of these other architectures and kind of merged that into the main thing. Maybe I have the list right this time, who knows? Yeah, all right, I got the list right too, so that works out. This is, I think, my favorite wallpaper. It's beautiful. This is actually not my voice print. It's the designer, Kyle Conway, saying Fedora in a voice print of that, and then that becomes the trees. That's just nice. And it looks pretty. We got a new mission statement. I'm not going to harp on that too much, but I think it kind of goes back in a lot of ways to that thing about spins and where we try to make it so you can as Fedora, as a project, we want to make something you can use as an end user, but we also want to make it easy for people with ideas about how to make an OS, how to make things better, to work on those ideas and deliver those to people. It goes from Fedora Next, rather than just like handing out a bunch of building blocks, we want to give out some pre-assembled things, but we also want to give people those building blocks and like, hey, you can make your Lego set and give that to people. That's something that we try to empower as a project. Modularity is its whole another retrospective talk. I'm not even going to touch it. We finally got MP3 playback. Software patents are a huge impediment to free software. Our basic tactic is to wait them out, which is not a great way, but we actually waited this one out, so there we go. The modularity thing was a little bit of a stress. This release took way too long, or the previous release took way too long. We made this one short again. Modularity was really the fire here, and again, that's another talk here. But this is Sugar on a Stick, which is a user interface designed for children to be intuitive. It's actually kind of amazing because you put this in front of an adult, and they're like, I don't understand how to computer anymore. And you put this in front of like a 4-year-old, and they're like, whoa. So it's great. This is another we broke the laptop screen wallpaper. I don't know why we keep doing that. So this is actually the first ever perfect execution of our planned release schedule. We were exactly on time. And the modularity thing actually landed, so that was nice. Part of the trick here was dropping alpha releases, so quality team, a lot of work around that. Ben Cotton, as program manager, I think gets a lot of credit here as well. And less good here, we had somebody who had been working on the websites team who over time became the websites team and had kind of felt he had ownership of everything. And once again, like he was doing such an amazing job with it that we didn't really pay attention to that. And when he got a different day job, suddenly we didn't have a websites team. And it turned out that when I went to Red Hat and said, hey, we need a websites people, and they're like, no, that's not important for RHEL. So that was a whole crisis about how are we going to have a nice, pretty website. Actually, it turns out that this should be another thing. We actually have a nicely revitalized community-built websites team that made a beautiful new website. If you go to fedoraproject.org now, it's amazing. And that was really done by building together a community of volunteers interested in doing this. So we're getting better at this, but we certainly had this problem over and over and over again. I love this wallpaper. It's cool. One of the big things here, Red Hat surprised everybody by buying CoreOS, the company. They didn't know what to do with CoreOS, the Linux distribution. And so I fought pretty hard to have that Fedora be a home for that, and I'm glad that it did. If you look at the statistics in a different talk, come to Flock, our next conference. I'll show you some statistics. Fedora CoreOS is doing really well. And from now on, at least through this talk, we're basically 180 days apart, release to release, very, very consistently. Plus or minus 1, I think, here. Fedora Silverblue came out around this time, and based on the CoreOS technology, which kind of showed that you don't have to just, it doesn't have to be just a trivial change of packages. Adam, you're making a face. What have I done?
We didn't do anything with your
Oh, we didn't? Yeah. Yeah, whatever. We'll talk about that later. The idea is basically you can make a big change to make in a spin. It doesn't have to be just a different desktop technology and packaged in the same way. You can change how the OS is put together in fundamental ways and also have a Fedora spin that shows that. So I think that's a big fundamental thing. Okay, running out of time, kind of move on. We drop the 32-bit x86. That's a big thing, not enough people to maintain it. This is a cool release. I feel like that's like a really nice 80s throwback wallpaper there. There's plenty of other stuff, but big highlight that Lenovo decided that they would ship Fedora Linux on, you could buy it out of the box with that. And one of the amazing things about this is, first of all, if we didn't go to Lenovo to make a deal, they came to us because of customer demand. And more than that, they didn't want us to make a customized version. They didn't want a customized version. They wanted exactly what Fedora as a community was producing with no changes. They wanted the real Fedora Linux, not some sort of Lenovoized version. They didn't want to take control over the kernel. They wanted to deliver to their users what we are making. So that was a really strong vote of confidence and a really nice way to work there. There's been a whole bunch of supply chain problems and COVID and whatever that, and there's still it's not available as much as it should be, but call Lenovo and ask for this, and because that's really the salespeople hearing it is what's causing it not to be available worldwide. COVID times, we had Nest instead of Flock, virtual meeting everything. I was actually kind of dreading that thing, but it actually turned out that our virtual conference turned out to be amazing and energizing, and I didn't organize it, so I can say this. It was the best conference of all of COVID, all of the Nests. They were, most of the things I went to, Red Hat Summit, sorry Red Hat Summit people, were just kind of draining and awful. At the best, they were like, oh, here's a webinar. And our conferences really felt like the community coming together from around the world and having a virtual party, that was amazing. So again, Fedora community is wonderful. This is the Peaceful Universe wallpaper, I think, escaping the stress. That was a nice one. There's a night version of that. Here's a case where GNOME 40, remember back to where we lost all the users. This is a really big user interface changing things from horizontal to vertical or the other way around. And I think both Fedora and GNOME Upstream learned a lot from this and actually spent a lot of time doing actual user interviews and research before putting the change out there. And actually, the results ended up being great. And I was worried. I thought there would be drama there. And it turned out to be, some people aren't perfectly pleased, but you're never going to make everybody happy. And I think the big change landed very smoothly. Pipewire, a big audio change landed. There's a little bit of rough there as well. But this is actually a funny marketing lesson, which is obvious in retrospect, which is a lot of people shouldn't ever care about their audio subsystem, but there's one set of people who care a whole lot, and that is YouTubers and podcasters. And suddenly, around this release, we were incredibly popular with YouTubers and podcasters who had an exciting thing to talk about, and they really liked that. And so that kind of jumped up how people were talking about us. So it's like, oh yeah, maybe appealing to the audiences that talk a lot about what they're doing is a way to get people to talk a lot about things. That was and we also have our new logo here. Mo Duffy does a great talk about why we have a new logo and how the designing went into that. I really like it, and I'm glad that it now will not have Fedora as one of the top typos or searches from people who don't recognize, in languages where they don't recognize this as a word, assume that that's what the old logo said because it had an A. It was very indistinguishable from an O at the end. Okay, so up at the time, best release ever, Fedora Linux 35. This is the new overview, the new sideways instead of vertical thing. We didn't quite make the 182 days there, so I guess more than plus or minus 1, but still reasonable range. Got things right instead of rushing. And here, some of the big changes that are not there. We launched the chat.fedoraproject.org, moving from IRC to Matrix, and working on discussion.fedoraproject.org. I know some people are very resistant, but I want to move as much mailing list stuff from there to that as well. So a modern, friendly interface that is transparent to people who are not necessarily deeply involved in the project. I also want to make sure that people who are deeply involved have a good experience, so we'll work on that transition. It's not going to be dumped on people, but I think that's actually a really important thing. We also have a renewed Fedora Ambassadors program around this time. That's kind of getting ramped up after COVID. We're working on some investments in mentoring, had a mentor summit. I think that was an exciting thing. And this new websites team that I talked about started coming together as well. And that was really with kind of lessons learned on how to make this a team success rather than something that could be, it was just an individual. I think that was really, really good. Right there. Kinoite was somewhere around there. So we started having some different variants using the OS tree that were coming around. Was that in this release here? Kinoite, was that? Is there? I was asked at the beginning, where's the missing 3 releases? So I started adding on to here, but I realized I didn't really have the perspective to talk about these most recent releases. So I'm sure there's interesting things to say. A lot of stuff has happened in the last year or so, but I've decided I'm going to put the seal on this talk here and end it, and then maybe in 15 years someone else can do a sequel and talk about what's happened over the time there. But that's, I'm going to stop this here. So quickly, some of the hard-earned lessons. What should we not repeat? You need to find a balance when you're making big changes. You can't just document it away. You've got to make sure you're listening to users, and you've got to make room for mistakes, but you also have to listen and deliver what people want. But also having a community that cares about the project and is working together, it can make the rough parts actually functional. Okay, I'm running out of time for questions. Community teams, you need to have momentum to keep going long term. Got to make sure that you're watching the people who are in positions where there can be a bottleneck so that they don't become.
Really bright lime green backdrops.
Don't use lime. This is one of the official Fedora colors, so that's there. There we go. Change to that. Don't. We've got to make sure that our teams they're not just depending on one person. That people should feel like they're recognized and awesome and supported, but that they also, if they want to go do something else, they can, and the thing they're working on will continue, and that should be a pride of success. And going kind of back to the things I talked about, Red Hat, letting go and letting the Fedora community lead. Really has brought a lot of innovation into the project, and I think that's one of the things that a lot of projects really could learn from. It's scary to do it that way. Sometimes it's hard when you have, to figure out how to get a community to come along with the decision that you want to happen, but you get better results that way. And okay, there. I have left some time for questions here, so let's. All right, Peter Robinson, is it about how I've gotten the architectures wrong?
No. I want to know why you left out the first new edition.
The first
new edition after the edition process.
What release was that in?
Early 30s, 31.
It says Fedora IoT. I think I mentioned it somewhere there, but I may have just skipped over it. Fedora IoT is an important addition that we added, kind of one of these use cases that we thought, we need to make sure we have something that covers this emerging area in technology. So that's a very important thing. Yeah, and actually going through the idea of adding a new edition made us come up with a how do we add a new edition process, which we had not had before, so we have that as well. That was the thing. Dan.
I would have talked when we switched to C groups v2. I think that was
This.
because that forced all the other issues.
Yeah, right. So there's another big change. We switched to something called C groups v2, which is a kind of kernel level thing that's used for making containers be containery. I was almost going to say containers contain, but then I remembered that I got Dan in this room, so I shouldn't say that. And that was a big change. That along with the systemd and those things, it's one of those situations where if no one takes that first step, it's never going to actually get exposed to users, and it will never get there, and things will drag on forever. So at some point, you've got to make that change. And so finding that balance of when to go to that and when to not is important. And I think having, in some ways, like the additions split, where I think, was CoreOS slower in that? Some of the additions decided to do that.
Kubernetes and Docker no longer work. So.
Yeah. Right. So some of the releases decided, okay, we won't make this big change right away, and kind of rolled it out slowly so that people had the option. It was the default in a lot of things, but there were also fallbacks where you think, okay, this is going to just work.
I just wonder why Fedora considered the D3FS as the default file system twice.
Oh well, so actually that joke, yeah. I skipped over landing my joke here. I've done in other versions of this, I landed the joke properly, but I had spent too much time on other things here. Yeah, so there's actually several other times it's mentioned. We actually considered ButterFS throughout the years, and every time it was going to be 2 years off. Between Red Hat storage internally, this is actually one of these let the community do things. Red Hat storage people decided we're not going to wait for this anymore. We've got to focus on what works, and so they put all their effort into a thing called Stratus, built on LVM and XFS and so on, to kind of give the same kind of features there. People in the community were very excited about things ButterFS could bring. People working at Meta, where they have a bunch of big investment in ButterFS, finally said, okay, look, it's ready. Let's do it. And so we went through our change process, and with a lot of debate, and with the Red Hat storage team weighing in to say, please don't do this, we decided, you know what, we've been considering this for years and years. It kind of brings some neat things that our users would like to see. We're going to do it. And this is, again, a thing where Red Hat doesn't call the shots. And so the Red Hat, for things like that, they figure out how that Fedora can be a good upstream and still have different decisions on some fundamental engineering things. But yeah, we eventually did make the decision to do that. Another one that's kind of along the same lines is a change in baseline architecture, which is basically, as new CPUs come out, they get newer and newer features. And so if you compile your code with a newer CPU, it can have better performance, but won't run on the older systems. And so Red Hat for RHEL wants to update to the newer version of that. But we have an ironic problem in Fedora where, because we move fast, we can't move as fast on some things because we'd leave people behind. So with RHEL, since it's got a long life cycle, if people can't use the next release on their hardware, or their old hardware, that's fine. They'll keep running the old release for as long as they want to pay for it being supported. Like I think there's probably RHEL 4 out there somewhere being paid for by somebody, right? Red Hat will take your money. But Fedora, we're kind of going on to the new thing, and we can't say, okay, well, sorry, all your hardware from 5 years ago, put it in the trash, buy new computers. So we had to move more slowly. And so one of the things I actually asked when the people at Red Hat who were working on this were like, well, Fedora will never accept this, and I asked them to bring it to the community anyways to discuss it, which we did, and it was a big discussion. But out of that, we kind of came up with this idea of having something called ELN, which is a build of Fedora, with defaults that are set for what would become the next RHEL. So we actually have a place in Fedora where people can experiment with, here is a way to do things in a different way. So we can do those builds even if we don't make that the mainline thing that we deliver to people. In some ways, Red Hat is special in order to do that because they're paying for a lot of the resources to do that. But if anybody else wants to come along with a thing like that and can help provide resources so we can do it, Fedora is open to that. So if you've got some other big idea you want to do, Intel, if you would like to do your clear Linux thing as a Fedora build, come to us. We can make that happen. Yeah.
What do you see as being the next big technical change for the Fedora project?
What is the next big technical change for the Fedora project? Predicting the future is hard. I think it's both a technical change and something that is going to be a kind of a social change. I think that this RPM-OS tree approach that's used in Silverblue, Kinoite, CoreOS, IoT, I think that's the way we want to go for all of our defaults at least. It has a lot of advantages for delivering a system that's consistent. You can do cool things like do a bisect to find out exactly where a problem came from, and it kind of goes towards a container-focused separation of what is the base OS and what are your different applications, and help solve the problem we were trying to solve with modularity, which is that everybody has different opinions about the speed that they want different parts of their operating system to go, and this kind of that approach lets you separate things in a way that lets you do that. So I think that change towards that, in whatever form it'll take, is probably the really big technical change. There's also the social change of convincing everybody that that's the right way to do it.
The rollbacks are great.
Yeah, rollbacks are great was a comment there.
Hello. My question about CentOS Stream becoming an upstream distro. Do you think it makes sense for my team to try to switch to Fedora for a production workload for the critical services in the cloud to Fedora? We wouldn't like to pay like for 500 virtual machines on Red Hat license. We are quite experienced in Linux, but we would like to have a strong community behind it, the distro we use as a next base system for the next 8 years. Do you think it makes sense to consider for us to switch to Fedora?
Yeah, so the question is basically, with the changes in CentOS project, would Fedora make sense as a cloud server operating system in actual production? And I can't necessarily speak to your particular use cases. There are hopefully reasons, for, Red Hat pays my salary. I hope that there's value that Red Hat's providing for that money. But I also think that, Fedora can be used in production, and people are using it in production in some pretty large-scale things. Depending on your ability to work with the community on things, your tolerance for risk, and your configuration and setup, your change management processes, you can definitely use Fedora in production for things like that. We can talk later more about it, about your specifics as well. Does that cover what you're asking, or does that cover what you're asking?
Yeah. I just wanted to ask if it's a crazy idea.
It's not crazy. Or maybe it's crazy in a good way. The right kind of crazy, it can make it really work, I guess. But we'll talk. Okay, I'm out of time here. But thank you, everybody.
Hey, hello. Good to have you here. I'm Carolina. I'm working as a software engineer for Red Hat. But today, I'm here not as a company representative, but just as myself, as a person who started the journey with open source not so far a time ago, even though my experience in IT is bigger than that. And inspiration for that talk was that I haven't met much other people like me who just started. So I thought it would be valuable to share my experience and my observation, how this whole process looked like and how did I start it. I'm not very great about talking on myself, so here is just a set of subjects and concepts I'm dealing on my daily basis job. I mostly work and contribute for RDO project. We are shipping RPM packages of OpenStack for CentOS. So mostly I'm doing packaging, DevOpsing, and debugging, also some coding. But let's go to the question. How did I meet open source? When I was studying IT in Wrocław, I was fascinated about networking and security. And it became obvious for me that you can do it without tooling which is available for a Linux. And tooling for Linux mostly means that they are open source. So I did two large students projects. First was for my engineer project, and this was a sandbox network for security research and testing. And this was a kind of honeypot. I was using technologies like Snort, like Nmap, Kali Linux, and Security Onion. And then on my master thesis, I was testing and benchmarking distributed file systems. A few time ago, after I was graduated, I realized that two of the systems I was testing, Gluster and Ceph, was a Red Hat project that I didn't know when I was doing my job. Of course, Ceph appears best from all the that I tested. Then, when I initially knew some Linux tooling and was really amazed that this wonderful tool is so powerful, it's open, it's free for everyone. And that idea was amazing for me. That's why I meant to FOSS them. This is a large conference for open source in Brussels. And then I saw some community from a closer view, and it was really amazing experience for me. How I didn't meet open source was on students' interest groups. And it's a pity that there is no at least at my university, any way to encourage people at the university when they are actually choosing their way or their careers path, to encourage them to go to open source. Also, none of my friends or colleagues from studies was contributing to open source. So, I was like lonely in this topic. Why people enter the open source? There are many reasons, and they are mostly mixed. But there are some few which are most solid, let's say. Generally, people would like to gain new skills. They are starting their new projects, some new adventure, to just learn new things, and they decide to just share it with a wider range of people. Also, they are starting something new because they need it for their work or for their other project, and just put it on a GitHub as an open source on a proper license. Sometimes they just need development in the desired project. So they just missing some features, or they discovered a bug which is really painful for them, and they just decide to fix the job or did the feature. And that's why they appear to be open source contributors. And the third way is, I would say, rare, but it's going to be more often to be hired to contribute to open source project. And this is my path of growing in open source. And speaking about motivation, let's say there are also some more soft, non-technical ones, like people like teaching others, people like sharing the knowledge, people have a need to belonging, and all of these motivations are mixed, but it's worth to remember that most of their motivations are not materialistic. No matter what motivation stays behind, people somehow has to start the work. And I observed that 3 mandatory pillars of a good start: onboarding, mentoring, and documentation. Absolute base of start if any kind of projects, no matter if commercial or open source, is an onboarding process. For open source projects, it's crucial for gaining new contributors, and for commercial one, it's providing smooth and quicker start, and also it helps to reduce stress and just make the start quicker. It's good onboarding process is shortening the time when people stops to be a cost for a company and starts to actually provide the value. Because don't get me wrong here, even the best engineers are a cost at the beginning. Of course, until the time they get into the project and get enough knowledge to provide value. Speaking about onboarding, it's also worth to mention some kind of vicious circle. If we have a project where contributors or developers are overwhelmed with a work, they don't have a time to onboard new people. They don't have a time for doing onboardings or all the stuff. Just leave me alone. I want to just work. But if they don't onboard new people properly, they still have too much work because they don't have anyone to help them. That's why it's very important to have this process, because it will help with it and automate some stuff for any new people. Everyone hates writing documentation, including me. But good documentation is a huge support, not only for newbies, but also for experienced contributors and maintainers. And this is a far more important tool than just the opportunity to say RTFM. Think about it in a more materialistic way. When some process is undocumented, every new people who is dealing with it has to do some, let's say, will engineering on it. And it costs a time. And time, as we said, is a cost. So if we have some, I heard a quite good description about such situation. It's called tribal knowledge. And this is a piece of undocumented project which is so obvious for a maintainer that they didn't even mention it in any kind of documentation. It can be, for example, setting a flag before an infra deployment. And you just start your deployment, you do everything, and you are meeting all these horrible bugs which you'd never seen before that. And you are struggling with it. This poor newbie is spending a time digging inside and waste of time. Yeah, I know that trying is a way of process and a way to grow, but come on, it's pointless. This time can be spent for something more valuable. And it's enough to have this flag documented. And that's why it's called tribal knowledge. Also, speaking of documentation, there is one important note: keep it up to date. Because if your documentation is outdated, people who are using it, users or newbies or new contributors, are learning that they cannot trust this documentation. And they will keep you asking anyway. And this documentation is, you don't need it because it's outdated. And the third pillar of a good start is having a mentor. As a mentor, I understand the person who, on a partnership level, will show you the project, will explain you the rules, show you how the team works, but also this is somebody who will grow you on or in other ways than only technicals. So this is somebody who understands what do you like, who will help you to clarify the way of development you want to go as a developer. The good mentor should also understand the tasks and helps to provide the proper task which will grow the newbie and which newbie will like. And I have to say that I had an amazing mentor on RDO, and if you will only have a possibility to find a mentor at your company, please do it, because I think that having a mentor is a kind of highway on a personal development road. In all this stuff I mentioned, there is challenges. First of them is a remote life. And if you work for a corporation, you at least have some chances for office. If you work like me, so 100% remotely, prepare also for a remote communication and kind of remote life. I have to say that COVID helped develop the culture of remote working. In Poland, where I work, COVID showed for many employers that remote working is possible, it's efficient, and people actually doing their job when they are at home. And also, I have to say that it proved it to me, because before COVID, I never thought that I had enough courage, enough self-confidence to even try to work remotely and not in a native language. I have to say that COVID just leave no choice. And speaking about language, English is a not native language for most of us, and this fact is often neglected. People are afraid of asking for repetition or just saying that they don't understand in fear of being known as incompetent. And it's good to remember when some problems or issue appeared, it may be not related to technical abilities of a person or just a simple basic communication problem related to language. When I start my work at Red Hat, and I get known that I will have meetings, normal stuff. But in written, on IRC, I was so shocked. I couldn't even understand how is it possible that the meetings are written. And also I thought that IRC is a communication method which appears only on XKCD memes, but it's still alive. Yep, and now from the perspective, also IRC is our official channel of communication for OpenStack community. So I understand why we are using IRC. It has its advantages because it's very easy to use for a whole community. But that time, I was very, very, very shocked and didn't prepare for that. And I could say that Fedora did it nice way because they moved for some kind, let's say, more modern communicator because they moved to Matrix, which is very, nice web user interface, and it's easier for anyone from outside to just use it. And challenge about communication is to just choose a platform where anyone who would like to have an influence for the project will be able to use it. Communities are relations. Communities are people. So building a relations inside the community and on the way community and commercial world is very, very important. And this is a huge role of community architects to just build these relations. And events like that, events like FOSDEM are very important for the communities because this is a place where you actually go, meet people, exchange your experience, exchange your ideas, and that's why how community is growing. Also, this is very important to, inside this community, build a welcoming culture because, when you are out of the communities, it's very nice. And I experienced that you are just welcome here. We are happy to have you here. It's very good for the beginning. Also, it's very important to have a safe space to ask, to not be afraid to ask and grow and solve your issues. Yeah. The governance of the project. The world of corporations and the world of open source differs. In corporate world, we have words like tickets, KPIs, performance, measurements, you know it. And at the same way, they are not existing in open source communities. It's just not the way they are working. And this is a challenge to find a way to find a balance between these two approaches and the workflow in those projects. The way how you are making decisions, the way how you're making even the meetings, how you are sharing the tasks, all this issue to be solved, they cannot be the same way in community like they are done in a corporate, because voice of the community has to be taken into an account while making decisions or while doing just normal basic duties. I have some tips for other newbies. And here, most important, and I think it's no surprise, just ask. Use the time, which is considered as being your training, or the onboarding process, as your time to be, safe to ask, because everyone are expecting that you will be asked, that you will not know, that you will looking for an answers, looking for solutions. And it's normal, and that's okay. And you should take best of the time what you even can. Trying. To ask proper and valuable questions, you have to first try to do something. So, if you want to ask somebody a question, don't let anyone to answer you with, let me Google it for you, or here is a documentation, just read it. Try to avoid that, because, it's a waste of time, and I think kind of lack of respect. And first, just try to do the job. Okay, it's normal that you probably will fail, or probably, I don't know, you're stuck on something. Yeah, but you at least try, at least do some effort to solve the problem. And this is something which will improve your skills. Make friends. Talk with as many people as possible, because you will never know with whom you will collaborate. So this is this onboarding time, this usually 1 month or 3 months, it depends on the company or community, is the best time to meet new people, to make new friends, like saying, hi, I'm new here, and just make networking between people. And as I said, if we only have a possibility to find a mentor, do it, because there can be a mentoring program in your company or in your community that you don't even know about it. So maybe you can just ask your manager or just try to find one, because you will only be profitable out of having a mentor. Tips for mentors. And as I say, keep your documentation up to date. I think I argumented it quite enough, so I won't repeat that. And again, this word of asking, but now asking from a different perspective. Why asking is so important? Because this is a route of communication. So people should, the communication should not be only in one way, should be in both ways. No matter if it's your mentor or if it's your manager, you should just exchange your communication. I know this is very trivial, as I'm saying, but what I'm observing, people don't talk. So they're just, sometimes they are not even aware about the problems of each others. And if you are a mentor, when you are in a situation that you give some tasks to your newbie, for example, read this documentation, or try this tool. After the time, ask your newbie and try to figure it out. How is the level of understanding of the newbie? What did this newbie got from this reading, got from this tutorial? Because this is a great way for you to understand how the newbie is looking at the projects. Also, this opportunity to indicate the moments in your projects which are or badly documented or unclear or just undocumented, because you, as a mentor, probably you don't have this perspective, because they're for so long in this project that too many stuff are too obvious for you. So this is an opportunity to you to have a different perspective on your project. And what's important if this asking, remember to emphasize that this is not an exam, not any kind of assessment, because your newbie can feel a little bit in danger in this fire of your questions. Just let them know that, I'm asking, it's not assessment. It's important, because without it, your relations can be distracted. Give tasks to help understand. When you are not only give a documentation to read, but also give a small task to use this new stuff you just learned. When I was learning our DeLorean tools, our very versatile tool for building packages, I got tasks. Hey, just try to build this one package with this tool. And it's completely changed my whole perspective of reading this documentation, because I was looking for some concrete informations in this documentation, which will allows me to solve the problem I've got. And I think this is a very valuable way of teaching new stuff, learning new stuff. Giveaway background. Not only explain the solution of problem or a bug, but also show how and why this happened. This is an opportunity to explain the workflows and architecture in the project, because it's actually having an anchor of a problem, because newbie meets something, did some effort to solve the problem, so they are inside the context. So it's very easy to make a notes about it and explain the context around it. And hold your horses. Don't try to explain everything at the beginning, because I'm sure you will have to repeat it later. And general tips for a good start for anyone: have a definition of done. This is something I really like to have. I mean that when you are making a description of a tasks in some kind of task management, define input and output of the tasks in a clear way. Describe this task that way. If you, for example, go for a holiday and someone will do the task after you, it will be totally clear for this person. And I think this is a good description, enough good description. Don't assume that somebody will understand what you meant without this description. That's why it's so important. And guessing is never an option, because there's a very high probability that you don't get what you expected. Describe the role. When somebody new is coming, it's very useful to define what this person was going to do after the onboarding process. And it's like setting an aim and setting a target for whatever they did. And when the person will go through this onboarding process, will be very sensitive for information which will be related to the job which they are going to be inside after the onboarding process. For example, let's say if you are a mentor or a manager, let's say at the beginning, hey, we are needed a person who will be in charge of developing our infra, or in charge of new CI jobs. And through all this onboarding, the newbie will be preparing itself for taking these responsibilities. Show collaboration with other teams or projects. As I said, it's very useful to know where to look for help and being able to ask it, of course, and who is responsible for what. And the onboarding process is a great time for that. And last but not least, give yourself and themselves a time. As a mentor, be patient and don't judge. People have a different way of thinking, different talents, different approaches to problem, as we are trying to build a diverse environment in our works. Also be ready that sometimes you will not only develop someone on a technical way or teach someone these hard skills. Also be prepared that you will have to teach also the soft skills, like problem-solving abilities, or doing dependency or required managements, or just way of speaking or discussing. Be ready for that as a mentor. And if you are a newbie, don't expect that you will be great since every first day, any first day, or even first month, because you don't have any idea about the complexity of the problem or the project. And don't care too much about the failures, because if you failed, it means that you tried. And trying is something which is most important for make you growing. Thank you very much for your attention. I'm here for you, and I will very appreciate your feedback. And if you have any questions, I'm here for you. Yes?
I'm actually about to be giving a talk in the same room, hopefully to newbies, and I was about to suggest writing documentation for a couple of polls in our project as a relatively beginner task. But I can see that you mentioned on the other hand that we should keep documentation up to date. What's your feeling about that? Is that a mistake? Is it a bad idea to, because it does seem somewhat like an easy thing technically to get done, So what's your feeling about that? Because you mentioned that for the mentors and for the project itself to have like good up-to-date documentation is actually the better thing to have.
And you mean by giving a task for making documentation up to date, yes?
Yes, actually not up to date. In this case, we have a couple of holes in
okay.
in our library.
Okay, so the question is if it's good to give a task for a newbie to fill some gaps in your documentation, right? Huh. I've got a task for that, and yes, I think this is a good task, but don't be too difficult in that. Don't give somebody a task to explain something which you don't really understand.
Right.
But I think it's a good idea for start. Yes?
So you mentioned this, like trying to solve the problem by yourself before going or asking for help, reading documentation and so on. Where would you say is the borderline? Like when, as a newbie, when I should start trying to resolve it and go ask for help?
Okay. The question was when to stop digging inside the project and stop trying to do yourself and actually ask for help. I've got this issue on my previous job that try to do it, but don't too much. And I heard from my manager that, it's up to you. This onboarding process is for you, and you will decide when you want to stop and move to asking, because your manager or mentor is not inside your head, and they don't know where you are, when is the moment you will feel frustrated or you feel stuck. It's up to you. If you feel that these few more hours will solve the problem, go get it. It's onboarding process, so nobody will know. Track your hours in Jira, or at least should not do it. But if you feel stuck, and you feel stuck that even these 2 days more will not solve the problem, just leave it. Just ask, because it's a waste of time and your energy.
So I want to that this subject that you said that during your uni times you didn't really have a nice and easy opportunity to jump into open source projects and all this kind of stuff. So you had your interest, but then you need this, someone to kick you in the project and so on. So now from the perspective of people, in those open source projects for ages, we like to have juniors, of course. We have programs like, G Summer of Code, the Outreach projects. So somewhere at the level of, upstream, those programs exist. We cannot say that there is no way for a newcomer to join the project, but at the same time, you touch a very valid point, because I can relate from my uni times that this is indeed a problem. So now from your perspective, what is missing in between? Because we have, on one side, we have those people at universities, at least some of them who are eager to join. Then we have programs that are aimed at doing exactly this, to having people to join. And somehow it doesn't work. So what's,
Okay. I have no idea how to make your question short for a recording. I try to understand with a context. So remember that programs you are saying about, like this G-Cloud, yes, these are big corporations. And most people, what I was thinking about open source, is just this small initiative is just like, I will start and do it. Or, Google is not widely recognized as an open source company. Maybe, let's say, Fedora is, because even though it's the same, also supported, sponsored by Red Hat. And I would say people who have a clear idea of joining open source, they will not first think it will not be Google or programs of a big corporations. And from the other side, from smaller projects, it's very hard for me, at least, to find this way to join. Also, this is another thread here, that people, for example, I wouldn't believe that I can handle the tasks totally remotely without not knowing people and just, using my keyboards to solve the problem and actually providing a value. So maybe I think people, this is a mixed. because people doesn't recognize Google or other, maybe Red Hat not, but other big companies as open source possibility. And from the other side, they don't have a very easy way to start with smaller projects. It's changing. I have to say, since I joined, I have to say that it's changing. I think that, for example, there's a lot of programs to start, as you're saying, but I think this is a matter of time to change it. But people are aware that inside open source that they need newbies, and I think this is an important change here.
So can I, kind of answer with a question? So can it be that the problem is purely branding? Because you touch something.
Yes, it may be branding.
Because Google Summer of Code, to make it clear, is not a program during which people work for Google. So I, as owner of an open source project, not related to any company, it can be my own startup, which is upstream. I can have a project in Google Summer of Code, during which I need a student to contribute to my project.
But you have a Google in the name.
Exactly. So can it be that it's purely about branding of this program?
Yes, it can be.
Problem?
Yeah.
If if we renamed Google Summer of Code to something Summer of Code, like open source Summer of Code, of course they won't agree, but just an idea.
If someone is here, for example, program for OpenBSD, it's very clear that this is open source. But if you hear Google Summer of Code, you understand.
I think we are all for time.
Okay.
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 Let's thank our
Come to me after. Thank you.
Thank you. Welcome to my presentation about Linux distributions collaboration on the mainframe. Yes, I'm speaking about collaboration. I don't watch any Linux distribution as a competitor anymore. We have got a working group at the Open Mainframe project for all Linux distributions. And therefore, I will speak firstly something about myself. Then you will receive an overview about the mainframe and the Open Mainframe project. What is that? Then we are coming to the Linux distribution working group, which is part of the Open Mainframe project. And I will tell you something about our goals for all Linux distributions and upstream projects now. I would expect all here are available because you are pro-open source communities. We are upstream working together, and therefore we have decided to include also upstream projects now that we can collaborate better together. And then we are coming to support you as developers, how to that you can receive support in development and architecture specific stuff. As an example, the S390X architecture, and what is the Linux One Community Cloud or the Linux One Open Source Software Community Cloud that you can receive VMs for free on a mainframe as developers. Something about myself. I am Sarah Julia Kriesch, and I am working as a lead IT/OT software engineer at Accenture. I'm doing that part-time because I am also a part-time master student in computer science at Friedrich-Alexander University in Erlangen-Nuremberg. In my free time, I am an OpenSUSE contributor until 11 years now. Yes, 11 years, because I have got a pre-education in computer science as a computer science expert, and I was a student with work experience because I have worked as a Linux system administrator then. And now I'm a member of the release engineering team. I am responsible for the S390X architecture at OpenSUSE, and I'm a team lead for OpenSUSE C systems. I raised the hand that I want to found the Linux distribution working group together with one IBMer. Therefore, I'm also one founder of that, and I am speaking for all Linux distributions who have joined to us. What is the mainframe? On the right side, you can see all sizes which are available from IBM as a mainframe. The smallest one here is the latest release from April. That is a rack mounting system, and mainframes are well known as large high-performance computing systems, especially used for banking systems, insurances, and everywhere where you have to transact multiple transactions in parallel. Now it is also available in a smaller version, and if you are speaking about architectures, they are also well known as big endian systems, and the architecture is the S390X architecture. It is used for mission-critical data like banking systems, as I have explained, and you can run thousands of VMs on such a system. From that, we are coming to the Open Mainframe project. The Open Mainframe project has been founded in the year 2015 and is under the hood of the Linux Foundation. The focal point is the deployment and usage of Linux and open source in a mainframe computing environment. Yes, we as Linux distributions said then, okay, if you have got also the usage of Linux as a focal point, then we want to be integrated. Because if you can see mainframe-centric projects under the hood of the Open Mainframe project are more COS specific or general C specific. You can see different projects here which are used mostly for COS and not Linux. Some of them are for the improvement of the command line, that you can connect better and that it should be as an open source software. Or SOVI is for better deployment of Linux and everything else on CVM. But I want to highlight one thing. They have got also a mentorship program. Therefore, if you are interested for mentorship anyway, in the area as a mentee or a mentor, we are supporting also the enablement of open source projects for the mainframe, for Linux especially. And therefore, there are many projects under the Open Mainframe project. Then we are coming to the hot topic, working groups. There are 3 working groups available. I have joined 2 of them. The Linux distribution working group exists since 2 years now. The modernization working group I have joined as a Linux contributor, but the focus of mainframe modernization should not be only COS related. I want to have also a Linux background inside of that. And then there is also the COBOL working group available, which is also responsible for the COBOL programming course at the Open Mainframe project. We have started 2 years ago, shortly after the IBM C Day, with a kickoff with community Linux distributions, because I and Elisabeth, we said we don't want to have one Linux distribution for the mainframe. We want to have support and infrastructure available for all of us. And especially IBM said in the past, we provide only official support for Rails, less, and Ubuntu. We said we want to have also really good support for all community distributions. Therefore, I have reached out to Fedora. Dan Horak has been available for Fedora. Then Elisabeth went to Debian, and we have received Rajendra for that. And with that, we created our Linux distribution working group. Now we are more. Afterwards, in the next step, we said we want to include all enterprise Linux distributions. Then SUSE has joined in the next step, Ubuntu has joined in the next step, and Dan Horak said he wants to be the representative for Fedora and Red Hat in our Linux distribution working group. Therefore, to the Red Hatters, if you are interested for speaking for Red Hat and supporting Dan on the other side, you can join us. We need a second person that Fedora and Red Hat have got the same split as SUSE and OpenSUSE. One Linux distribution for one person should be enough. But anyways, that was the next step, to integrate the enterprise Linux distributions. And then after my talk at FOSDEM in the year 2022, Alma Linux and Rocky Linux have joined also. But if any other Linux distribution wants to receive support for building for S390X, all can join. Our structure is, we have got our founders as co-chairs. I am an OpenSUSE representative, and I'm working for Accenture. Elisabeth is Ubuntu member, therefore she has been the second founder from Ubuntu side as an IBM employee. Now she is also the head of Open Source Program Office at IBM. Therefore, we have got the highest level at IBM for open source software within our Linux distribution working group. Then we have got one representative for every Linux distribution. We need that for the input and that we can share our knowledge, whether we can fix something in other Linux distributions if anything is happening and another Linux distribution has got a solution. And additionally on top, we say also upstream developers are welcome during our meetings, and our sponsor has been SUSE at the beginning. Our goals at the Linux distribution working group is to create a place to collaborate across Linux distributions via an open mainframe project, mailing list, wiki, and chat. Yes, we have got a wiki, we have got a chat, we have got a mailing list. Our mostly used place is the mailing list, because you can write there, I have got a problem, can we fix that, can we receive support, and mostly you receive support within 2 or 3 hours from IBM side or from other Linux distributions. And that is providing also a space for distributions to request for help on their S390X port then. And then a topic from Elizabeth, we want to ensure any and all infrastructure which is required is available for supporting the ports. That is the mainframe in the background. Red Hat and SUSE have got mainframes. Canonical has got a mainframe. Fedora is using the Red Hat mainframe. OpenSUSE is using the SUSE mainframe. And Debian has got our own mainframe. Alma Linux and Rocky Linux have received also infrastructure. But a case what I want to give as an example in to this goal is that nobody on Debian's side from the infrastructure sponsors wanted to be responsible for the mainframe anymore, and the CI/CD pipeline, as an example, didn't work anymore. And and that was the reason that we said, okay, we want to transfer all the pipeline stuff into the Linux One community cloud, that IBM can be responsible for the infrastructure for Debian continuously. Therefore, if anywhere will be a shutdown of a mainframe, our Linux distribution working group has got this goal, and therefore you will receive a new mainframe, or you will receive a transfer of the mainframe, or the community distributions, as an example, will receive alternative mainframes where they can receive infrastructure for pipelines and buildings. Then the topic what I wanted to have within it is the better support from IBM to fix S390X specific bugs. In the past, that has happened mostly for enterprise distributions only. Now you can receive support continuously and really fast, I would say. If I want to create a bug report because of a kernel problem, I'm receiving the bug fix within 1 day now. That is a really improvement, I would say. Therefore, if you are writing to our mailing list or sending a bug report to the program managers at IBM, you have got a really fast response there now. From that, we are coming to our collaborative process. We want to collaborate and support each other. We don't watch us as competitors anymore. And we are doing our problem discussions on our mailing list as a first step. We can reproduce issues sometimes in other build pipelines if anything is happening. we have got open discussions on the mailing list about problems, and when we are forwarding issues and ideas of improvements for IBM. As an example, the SUSE kernel developer wanted to receive an improvement in the tooling suite for the kernel configuration. The distinguished engineer Ulrich Weigand has interacted. A nice idea, I will forward, and within 2 weeks they created a patch for that. Therefore, yes, the distinguished engineer Ulrich Weigand is also available on the mailing list and in our discussions. And then we have got collaborative small projects. I will bring in on the next slide the example with OpenQA. But anyways, we have got also monthly meetings, which is a come together with a review. What has happened in the last month? Is all resolved? What has been happened on our mailing list as an input and to-do task, and then a discussion what we want to do next and whether we have got new releases and everything else. Therefore, we are reviewing all and we are creating new goals for the future there. One small project what has happened is also the S390X test contributions for OpenQA. Some of you will know OpenQA is a testing suite from OpenSUSE, which has been used also for Fedora, Debian, and Gentoo in the past, and of course SLES. And Alma Linux has joined using OpenQA and said we want to enable the support of Red Hat KVM in OpenQA. They did that. We have announced that on our mailing list, and Rocky Linux stepped up. We want to use it also, and we want to integrate also our contributions. Therefore, we are now OpenSUSE, SLES, Fedora, Debian, Alma Linux, Rocky Linux, and Gentoo. And we said afterwards, contributions to our general OpenQA repository here on GitHub is of course welcome. Therefore, it is a good point that we start also a collaboration for OpenQA, that all enablements and test suites are coming together, and every Linux distribution can use available tests. That should not be only for S390X. We want to have it also for x86 and other architectures. The difference finally should be Linux distribution specific stuff. Therefore, the needles, the screenshots are different, perhaps, and perhaps the distribution specific configurations. From that, we are coming to the topic, are there any problems during your development process for S390X? Because we want to be the point of contact for all Linux distributions if anything does not work on the mainframe during the process. Problems are affecting mostly all Linux distributions, and you as developers also, and not only one single person or one single Linux distribution. We are receiving fast support via our mailing list of the Linux distribution working group. We can reproduce build issues. Sometimes we have got situations that only one Linux distribution is affected, but that is mostly based on the kernel version, that Ubuntu, as an example, is using a special older kernel version, or OpenSUSE Tumbleweed is using the latest kernel version. The same as Fedora is using another kernel version. That can happen that something will break based on the kernel, but that will be also in our focus, and we will support there. But mostly that should, on application level, everybody. The IBM Distinguished Engineer is responding on development problems. Then I have forwarded also upstream project issues where the developers didn't know how to enable this software for S390X. Anything small didn't work. I have forwarded, and the fix was available within 3 hours. All were happy then. That is also possible. Therefore, if you know anything related to that, you can forward it to our mailing list with the WG Linux distros of the Open Mainframe Project.org. And afterwards, we are receiving solid solutions also for upstream, mostly within hours or some days. If you want to know something like that also for ARM, I know that Linaro, as an example, is providing such a mailing list for ARM-specific problems for all Linux distributions. Then we had email discussion at OpenSUSE about that, and security related. There exists a mailing list for all Linux distributions. Therefore, you can find something for mostly all architectures already. Now you want to, I expect you want to know how can I develop on a mainframe without having my own mainframe at home or in the company. There you can find the Linux One open source software community cloud and the Linux One community cloud. You can receive AVM for 120 days for developers, students, and professors in the Linux One community cloud. You are creating your user account and you are receiving access. The account will be removed afterwards, and a recreation is possible, but the best case is you can receive also, as an open source project, long-term VM access in the Linux One open source software community cloud. You can use this virtual machine request, write down any reason for what you want to use it. You can define which size of memory, CPU, and everything else you need, and when you can receive it. As an example, I have received 7 VMs for development and hackathons for our OpenSUSE C systems team. And the single thing what you need is any open source project as a reference. Now we are coming to the last slide. Finally, I can say collaboration we can watch as a benefit. Upstream contributions are available for all. We are lowering the research and development costs. That's valid for IBM, the community, and every open source enterprise company. We are receiving the same solutions for all Linux distributions. We are sharing our knowledge between the communities, and finally all are happy and are receiving the fixes faster. And then we are receiving diverse community ideas. Every Linux distribution has got another thinking, has got other ideas, and with that you can increase also innovation. And on this way we can accelerate the Linux development for S390X. Now we have got some minutes left for questions. Oops.
I have a stupid question. First of all, I'm just a user of IBM systems. I'm not an admin. I just the S400. I know how to operate those into
Yes.
compile programs and stuff. I wanted to try out Linux basically, but then hardware becomes a problem. I understand I can access this with an open source project, about running into Linux's on Hercules on the emulator. So there is an S390X.
Yes, you can use QEMU already as an emulator, as an example. And there's also Hercules available, but IBM does not really support Hercules, I would say. But they have got, yeah, some people are laughing. I wrote my bachelor thesis based on QEMU. IBM has got also a KVM team related to that, I can say. But if you want to develop and building stuff, I can really recommend these two links. If you want to use it only one time, you can use the 120 days version. If you are a Fedora contributor or anything else, you can order for yourself via this link. The hint is that you can only choose between Ubuntu, RHEL, and SLES as a foundation. Therefore, you have to choose one of them, and if you want to build on Fedora, then you have to use KVM or something like that within it. SLES is possible that you can upgrade to OpenSUSE, where we have got a method that we can use zipperdup on OpenSUSE repositories, and we have got OpenSUSE in our VMs. I am working on it that I can receive IBM to the site that they want to support also community distributions, that Fedora and Debian can be also integrated there. But it seems that it needs some time because that is not officially supported. Therefore, I can recommend using QEMU for S390X. And then you should have got a good emulator that has been improved within the last 10 years. That's the best choice related to emulators.
Does IBM still hate the emulators or not? I know that in the past they didn't like them very much.
They didn't like it really much, but my bachelor thesis was about something like that related. I should create container images, build it and run it, integrate it into QEMU emulations, and that was then a transfer from Cassandra as an example, exported to X-Sphere, and then the emulated VM should start on x86. That was an interesting bachelor thesis project, I would say. You can see also my bachelor thesis under my name as Krish at /bachelor thesis on GitHub. But yes, they are working on it. It was not really wanted in the past, but IBM wants to become open source, therefore they have improved that, and this method is the method they want to provide open source projects who don't know anything about mainframes in the background of GitHub or something like that. IBM wants to receive enablements of open source projects, that they are not responsible for that. Therefore, anyway, it has to be enabled. And on the other side, they want to be responsible for the foundation, kernel development, KVM, network devices, and everything else. And therefore, you need a solution where you are supporting the application development on community side and stable foundation on IBM side. Nice.
I didn't want to fight with it really, and also I have some family stuff, so I decided that
that's the other one I'm planning to do it at.
It will be closer, like when it was in here in Hungary and everything, it's easier.
Yeah.
So, and also the budget is quite tight, so
yeah, I was surprised our whole team is getting to a flock, which I was not expecting to happen. So. I don't know why our budget worked out that way, but. All right, we got some people. Good.
Folks.
Yeah, it's just.
Welcome everybody. I'd like to introduce Adam Williamson. Most he's very famous, so I don't need any introduction. Pressure. This is about Fedora and QE. So all yours.
Okay. Hi everybody. I'm Adam Williamson. I've been working on Fedora QA for quite a long time now, since about 2009. And this is Miro Vagkurti, who is helping out with the Fedora CI parts of this talk. I'm going to kind of get right into it because the slide deck's pretty long, so I want to make sure we get through the time. Miro, do you want to do a quick personal introduction?
Yeah, so I'm Miro. I work mostly on Rails CI, but we have some infrastructure also in Fedora. And I'm a Fedora contributor. We are providing some infrastructure for running the tests via the testing farm service. That's it. Okay.
So yeah, what we're aiming to cover today is, it's not going to be a deep dive into the technical details of the systems. What I want to talk to people about is what are we actually testing, what is this achieving, and for people who are Fedora package maintainers, how do you interact with it and how is it helping you? So let's get going. A little bit of quick background. How do we test an operating system? This is a huge topic. It's a challenge, deciding what to test, when to test it, what's going to be most useful, especially with the resource constraints we have and the time cycles we operate on. So there are 4 levels right now at which you can really do testing within Fedora. There's package source control, so Fedora packages are stored in a Git repo, and you can do testing on things that happen within that repo, pull requests, commits, anything you want to do in there. You can do testing at the level where builds happen. When you do a single package build within Koji, we can trigger tests on that. You can do testing at the level of the update, which is the sort of abstraction we have for getting feedback on single builds of packages or multiple builds of packages before they actually go into the distribution. And we can do testing of composes, which are when we build the whole of Fedora together and actually produce the images, Docker containers, disk images, whatever you like that we ship to users. We can test the composes. So the background, manual testing, ye olde days. So this is up to about 2015, which is going to get covered on a later slide. Back in the days before we started getting better at this, we basically didn't really do any testing at the dist-git level. Just maintainers who were really keen might self-check themselves somehow. They might have some little script they run on it. But there was nothing automated. The Fedora QA was not really doing anything at that level at all. Build testing, all you could really do is have a check section in your package, which many packages do, and it's a good thing to have, but it's not really sufficient. And that would usually it just runs the unit tests from upstream. Update testing, once Bodhi came in, the point of Bodhi originally really was to allow for testing and feedback on updates so that packages didn't just randomly go into the distribution and break stuff. But before we started doing automated testing, it was really just down to people doing it. So maybe if your package is really popular, if it's Firefox, you're going to get a lot of feedback. If your package is not that obvious to users, even if it's really important, it may never get any feedback at all. It was very haphazard. Maybe this build gets tested, but this build doesn't. And what actually got tested from build to build, again, was just kind of down to people. So it was very varied. It was very inconsistent. It's very difficult as a manual tester to test whether an update breaks other things, and especially whether it breaks Fedora composes. So we had almost no testing of that. And compose testing was the thing we mostly focused on, I guess. And we were getting pretty decent at it, doing it manually. We had a whole process for it, which I'll cover soon. But it was very time intensive. Anyone who worked on Fedora QA back then, my life was just booting up 6 VMs every day and doing install tests and wishing I was dead. It was not much fun. Incredibly boring, and even the amount of work we put into it, as humans, you can't test every compose. Like, we would test, you know, some snapshots every cycle and then the release candidates. So we'd test, I don't know, 15, 20 composes a cycle, but there are hundreds each cycle. So we were not covering very much at all. Little history of how validation testing worked. I'm a history nerd, so I love this. On the left here, this is the earliest recorded formal validation testing of Fedora I can find in the history, which is Fedora Core 5. And this is a wiki table. And there were 26 tests in it, and the 2 people did almost all of them. As a test, I'm just counting a row. I'm not counting the environments, because counting that is harder. And then up to Fedora 21, which was 8 years later, I think, we were still using wiki tables, but they're much shinier and more color-coded, and we had got up to 138 tests. Fedora 21 was the last release before we really started doing automated testing. So that was, you know, as far as we got with humans doing all the testing. Did I miss anything on my notes here? Yeah, so this is like 6 times as much work as we've been doing on Fedora Core 5, but it still wasn't enough. We weren't covering everything. We were missing bugs. We were taking too long to catch things. Like, we would often only find something when we got to beta, but it had been broken 3 months earlier, and tracing that out was a nightmare. And just as a note on the test counts, Fedora 39 now has 202 tests, so we've continued to kind of scale the amount of testing we're doing that way. So that was, you know, that was as far as we could really push manual testing. We were at our limit at that point. So we came to the conclusion that we need to do automated testing. What are the automated test systems that exist in Fedora right now? The key 2, I'm going to cover other things very briefly later, but the key 2 are Fedora CI and OpenQA. So I want to do a little bit of explanation here. One of the questions we often get is, why are there 2, you know, automated test systems in Fedora? And this has been a process and a history, and there's a lot of nitty-gritty in the background, but we've come to a pretty good understanding of why this is and why it makes sense and why we had them. Fedora CI, the point of Fedora CI is really to provide CI-type workflows, infrastructure, processes to people operating in the Fedora environment. Fedora CI, the people who work on Fedora CI don't wake up every day and say, is Fedora broken? They wake up and say, are the tools and processes we're providing to Fedora people, are they working? Are they good tools? How can we make them better? That's what Fedora CI is about. Providing CI services to people working in Fedora. OpenQA is there to do testing of Fedora. OpenQA is literally the automation of all the stuff the Fedora QA team was trying to do manually and really burning out on. That's the point of OpenQA. OpenQA is there for us to be able to figure out if Fedora is being its best possible Fedora. It's not a service we're providing for other people to write tests of their thing in the Fedora environment. That's not what it is. So with Fedora CI, the system is the point. That's what Fedora CI is, systems and processes and, you know, interconnections, and it's the job of Fedora CI is to provide testing systems for you all to use. With OpenQA, the system isn't the point. We just use OpenQA because it was a thing that was there that worked to do the job. The point of OpenQA is helping us figure out, is Fedora broken? Who broke it? What broke? How do we fix it? That's what OpenQA is for. OpenQA is specifically not about letting other people come in and run tests of their thing. We kind of thought about going down that road several years ago, and we've specifically decided against it. You can contribute to OpenQA, but it has to be within the context of what OpenQA is there for. So if you want to contribute something which helps us test whether Fedora is great, perfect. But if you want to test your little widget in the Fedora environment, that is what Fedora CI is for. So that's kind of the distinction between the two. OpenQA was started by the QA team in 2015 as a Skunkworks project just to automate our stuff. Fedora CI started in 2017, and it really came out of we try to be transparent about the relationship between Red Hat and Fedora. Fedora CI really came out of an effort within Red Hat to reduce the distance between Fedora and RHEL where it came to testing, automated testing, because how we do things in Fedora is completely different from how we were doing things in RHEL at the time. And Fedora CI is part of like a coordinated effort to try and make it possible to share more things across RHEL, CentOS, Fedora. So Fedora a large part of Fedora CI is making it possible to take things we have within Red Hat that were never applied to Fedora and make it possible to apply those tests to CentOS and Fedora. So I am going to go, Miro will talk about Fedora CI after I've done OpenQA. I'm going to go into sort of details of what OpenQA is and what we're doing with it. So what OpenQA, its an original strength, what it's really good at and what is really cool is that it tests like a human. Like, I'm not going to go into details of how it does this, but OpenQA is effectively running a virtual machine, looking at what's on the screen, looking for little areas of the screen that it expects to see, clicking on them. It can also type things. So it can type commands, get the results out. And so it's great for automating manual QA testing because that's what we did most of the time. We span up virtual machines and clicked on things. It's also great because it doesn't care about the operating system at all. You can use it to test Windows, Linux. You can use it to test firmware interfaces. All it needs is a VNC connection to the computer and a way to click on things. So it is really appropriate to what we're doing. And as I said, what we're trying to achieve with OpenQA is high-level functional testing. It is not here for unit testing. It's here to tell us, is Fedora broken, right? Is something that we care about, something that is part of what we want Fedora to be for people in the world, is any of that broken? That's what we're doing with it. So what do we actually test with Fedora? We run a standard set of tests. I think there's about 200 of them on every Fedora compose. Also, we run a subset on CoreOS composes, IoT composes, cloud composes. Anything that's a compose in Fedora gets tests run on it. We also run a subset of tests plus extra tests, about 50 to 60, on critical path updates for every branch of Fedora. Stable branches, branched, and rawhide. Any critical path update gets the tests run on it. If no one knows what critical path is, it's really just the set of packages that are most important, and this limitation is purely resource-based. I would love to test every update that goes out, but we just don't have the capacity for it. So this is what the OpenQA web UI looks like, and if you're not part of the Fedora QA team, you actually don't need to look at this very much, but I wanted to make this talk, practical and really show what things are looking at. So on the left-hand side over here, this is just a subset, but this is a view of some of the tests that were run on, this is a compose from a few days ago. These are most of the tests that ran on the Silverblue installer image. And down the bottom, you can see one of them failed, rpm-ostree_rebase, which does what it sounds like. It tests rebasing, an rpm-ostree type install. On the right here, these are two different screens. I'm just switching them onto one slide for, complexity. On the right here, this is what that fail test actually looks like. And you can kind of see there's a bunch of screenshots. When it's got a green outline, it saw what it wanted, or a command did what it was supposed to. Where it's got a red outline, it didn't see what it was expecting to see. And you can click on each of these, and you get a full view of the screen. And you can see, like, the top here it's in emergency maintenance mode when it was expecting to be a booted system. So that's kind of what you get with the OpenQA web UI. And this is a real thing. You can't rebase from rawhide to 38 at the moment because of, I think, an SE Linux thing. So that's how that works. What do we actually cover with the OpenQA compose tests? We cover 75% of the validation test suite, which is the set of tests that need to pass for a Fedora release to go out. The things that aren't covered are things that are very difficult to automate or things we explicitly don't want to automate. We always want to have a human in the loop. So we always want a human to test that the images actually boot and install on a real computer, a real container, a real virtual machine, just in case the automating testing system missed something, So I never want to release an image that no human has actually tried to boot up. So we can't really do 100%, but we do our best. We also cover some stuff that's not release blocking, like we test Silverblue, which isn't technically release blocking, but is very important, so we want to test Silverblue. A lot of the tests are install tests. We really exercise a lot of the installer. We install a bunch of different images. We test different package sets. Can you install GNOME, KDE, Minimal, a bunch of different ones. Different partition layouts, ButterFS, XFS, EXT, LVM, thin partitioning, whole laundry list of different partition layouts. Languages, we test English, Arabic, French, Japanese, and Russian to cover a kind of different fonts, different symbol styles, and also right to left. which is very important. We test different firmware types, so we do installs on UEFI and BIOS to make sure they both work. But we don't just do install tests. OpenQA started out mainly doing install tests, but these days we do a lot more. We have the base tests are, the core operations for any Fedora install. Can you install a package? Can you remove a package? Can you update a package? Does logging in work? Does logging out work? Does rebooting work? Is SE Linux in enforcing, just in case we mess that up sometime? Hasn't happened yet, but it might. Can you start services, stop services, restart services, enable services, disable services? All of that is tested. System logging, is logging working? Can you get the journal? Upgrade tests. We test upgrade of all the release blocking package sets. So, workstation, minimal, KDE, server. We test them N1 and N2. So we test, 36 to 38, 37 to 38, both of those. And we also do a test that a free IPA deployment can be upgraded, an entire deployment, server, replica, client, upgrade them all, make sure they're still working after the upgrade. So that's one of the more complex tests we have. Graphical desktop and application tests, we test GNOME and KDE, a lot of their core functionality, the overview, the user menu, all of the stuff that you expect to work on a desktop. We test that every installed application at least starts up and stops. Trying to test of them all functionally is a lot of work, but we'll test that they don't just crash or just not launch at all. On GNOME, my colleague Lucas, I don't know if he's here. Anyway, he has been working on writing a bunch of GNOME application tests. So right now we test about 15 GNOME applications in quite a lot of detail. Like the maps application, it does a bunch of stuff. Can you look up a place? Can you do a route? It's real proper detailed functional testing of the apps. We test desktop login, which isn't just login, but also can you log out? Can you switch users? Can you lock the screen? Can you unlock the screen? Can you reboot from the login menu? That kind of stuff. We test that notifications work, which includes testing that on a live image you don't get update notifications, which is an important one. We test printing using virtual printers, obviously. And we test upgrades, updating and upgrading. Yeah, so that's pretty intensive. And we test, all those tests run on Silverblue, and we also run all those tests on an upgrade as well. So we upgrade Workstation, and then we run all those tests to make sure they still work on an upgraded system. We have a bunch of server functionality tests, like the key features of server, free IPA, a database, Postgres, and Cockpit. We do a bunch of functional testing of those. Do they work? Do they show what they're supposed to show? So for every single compose, we are testing all of this stuff. Like every time a nightly compose comes out, all of this gets tested. Update test coverage. We don't run all of those tests on every update, again, capacity issues, but we run about 50 to 60 tests. And this has got a little refined recently because we were doing stupid stuff like running all the GNOME tests on KDE updates, which was just idiotic. So I did a lot of work to split up the critical path into groups, and that allows us to only run appropriate tests. So not every update runs every test anymore, but there's a total of about 60 tests. We do the tests I talked about on the last slide, the KDE workstation and server tests, not all of them, but most of the key ones. Again, a subset of the base tests and the desktop tests. Free IPA, Cockpit, and database tests, I think we run all of them pretty much. And then one thing that's really important and I'm pretty proud of is for every single CritPath update, we're building a network installer image, a GNOME Live, a KDE Live, and a Silverblue installer image, which was a lot of work. And making sure you can do that build, you can run an install, and the installed system works. So what this is really testing is that the update doesn't break the compose. So we know that, once we push this update, the compose process is still going to work, which was really key. And yeah, again, just a key thing to note, again, from earlier on, when we're testing an update to, libfoo, we're not testing, is this libfoo the best libfoo it can possibly be? We're testing, does this libfoo break Fedora? And this is always the goal for OpenQA. All of the testing is in the context of making sure Fedora is OK. So yeah, I mentioned this already, but the main limitation is really just the test runner capacity. I would love to run more tests. I would love to run all the tests on all the updates. I would love to go across arches, but we just don't have the machines. If someone wants to give us more machines, that's great. I'd also like to thank the Meta folks, because they're planning to hire a contractor to work on cloudifying OpenQA, which would be a great way to get more test resources. So I'm hopeful we'll be able to get somewhere with that soon. So scale and success, just a perspective on what we're actually achieving with this. We have 2 instances of OpenQA, a production and a staging one. In staging, we test more arches. We have PowerPC in staging. Right now, we run over 100 tests at a time on each instance, I think. We've run over 3 million tests since 2015, discovered hundreds of bugs. 358 is just bugs that are tagged OpenQA in Bugzilla, but that's a huge undercount because I only started tagging after a while. And a lot of things, we just fix it because I'm a proven packager, so I just fix stuff. Or we file issues upstream, so it's a lot more than that. In a typical day, like just a typical day, not a busy day, there'll be 1 or 2 Fedora nightlists, depending on whether branched exists. There'll be 3 CoreOS or Cloud Composes, and we'll test about 20 updates. On a busy day, you can double or triple those numbers. Just some examples of recent bugs that OpenQA has caught. Right now, there's 3 failures that we know about from the EFI system partition size increase thing, which I've filed. In the past, we might not have noticed that for another 2 months. Firefox just crashing on startup, which it does, so we caught that and we got it untagged, so that doesn't affect Rawhide users. The Arabic translation just disappearing from the installer, that was a fun one to catch. Notifying about updates when running live, that started happening and we caught it. And that's just the first page of search results. I just pulled up the first page of most recent results from Bugzilla, and that's what's on there. Another example that happened recently from update testing, a new util Linux build. It was mounting the root partition read-only, which obviously makes the whole thing not work. And in the past, that would just have landed in Rawhide, and the next day, people would have been like, hey, my Rawhide system isn't working. But instead, we caught it, we got util Linux untagged. Nobody saw that, except people who were running the test. OpenQA resources, yeah, this is the thing I mentioned earlier, but it's important. We see OpenQA as like a service we provide to Fedora, the testing. We don't necessarily want packages to be trying to debug failures themselves. So we don't just run the tests and run the system. We investigate the failures and we make them actionable. Ideally, we fix them. If not, we at least turn them into a useful bug report so you don't have to look at the OpenQA results and try and fix it yourself. So that's the philosophy about OpenQA. If you need to contact us, we have a mailing list, Fedora chat room. The upstream site, I should mention, OpenQA is originated by the SUSE folks. It's a great system. We're really happy to have it. We collaborate with them, but thanks to them for all the work they put into it, and that's the upstream site for it. There's a wiki page which kind of explains the Fedora deployment. And this last point I added after the keynote, I really love the keynote. OpenQA is an open source service. Everything is open, not just the code, but all of the stuff that we've written around it, the tests, the scheduler, and it's deployed via Fedora infrastructure Ansible scripts, which are in a Git repo and you can contribute to. And you can even do a pet OpenQA deployment using those Ansible scripts, and it should mostly work. So you don't have to contribute to OpenQA, but if you want to, you can. And I'm now going to hand off to Miro to talk about Fedora CI.
So hey, so if you want, so Adam has less work, then onboard your tests to Fedora CI. Because once you do that, you do your part, that your software is stable, and then will have less work, and he will be glad. Right, so Fedora CI is here for you, that you as a contributor to Fedora can do your part. You can stop basically your build, which sometimes breaks, it's software, right? You can stop it before it enters Fedora. If it enters already Fedora, it's on Adam. That's the story. So what can you do? Fedora CI, it's a maintained by community. It's very close now to what we do in RHEL because it has it's done similarly. There is a Jenkins instance, which is actually calling testing farm, what my team takes care of. It's fairly stable and it works well. You can see the documentation here at the docs. There is also a nice how-to guide to get you started, quick start guide, really copy-pasting stuff, and you can add your test, whatever that is, in Fedora. There are 2 places where you can run tests. First is, I can watch here, sorry. So you can run tests. The tests are always placed in this Git repository. You just drop there some files. The tests don't need to be there. They can be linked from GitHub wherever you want. That's thanks to TMT, because it can share tests with the upstream repositories and so on. So it's maintained by you. It's your responsibility. You can, of course, ignore the results. Fedora is not gating. It's not gating your dist-git pull request. You can open a dist-git pull request if you have the test there, like it will be reported, but it's not gating. You can just merge it if you want. If you, then you will break maybe Fedora. So yeah, it can be made gating. Like I think Zool has capabilities for that. So that's the first place. Open a dist-git pull request. Nothing gets yet to Fedora. Test will run. You will validate it that build that was built from the dist-git pull request actually works against Fedora. And before breaking Fedora, you can fix it. You can also run tests from other components. For example, I would love if Linux would run Cockpit test suite, because Cockpit touches a lot of components and so on. So it would be great if the great Cockpit test suite would run for Linux, and then maybe less work later on for IDEM. So yeah, so that is one thing. Then also the tests are run for validation after merging. So once the stuff gets to rawhide, there is no gating again. So on Bodhi, you can again see after the production build was built, you can see the results on Bodhi. So that's the second place where Fedora CI runs. And also OSCI team, which is the second team who is running this stuff, is running some generic tests, installability, RPM inspect, and RPM deplin. They really try to make sure that those packages are installable without issues. And RPM inspect makes sure that your sanity of your RPM is fine.
Next slide.
Sure. This is all I said before, sorry. I think like if you want to do it super smart, do it via packet on GitHub or GitLab. If you are lucky that your upstream is there. If not, then you can do it on this git merge request. That's a better place, and the worst place is after merging when stuff already gets there. We would love to start gating. You can enable gating on Fedora, so your tests can be gating, but currently they are not. It's really on you to make them gating. That's it.
Yeah, I do want to just quickly highlight the packet workflow. If people aren't familiar with that, if you kind of really buy in, it's a cool system because you go from your upstream project all the way to Fedora in kind of one workflow. So you have your packet configuration upstream and you have your tests upstream, and then you can do all your development upstream, and all the packaging stuff kind of happens automatically, and the tests get run on your upstream pull requests, on your spec val pull requests. It's a really nice integrated workflow with all the testing in the background happening via testing farm, which is Fedora CI's backend. So that's a cool thing that it's worth checking out. Have a look at packet. Yeah. Others, I'm just going to blow through this really fast. There are other things which kind of are automated test systems, even if they weren't intended to be. So Koche, which is anytime your package's build dependencies change, it tries rebuilding it in Coper and tells you if it's broken, which that's effectively a QA thing, so it's kind of cool. Fedora Release Auto Test is written by our colleague Lily Nye, another person on my team, and that runs tests on weird hardware that we can only really do in Red Hat's Beaker. Beaker is a Red Hat internal like test farm thing, so it can test weird enterprise storage things like Fiber Channel over Ethernet, iSCSI, and things that we can't really test in OpenQA. So that's really neat. So that automates those tests, which were really hard to get done before. RelVal, which is a silly thing for reporting results manually to the wiki, also actually, when a release validation, when a new candidate release comes out, it runs the size checks automatically and files those results into the wiki. So that's kind of an automated testing. Fedora CoreOS has its own entire like CI release workflow, which is really cool and really integrated, and it's very modern. You know, Fedora is kind of old, and we're bolting all this stuff on afterwards. Fedora CoreOS was invented much later, so they have a really cool cycle, and they do all their own CI. Zool-based CI is getting tests run in Pagure for your project, and Packet I just mentioned. Result delivery reaction. So testing is one thing, but you have to do something with the results, right? So this goes back to that earlier slide about the 4 places testing can happen. So dist-git is like the earliest place you can get your test results in. So you know, your package is in dist-git. We have a Pagure user interface on the front of that, which is, you know, the GitHub style Forge thing. And your pull requests, if you manage your package, if you actually do pull requests, which not all package maintainers do, but if you do pull requests, then your tests that are in your repository will get automatically run, and you'll get the results in your pull request, as Miro mentioned. And you can optionally have your pull request gated on those results if you want to. So this is like the earliest point you can get it in, and if you're disciplined to use the pull request workflow, it's really useful to have all your test results at this point. Bodhi, the web UI of the package of the update management system is probably the main integration point for results. This is where you're most likely to actually see your results, I think, for a normal packager working in a normal way. On the automated tests tab in Bodhi, you get like a list of all the test results, and this is, you get your Fedora CI tests and your OpenQA tests all together. The ones that have Fedora-CI at the front come from CI. The ones that had update at the front come from OpenQA. But because the backend, they're all kind of compatible, you get all the results in Bodhi. We've improved this quite a lot recently. The first version of this talk had me apologizing a lot for a lot of the bugs in this view, and I'm hoping people may have noticed it's got better recently. We would have weird things where the sync between the back end and the front end of Bodhi was off. So one would say your package was gated, and one would say it wasn't, and hopefully that's been fixed. You now see running state. So when a test is queued or running, you will see it on this tab. Before, it would just say the result was missing, which is confusing. But now it actually tells you that the test is running. Wait a bit, and you'll get the results. So yeah, new queued running status. Fewer bugs, hopefully, more consistency. Right now, updates for stable releases and branch releases are gated on most of the OpenQA tests, which means if one of those tests fails, your update cannot go stable. Right now, Rawhide is not officially gated. I'm probably going to turn that on after this talk. I wanted to do it during the talk, but we're running out of time, because FESCO has approved it, I believe, and that'll be a big thing, but anyhow. We've been shadow gating Rawhide for a while, which means when we find a bug in an update for Rawhide, we will untag it before it makes a compose. So effectively, Rawhide has been gated for several months. We just weren't telling anyone about it. That's me and Kevin Fenzi. But it's been working great. It's made Rawhide way more stable. Yeah. Packages can configure additional gating requirements. So if you want to gate on the tests that are in your repository, you can drop a gating.yaml file in your package repository, and it will be, those tests will gate. There's a button for waiving bogus failures. If any test is failed and it's blocking the update, there's a button that says rerun, that says waive failures. Please only click that if you're really sure the failure is a bogus one. There's another button for rerunning the tests. If you think the result might be a bogus one, hit the rerun tests button and see. If it keeps failing, then it's probably a real problem or a bug we need to figure out. What do you do if you see a failure in Bodhi as a packager? If it's a test that you put in Fedora CI yourself, you should probably go ahead and debug that. That's your problem. If it's one of the generic tests, which are the installability, RPM, deplint, something like that, that shouldn't gate the package by default, but maybe you've turned on gating for it. Try and debug it. If you can't, then contact the Fedora CI team, and they will help out. OpenQA failures, again, this is part of our full service model. Like you can, if you're really keen and impatient, you can try and diagnose the failure and figure out the details of OpenQA. But if not, just stay calm and wait. And usually I refresh the OpenQA web interface about 12 times a day. Like I'm always looking. And anytime I see an update failure, I am going to investigate it. I'm going to either fix it or I'm going to file a bug for you. So you will get a report which you don't need to know how OpenQA works. You will just get told what's going wrong, and I will ask you to help fix it, right? So if you need help, you can contact us on Fedora Chat, the mailing list, send me an email, carrier pigeon, whatever you like. And yeah, rerun the test if you're not sure if the failure is genuine. Waive the results if you're really sure it's not a genuine failure. For problems in Bodhi itself, you can contact CPE, the Fedora infrastructure team, or you can contact me because I sort of work on Bodhi too, so I know how to do it. And quickly, yeah, we still use the wiki. Like 20-something releases later, we still have tables on the wiki with all the results in them. The reason we do this is just because it's the only way we have to integrate automated and human results. So we still need some manual testing for composes. So people put their results on the wiki page. And a crazy thing I wrote lets OpenQA file its results into the wiki. So when we're deciding whether to release a Fedora release, we go and look at the wiki page and we check that all the tests are covered and all the tests passed. That's why we still have the wiki. I'm going to skip over this because we're short on time. Just wanted to say that there's a lot of stuff behind the scenes here, and this is all shared between Fedora CI and OpenQA. Like on the front end, they're different systems, but the way they file results, the way they all talk to each other is all kind of integrated and shared. I really like this slide. If you've been looking at cat pictures for the last 30 minutes, but you want to say you came to this talk, take a picture of this slide. This is everything. This is the whole talk. Updates and composes are tested by OpenQA. Package builds are tested by Fedora CI. We don't gate composes right now, but we review the results. We gate updates. You can gate your pull requests in dist-git, and Koche does FDBFS. That's what we've been talking about the whole time. The future, again quickly. What are we doing with OpenQA? We want to do more tests. We're always writing more tests, so cover GNOME applications. Gate rawhide updates. I would really like to turn that on, and I'm planning to soon. We'd like to cover more arches. That just needs more hardware. Cool thing we're working on right now is doing bare metal testing in OpenQA, which uses Raspberry Pi KVM, which is a really cool project. More tailored update tests. So because we now have this grouping thing, I kind of want to do, let's run all of the installer tests when we have an Anaconda update. So that would be cool. And maybe move it to the cloud. Fedora CI plans, Miro.
We are almost out of time. One thing, if you have STI, we are going to get rid of it. So migrate to TMT. There is a nice guide. That's the most important stuff for this. Otherwise, like I think Fedora is quite stable. If not, then you can reach me on chat, Fedora Project or Fedora CI. We are there to help you.
Okay. And if you watch the recording of Miro's talk, he has a lot more about all this stuff in it. Other plans, yeah, one thing I skated over, the biggest challenge we have right now, lots of other things go into making a Fedora compose. The kickstarts, the comps, Pungy configuration, workstation OS tree config, which is actually where all the immutable configuration lives. And so when these things change, there's no testing. If you make a mistake when you're editing comps, the compose fails, and we just don't know about it. So I would love to do some stuff to do more testing of these, but that's, you know, we got to have plans. And we made it through the slide deck. Thank you, everyone, for sticking with us by talking fast. I think, do we have 5 minutes for Q&A, or is that the slot? 5 minutes. Okay.
I know this is probably going to, get another request for more testing, but can you maybe test Turkish, because it has some weird thing with uppercase and lowercase that recently fit as an openness?
Okay, cool. Yeah, we could. So the question was, can we also test Turkish? Yes, we could. Onboarding a new language just requires doing quite a few screenshots, but yeah, we could. We do have an issue tracker. I'll talk to you after the talk, but OS Auto-Inst distri Fedora is the project for the tests. And if you file an issue on there, or I will file one, yeah, we can definitely look at doing that. Cool. Okay. Yes?
I have 2 questions. One is suspend to RAM, suspend to disk, but I guess that will be mostly after that pipe KVM is.
Yeah, so let's do one at a time so I don't forget. The question is, can we test suspending? And yeah, theoretically we could test it because you can suspend a VM and resume it, but it's not very useful because all the problems with suspend and resume tend to be on real hardware. So yeah, that would be, that's one of the reasons we're looking into the real hardware testing, so yeah.
And the second question is application caches and debugging, like core file analysis and like downloading debug files and that stuff. Is that tested or not really?
Oh, sorry, I'm not sure what you mean. Application cache files and debugging?
Yeah, like if an application caches,
oh.
paste a core file and then I get.
Yes, good question. That's good. I kind of skirted over it. Miro can talk about CI, but in OpenQA, if the test causes, if there's an application crash, so there's a thing in OpenQA when the test fails, it runs a post-fail hook. So we upload a bunch of generic logs and stuff, but we do also test for abort crash dumps and core dump control crash dumps. If we find one, it gets uploaded. So there's a tab in the OpenQA web interface, assets, assets and uploads, I think. And if you click on that, for a fail test, you'll see a bunch of logs and any crash record that happens. So one of the things I do when I see a failure is, oh, there was a crash. I grab that crash, I analyze it, and then I file you a bug with a proper backtrace in it.
Yeah, I just want to say that maybe there could be a generic test for all packages for that. Like, maybe.
But then the test would have to run it to see if it crashes.
We can discuss
That's
later.
the tricky part. Yeah. Anyway, yeah. More questions? I think you had your hand up first.
Let's take one more and then we'll do it.
Okay.
Beer and the pool.
I think.
I wanted to ask how long approximately one test runs, and do you use some parameterization on this?
Great question. Yeah, so the question is how long do the tests take to run? For Fedora CI, it's very complicated because it all depends on, it's all in the test definition. For OpenQA, the compose tests, I believe, take about 2 hours to run completely. For an update, it takes, again, about 2 hours in total, but most of that is for the Silverblue test, which isn't gating. So for all the gating tests to finish takes a little over an hour, I think, mainly because of the live build and install tests, which takes a while. And yes, there's a lot of parallelization. So the way OpenQA really works is you have these things called worker hosts, which are systems that spin up the virtual machines and run the tests in them. And it's configurable how many workers will be on each worker host. We run on fairly powerful machines, so our main test boxes run 30 workers. So at any one time, they can be running up to 30 tests. That's how that works. Yep, you're welcome. All right, thank you so much.
Thanks for having me.
Yeah, thank you. Yeah, sorry I took up a lot of the time, but you did a good job.
This was fine. I think we
yeah, good job.
I think I said that what I wanted, like, okay.
That's fine.
Can you? Yeah, works.
So you can.
In the eBPF XDP department. Very nice guy. I highly recommend getting to know him better at the pool party tonight. But with that said, go for it.
Okay, thank you. Thank you for that introduction. Yes, so welcome everyone. Hi everyone, and welcome to my talk on developing modern eBPF applications. I'll spare the introduction, like I'm doing networking at Red Hat, mostly kernel and a lot of eBPF work recently. I have a few notes up front. I'm super happy to answer questions, but please keep them until the end and we can have also lively discussion about that. One thing, like the second thing, I designed a talk for an audience that is kind of knowledgeable in eBPF already, so it helps if you've already written eBPF, but hopefully you can follow along if you didn't so far. The reason for that is that my goal of the talk is to show you new ways how you can improve your eBPF programs, so you can switch from writing small toy programs to like writing normal eBPF applications, like bigger ones where you can do more complex stuff. Like I said, I'm working on networking mostly, so my examples might be slightly skewed towards networking, but that doesn't mean that they don't apply to tracing use cases. It's just my examples usually come from networking. All right, so let's get started. I want to cover basically 4 topics today. The first thing is modern eBPF. What do I mean when I talk about modern eBPF? The second thing is I want to show you how you can compose your eBPF programs, like the small programs you have, into bigger applications. Like there are different ways to do that, and I want to show you like 3 of them basically. The third thing I want to show is testing. So with growing complexity in the applications, how do we test them? How do we like go ahead and make sure they do what they are supposed to do? And the last one is I want to cover eBPF helpers and kernel functions. So those are basically the APIs that you can use from your program. And I want to show you how you can navigate that space and more easily so you know what functions, what APIs are there and which ones you can use. So let's talk about modern eBPF. What do I mean with that? What do I talk about when I talk about modern eBPF? I want to illustrate that with a few examples. I have brought some code snippets here. So all of these code snippets are from the samples in the Linux kernel tree. It's not important what they do right now, but I want to illustrate a few things with them. The first thing I want to illustrate is eBPF a while ago didn't have any loops. Like you could not write loops that you are used to in any normal programming language. Was not possible in eBPF. The only exception to that was you can ask your compiler to unroll the loop. So basically copy the contents, like the body of your loop, one after another, and run that instead. That, of course, like increases the size of your code, and it's not applicable to each and every loop. It has to have a like upper bound that you know at compile time already. Next thing that was not really possible was calling functions. So you could not just call a function like you would in any other language. It was just not there. The only thing you could do is, again, inline all the functions. So basically copy the contents of the function into your main program. So you have like a constant flow of execution. Or you could use so-called tail calls, which basically means at the end of your eBPF program, you jump to another eBPF program and execute that instead. But you will never get back to your old or previous function. So it's not really a function call. It's a way to combine programs, but not really a way to call functions. So let's see what improved in terms of loops. eBPF nowadays can have loops. Like you can write loops in your eBPF program. The first addition that we had there were bounded loops. So basically loops that have a fixed upper bound as well. So the verifier can really check, does this loop end at some point of time, so you can be sure that it doesn't prevent the kernel from continuing. With that, it was not necessary anymore to unroll the loop. Your compiler might still do it, but it's not necessary anymore. And it covered some use cases, but not all of them. So we later on had further additions to the eBPF or the BPF programming environment that were the loop functions, how I call them. So basically, the first one that I want to introduce is BPF loop. That's a helper function that you can use in your programs, and what it does, it takes basically a number of iterations, and it runs your, like another function, like a callback function, that number of times. And the number doesn't need to be fixed or constant or anything like that. It's checked dynamically at runtime. So at runtime, you can pass it a number that you got, I don't know, from a network packet, for example, and run the loop this and that many times. That's like, with that, you can probably support all the use cases you have for loops, right? You can do everything you want with. And then there are other functions that might simplify your life if you want to change, if you want to do something different. So there is BPF for each map element, and like the name already implies, what it does is it gives you a way to iterate over the contents of maps with keys and values. So all the BPF maps, you can iterate over the contents, basically. It's also something that was not really doable before, and at least not easily. And now you have like a very useful helper function to do that, and like a more convenient way for that. Let's talk about function calls as well. So eBPF now as well supports function calls, something that was not possible before. And if you now want to write eBPF functions, you write just a normal function like you would in normal C code, and the compiler translates it to real function calls, no inlining anymore, no nothing. Your compiler as well can still inline it, but it doesn't have to. And you can really have function calls. And with that, you get all the benefits of calling functions. You have better modularity. You have, like, your code size goes down if you're calling, like, if you beforehand had an inline function that you would call from many other places, your code grows in size. Now, if you have real function calls, like, it's reduced in size again. And one nice thing about it is that every function is treated by the verifier as its own program. So the verifier is that thing in the kernel that basically checks your programs if they are safe to run in the kernel. And it checks each function as its own program. That means that all the limits that the verifier has apply to one program or to one function at a time. So for example, the complexity limit, it applies to your main program first, and then it applies to the function you call second. So you can write more complex applications because you don't run into the limit of the verifier that easily anymore if you break down your application into smaller functions. So those things that I just said, like the function calls and the loops, that's just a few examples for what improved in the eBPF territory, so things that you can start using today. Now that we can split up our execution into like different functions, let's talk about how we can compose all these functions back together into like a big application or larger application. I want to introduce 3 different, or like maybe 2.5 different ideas for how you can do that. And the first thing I want to talk about is how can I compose programs together? Like how can I combine them at build time? Right now we have a super simple linker in BPF tool. So that's something that was added some point like a while ago. You can now call BPF tool and link together BPF object files like you would have done with your normal C object files in the past. It really doesn't, like, the linker is not that complex like it is like a normal linker for C user space programs, but you can really do the same basic thing with it. You can have your code in one file, you can declare your functions that you want to call in a header file, you can write the code for that in a different file, compile these things separately, and later on link them together to ship one big binary. But you have your code split over different files, so you can organize it nicely and so on. That makes it, like I said, easier to structure your code into something that you can maintain more easily, something that is very important if your application grows in size. And of course, with that, you can build stuff like static libraries, for example. So you can, for example, have a team that maintains all the parsing functions for your network packets. Like I said, I'm mostly networking focused, so parsing network packets is something that we do a lot, and you need to do often, and basically the code is the same all the time, because the network packets look the same all the time. And you can go somewhere and you can build your library, build your parsing functions into that, and then reuse them where needed. Like basically make an object file of that and link that into your application. So that's a use case for like these linkers. Another thing is, imagine you don't have all the object files available at build time. Imagine you want to link stuff at load time or combine programs at load time. The BPF tool functionality I just described is based on libbpf. Libbpf is that user space library that's there for basically all your BPF-related wishes. And it also exposes the linker functionality I just described to you as a program. So you can programmatically link BPF objects at load time, or just before you load the program into the kernel, you can just link it together and then load the result into the kernel. One thing that I could imagine you could build with it is you could, for example, have your application built already and allow users to provide you with like their code. Imagine you have like a big networking application and you have one place where you could offer the user or the users of your program to collect statistics, for example. And they can provide you with an BPF object containing the program to generate the statistics and that they can extract from your program. And you can link that object into your application at load time, so the user can really make use of the BPF functionality still after you have attached your application. So imagine something like a plugin system in easy terms, right? The next thing I want to talk about is a bit more brittle, to be honest. It's called freplace. So imagine you have a program that you've already attached, that you've already loaded into the kernel, and you want to change parts of that program. So there's a functionality called freplace. It's available via syscall. It's available from libbpf as well. And it allows you to like swap out functions or subprograms of your application that are already there. So you can, even if the thing is already attached at runtime, just replace a function of it and basically put in your new code. It's a super powerful concept. Like, you can do a lot of different things. I've seen people doing interesting things with that. But you have to be kind of careful because it's not as usable as other features from BPF. The first or the main restriction is you cannot use it recursively. So in your whole call stack, like in your whole function stack, you can only have one function that got freplaced at some point of time. You cannot have multiple of them. So as soon as you have used it once in your stack, you should not use it somewhere else in the stack. You can still replace that same function again and again, but you cannot replace something up in the stack or lower in the stack. And that combined with another kind of feature. So this functionality, freplace, is often used in infrastructure, like libxdp, for example, uses that to attach multiple XDP programs to one network interface. That's something that the kernel doesn't provide, but libxdp allows you to do that. And that's based on the freplace functionality, for example. So if you're writing XDP programs, you can probably not ever use freplace because libxdp already does that thing. So freplace is something you want to use in your infrastructure, maybe. If you're building infrastructure for the BPF ecosystem, that's an interesting thing to use and to know about, but it might be not that useful in your applications. I wanted to show it anyways because it's super powerful, and if you're reaching like the limits of what you can do with the other method I showed before, maybe freplace is the thing you need to really get forward. So be sure it is there, but be careful when you're using it. Next up, when we combine programs at runtime, load time, whatever, so we're building more complex applications out of our programs, we want to make sure that those applications do what they are supposed to do. So let's jump to testing. There is a way that probably a lot of you already know if you're using eBPF or if you're developing in eBPF, and that's you're basically running your full application in some environment to test it, right? So in networking, it's usually a combination of network namespaces, virtual Ethernet pairs, shell scripts, bridges, and so on. And you basically set up a network within, like a virtual network within your computer, have the different namespaces, and you run your application inside that, those namespaces, basically. That's a cool thing. Like I've written here, it's used in self-tests, it's used in demos. I've seen it used for examples as well. So it's a pretty simple thing, actually, right? You can just set up your network and just run your application within that network that you set up. kind of difficult is, how do you observe if your application is really doing the right thing, right? So you cannot test your application directly, but what you're doing in networking, for example, you're usually just sending traffic through your application and see if it does the thing you expect. And if, I don't know, the traffic is dropped in between, do you know why it dropped? You don't know. It's just not there anymore. And then you start looking, so where's the issue coming from? Is it coming from my application? Is it coming from, I don't know, some setup issues? Is it, if I run this same script on another system, is everything in the same place that I expect it to be? All these different issues that you get if you're just basically running testing on your main machine. So it gets kind of hard to observe what is going wrong, what goes wrong, and it's also kind of brittle. Sometimes it's like you have a lot of race conditions there. If you set up network interfaces, what does the system do with them, and so on. And another thing is that if you do stuff like that, you need to change the system of your developers, right? And I can say for myself, I don't like people adding network interfaces to my systems. I have, like, they're using IP spaces, I might be using them as well, and it's always causes some issues. So I want to show you one other technique that you can use to debug or to test eBPF programs that doesn't require all these things, and that's called BPF test run or BPF proc test run. So that's a way where you load your BPF objects, just your BPF objects, not the full application, but really just the kernel parts or the BPF parts of it. You load these objects like you would in your program as well into the kernel. Then you know already those programs pass the verifier. And then you basically run that program without attaching it to the real thing. So you don't attach it to your network interface or to your syscall, but you just run it with a defined context that you give it, like you pass a buffer to it with a context, and you run the program with that. So you can think of it like unit testing for your BPF program. You take the BPF program, give it a defined input, and run it and observe the output. That's, of course, super useful for network programs where the context is super simple. It's usually just a network packet. It can be used for most network program types. It can be used for others as well. I know at least for syscalls, it can be used. For trace points, it can be used. And the full list is in that link. The slides are shared in the schedule, so you can get the slides from there and click the link if you want to. I want to quickly give you some hints on how to use it, because the documentation, as some parts of the BPF documentation is pretty sparse. But my hint is take a look at struct BPF test run opts in libbpf to get started, so you can really see all the options that you have for running programs in that testing environment. And the core idea of it is you build a packet in user space memory. You allocate some memory, you write your packet data into it, craft a network packet as you would do it otherwise. It's just basically you place your packet data there, or your context if you're speaking about syscalls. Then you pass all these, the full buffer. You pass the full buffer to the kernel, to that BPF test run function, and the kernel then continues to execute the BPF program in the kernel. So it's not like running in user space or anything. It's really running in the kernel on your buffer. If you ask it to, it can run the program repeatedly. So that's interesting, for example, for benchmarking reasons, if you want to run multiple times. And after the execution, the kernel returns the result of the execution. So it returns, for example, the modified network packet, if we're speaking about that. It returns the usual return value of your program. So you know what would have happened if that thing was being run in the kernel at a normal hook. And for benchmarking reasons, it returns the average runtime as well. So it's a pretty nice thing that you can use for unit testing, like I said, for benchmarking as well, especially for networking where you have programs that are usually time sensitive, so you want to process the packets quickly. So that's why you can use it for benchmarking as well. So next, I want to talk about the eBPF helpers and kernel functions. Those are basically all the APIs that you can use from your application. It's basically a set of functions that you can call. right? And for you as a developer, it doesn't make a difference if you're calling a BPF helper or a kernel function or kfunc. That's not different. It looks the same. It's just a function call. The difference for you as a developer is that BPF helpers are part of the stable user space API of the Linux kernel. So there is a man page documenting them, and that's part of the stable API. So that will not change in a backwards incompatible way. So your programs using BPF helpers will always, like if they run on a current kernel, they will run on a new kernel as well. On the other hand, we have kfuncs, and they are not necessarily stable. There are some lifecycle guarantees attached to them, like they should follow some rules, and those rules roughly boil down to we don't want to change them without a reasonable justification, and we don't want to remove them without reasonable justification, and there should be a deprecation period if we want to remove them, but it's not guaranteed. So if we see there is an issue with those functions, and it's reasonably bad, that issue, then we can just remove the function or the kfunc. So if you want to use kfuncs, it's a bit more of testing you should put into place when new kernel versions are released, or at least check if the functions are still there and if they still work in the same way. Sometimes these these kfuncs are also explicitly unstable. So there are functions that are explicitly unstable. One example for that is currently connection, like contract access. You can access the contact table from your BPF program, and that thing is currently explicitly labeled as unstable. So you, well, be careful when using it. That's the main takeaway from that. The list of helpers and the list of kernel functions is basically growing with every release. So it's hard to take a snapshot in time and say this is what you can do, because it changes from release to release. There are new functions added, new functionality that you can call from your BPF programs. And I want to quickly show you how you could navigate that space, so how you could find your way around and how you can find out which functions you can call and which ones are available. So for BPF helpers, it's kind of easy. So there's a man page that's called BPF helpers, and you can just type man BPF helpers, and you should get a long list of functions that you can use. And I invite you to just step through that once and see what's available. The functions are somewhat descriptive, like the names are somewhat descriptive, so you can at least guess which area of functions are available. I would not want to guarantee that everything is documented in that man page. So there is this header file that I linked here, or where I showed the path here. You can go to that header file and take a look. So all the functions must be in there all the BPF helpers must be in there that you can use. For kernel functions or kfuncs, it's not that easy. There is no man page documenting all of them. So in the end, it boils down to you need to look at the kernel source if you want to know which kernel functions or kfuncs you can use. Some of them are documented in the normal kernel documentation, but not all of them. So a lot of them are basically only viewable if you look at the kernel source. But one nice thing is all of these kfuncs should be marked with __ BPF kfunc. So if you just grab in the kernel source for that, you should get a long list of functions that you can use, and it should be almost complete. There shouldn't be any other functions that you missed that way. Right. So as a summary, what I want to show you with that talk is that basically the BPF development environment got a lot better in the last years, a lot easier, a lot more comfortable, and so you can really build more complex programs more easily. And one particular nice thing about everything that I showed today is these features are not, these are not from yesterday's kernel. They are not super bleeding edge, but they are present in kernel for a while already. So if you have a reasonably recent distribution or Linux distribution, you can use these features today in your program. If you target something that is somewhat current, you can use it today, and you don't have to wait for the next 2 years for those functions to arrive and for those features to arrive. And with that, I want to thank you for your attention. And if you have any questions, please go ahead.
So, sure. Thanks for the talk. About F replays.
Mm-hmm.
So correct me if I'm this is happening at a runtime, right? And previously you mentioned that now in modern eBPF we're not bounded by the loops, so you can have unbounded loops. So is it correct to say that a free place can have now that, I mean, if it's having a runtime, so you don't need an upper bound and lower bound. So you can have a number of loops which are not bounded by the iterations. Is it?
So the question is basically if we can kind of escape with every place and the loops, like the unbounded loops, if we can escape kind of the limitation that it has to stop at some point of time. No, not necessarily. So everything still passes through the verifier, and it's not really unbounded. So let's take the BPF loop function, for example. That's also like, it's a helper function as well. So that's code that is not within your BPF program, and you don't control it, but the code that iteratively calls your callback function is part of the kernel. So you pass a number of iterations to that function, and then the kernel makes sure to call the next function a number of times. And only that number of times, and there is an upper bound to that. So it's not unbounded in that way. And no matter if you ever replace anything after that, that doesn't change anything.
I can ask one more.
Yeah, you go ahead.
What's the reason that kfuncs is not documented? I mean, it's like Linux is a huge code base. Is it an open issue that people are documenting kfuncs because?
So what I can add there, it's not that they're not documented at all.
Okay.
It's just not like the documentation is not exposed. Like you don't see, like it's not in the normal kernel documentation, for example, that's rendered online. But if you search for kfuncs, like the BPF kfunc thing in the kernel, then usually these functions have some kind of annotations on top of them saying like, this function does this and that, those are the parameters. So it's not completely undocumented, but it's not openly documented in a like online rendered way. Any other questions?
How many people were watching cat videos? Okay,
oh,
thank
yep,
you.
no. One hand. Sure, go ahead.
So, like, in like a sentence or something, what's like, so these new building blocks that have been given, what's an example of like how they're being exploited, like from a user perspective, like what's enabled that wasn't possible before?
So he was asking for one sentence, basically, what you can do now, what was not possible for. Yeah, or an example for that. So for me, the most interesting things are, let's say, these composability things. So you can build more complex applications, and really, you're not bound to the strict rule, I build my program first and then I load into the kernel anymore. So you can really change at runtime what is going on, in the most extreme case. And what is possible through that is, for example, what I told beforehand, the libxdp, so the library that's used for interaction with XDP programs. They found a way to attach multiple XDP programs to one interface using freplays. And beforehand, there was a one-to-one mapping. Like your network interface could have had one XDP program, and you could run it. But that's it. And they made it possible that multiple programs can attach different programs to the same interface. That's, for example, something that is enabled by these new functionalities. All right. Thank you very much.
So I'm going to give it like 2 more minutes. Am I already unmuted?
You are unmuted. So we'll start close to time.
Do you know how I could point with this?
Yes, so the thing.
Yeah.
See, there's a leader.
Uh-huh, great. The red one.
The red.
Great, thank you.
So we'll start close to time because if in case somebody is dialing in.
Sure, sure.
Japanese was the spoken language is really inconsistent because of writing.
Like Chinese, I know.
Yeah, I can like order military meaning. So that's as an Indo-European language that's normally related to my native language, it's off the different scale. I never knew that people a language with 2 plurals for every one. For 2, 3, 4 and a different one from 5 and upwards. And whether you're saying I'm going to Prague, or I'm from Prague, or I'm in Prague, or I'm going to pass by Prague, the word Prague is different for all. Yeah, I now realise.
Okay, so let me introduce Arjun Shankar. He's local in Brno. He's going to tell us more about glibc and stuff. So I know this is the last session, and thank you very much for everybody for being here. Let's go. That's it. All yours.
So, hi everyone. I'm here to talk about glibc. I've tried to put this together as a sort of call to action for a first-time contributor or a fairly new contributor. But I'm also hoping that maybe it's useful, at least entertaining to people who are experienced programmers and already know their stuff. Who am I? My name's Arjun. I'm an upstream glibc contributor. I also co-maintain glibc in Fedora and Red Hat Enterprise Linux, which of course means that I work at Red Hat. So I'm going to try to, this is the last talk. I want to make this really quick to talk about whatever I have to say and leave some extra time for questions and answers. I hope I make it. It's really my first talk, so I'm not sure how I'll get the timing right. But I'll try my best to leave as much time as I can for questions and for people who want to maybe leave early to party, right? So I'm going to go with an introduction. I talked about 7 steps in my title, so I'll quickly jump into the 7 steps. And then I'm going to walk through a patch, a glibc patch, a recent glibc patch, just to kind of show what kind of goes into writing a patch. And then I'm going to talk about what you could do to contribute to and help with glibc. And then, of course, questions at the end. And we're off. So I was first introduced to the C language in high school. I knew a little bit about stdio.h and malloc. And to be honest, it was mostly magical incantations that I wrote in the middle of my program to print and to get input and to allocate some memory. I really believed it was something that's happening within the compiler and kind of didn't really think too much about it. But very soon I realized, string length, for example, is a function that can be written in C. So it's not really magic. There's something going on there. Obviously, eventually I got into this field and I know a little bit more about all of this. Well, not all, but some of it. It's a pretty wide topic. So I know that a lot of it is actually mostly written in C. Mostly written in C. So what is glibc? It's the standard C library. We have all of those functions and a lot in between. For example, one might think that main is the first thing that starts executing when you start a program. But there's quite a bit that goes on before that. That is the loading of the program, placing everything in their right places, fixing up function addresses, and then finally call main, and then you go on with the execution. So there's a lot more to glibc than just providing the functions. It is the runtime. Okay, so next we're going to talk about why it's maybe useful or why you might want to contribute to glibc. I think the first reason, at least for me, is that it's very high impact. There are millions of installations. It is the C library for the majority of non-Android Linux-based operating systems. If you make a change in malloc, for example, that shows up on the critical path, you're looking at trillions of executions of the code that you wrote in a week or something like that. I don't know the exact numbers, but you can think about every time malloc goes through, your code's in there doing something. So that's what actually makes me very happy about being able to work on this stuff. The other thing is we actually have a fairly actively developed piece of software. It's not really like some arcane old thing that's never really updated. We have over 1,000 commits a year, which means we regularly add bugs that need to be removed. My personal experience with the community is that it has been very welcoming to me, very kind. Mistakes are welcome and accepted and understood. We all, commit bugs once in a while and help each other out to fix it. It's like any other piece of software, really. We recently, I think recently is not really accurate, but I think it's been more than a year already. We have weekly public video patch review meetings. So people who have recently submitted a patch can actually show up to that meeting. There's a link somewhere in our wiki. Show up to the meeting and talk about your patch or say that you want review, and someone will be assigned to look at it. A lot of the regular attendees are basically like regular contributors. I don't show up very often to that meeting, for example, but once in a while I do, and try to find or get assigned a maybe a beginner's patch, because I do care about this. I do care about, it makes me happy to, it's first of all easy to review a patch by a beginner, and it makes me happy to see that we have another person who made a contribution and who might make more contributions, right? It's got this kind of multiplying effect. So we have all of this, and we do look out for patches from new contributors. And we also have a code of conduct that is a work in progress. So yeah, we do care about being welcoming, being kind to everyone, and trying to get as much as possible contributions from people who are willing. Okay, I said 7 steps. It was a clickbait, to be honest. I didn't know how many steps it would be. I don't think there's a fixed number of steps, but I did shoehorn the 7 steps here. You can see them. So you do a git checkout, and this is a bit of an idiosyncrasy. You need to be building in a separate directory, and you can't really build in the same directory as the source tree. I don't know the reasons for it. It's something to do with the build system. I don't know most things about glibc, to be honest. So you build in a separate directory, and you need to make sure at configure time that you provide a prefix, which is about where it's going to be installed. It's just a couple of idiosyncrasies to building glibc that don't exist in a lot of similarly packaged applications, right? So let's say that you're trying to fix a bug. A good place to start is by maybe adding a new test that fails without this bug having been fixed. So that's a potential step 3. You implement the fix. You do some testing. We recently added a couple of recent is always a bit of a longer time span when it comes. But maybe I think a couple of years ago, maybe slightly more, we added a couple of scripts to help you run a program not on the system's installed C library, but on the one that you just built. So there's test run for that, and then there's you need to do a lot of special things to get GDB to pick up the in-tree freshly built glibc sources. Not sources at this point, of course, executable, and then run it with a test program. And so we have a script to help with that as well. And you can use that to kind of check out how your test and your fix is working, and then eventually you delete the build directory, you reconfigure, you run make check, you make sure everything's working fine, and perhaps you submit a patch to libcalpha@sourceware.org. That is our mailing list. We submit patches there. We discuss patches there, right? Is that the end of the talk? Maybe not. So I will now go into the anatomy of a relatively simple patch. I try to look for something that is on the order of magnitude halfway between a fixing of a typo in a comment to like a entirely new, let's say, feature that changes dozens of files. Somewhere in the middle of that is this. It's a fairly simple fix that went into glibc recently. My colleague Florian, who is an experienced developer and a prolific committer in the glibc source tree, he submitted this a couple of days ago. I reviewed it for him. And it's basically a fix to a function called stir error. And apparently this function must not return null. We'll go into why. So for some reason, stir error, the function was returning null in some cases, and it's not allowed to do so. And then Florian goes on to explain that we made a recent change where stir error was implemented in terms of another function, stir error underscore L, and that's what caused this sort of regression that needs to be fixed, right? What is stir error and stir error underscore L? So stir error is basically, if you know errno, the error number, it takes in a number which potentially is the error number, and it returns a string corresponding to that number describing what that error might mean. Obviously, if you put 0, you get success. And I did not know this, and I really don't know if this was a joke or if it's I don't know, divine intervention, but stir error 42 returned no message of desired type. I have not read the book, but 42 is apparently an interesting number, and I thought it was funny that this is the reply you get when you try to find out what 42 means. So stir error underscore L is a very similar function that returns a string in the current locale, which might have a different language than the one then in a given locale, sorry, not the current locale. The current locale is the one in which the program is running. So the program is running in locale X. You want the error message in locale Y for whatever reason. You use this other function. Obviously, you can now see why stir error can be implemented in terms of stir error underscore L. You just pass the current locale and you get it back. So someone made that change, which was definitely an improvement, right? We don't want to duplicate code, but it caused a regression. And why was it a regression? Stir error is not allowed to return null, but stir error underscore L actually is allowed to return null for some reason. And the details of that are actually in this little bit in the POSIX documentation for these functions. Right? POSIX tells you what these functions are allowed to do in what circumstances. And basically, the POSIX manual says that whether successful or not, stir error must return a pointer to a generated message string. But stir error underscore L does only need to return it upon a successful completion. If it's a fail, it can return null. So the moment we made stir error use stir error underscore L, we started having the same behavior that it was sometimes returning null. That was the bug. So now we're actually looking at the patch that Florian wrote. It was a test and a small change to the code, right? I really want to show that, I think my idea here is to show that a patch is not so complicated here. Like, you can see this and see that it's not, I don't know, like arcane magic, right? So the test includes some usual headers. You see a few headers called support/something. Those are actually part of the glibc test rig. When you run the test suite, you can actually use some helper functions to do a lot of things, like implement some checks, do some error checking for functions that you're not testing, and so on. So we have some helper functions for it. The patch has a test. This is where these are the headers that the patch had. So first, we're going to look at the test itself. So I think I should be using this at this point. Okay, is that visible? Yeah. Okay, so it's a function that tests this stir error, and what it does is it sets a variable called fail malloc, which when you turn it true, apparently some malloc is going to fail. Every malloc from here on is going to fail, right? And then you call stir error with a weird number, which obviously is not a regular result that you get for an error.
and then you get the result for it, and then actually you stop causing malloc to fail because you don't want the rest of the test to stop working, right? Only for the call of the stir error you want malloc to fail, because we know that that is the point at which stir error was returning null. It was trying to do an allocation and would fail and would just return nothing. So we got malloc to fail, we got a result, and then we're actually checking that this result is the same as this string unknown error, which is the default string for any kind of error that you don't really know what it is. So we expect this. So this test compare string is actually from the test rig. Like I said, we have the support directory where you have all of these helpers. It's one of those helpers is this. It just compares strings and it logs an error if they're not equal, right? I forgot I can use this to change slides. So now we're looking at the test itself. So the test rig actually has this bit where it makes sure a test will not run forever, right? If the test was a main program that never returned, then you'd run make check and it would be stuck running one of these tests forever. So what we do is for tests that we have in glibc, we require you to actually define this function called doTest, and then write all of your testing inside it, and then you just include the rest of the test rig, which has a main function, and that will actually make sure that this doTest doesn't run for more than a couple of seconds. So that test will return, or if the test gets timed out, then it actually errors out, and we know that this test hangs for some reason. So that's pretty much all of the tests. So Florian did include another test for stir error _L. But that's not important. I just want to talk about the one piece, so that's what I bolded here, right? And now we move on to really the end of the test itself, which is the malloc, which we said that there could be a malloc that fails, and this is the malloc that was in the patch. So it's a malloc which will obviously take precedence over the malloc in the C library. If you define this function in your test, it's going to get picked up before the glibc's malloc gets picked. And what it does is, if this fail malloc is true, it returns a null, which means it won't allocate. And otherwise, what it does is it goes into the glibc .so, and it picks out the actual malloc, and it asks it to do an allocation, right? Because we don't want to re-implement the whole malloc. We just use the one that actually works. OK, we finished writing the test. How do you add a test to the glibc source tree? This is a string-based test. Stir error is a string function. And so we have a directory for that. You just go to the makefile, and there's going to be this little line called tests, and then you just add the name of the test here without the .c. It's literally just that. You write this function. You don't write it as main. You write it as do_test, and then you add it here to the makefile. And you have already a test that will start to fail, right, without the fix. So now, and I really hope this is visible because it was really, really hard for me to split this among multiple slides. So now we're looking at the fix itself, right? I'll quickly go through this. So we have stir error _L. Like I said before, we implemented stir error in terms of this function, right? So this is the function where the problem lies now. I know it's allowed to return null, but there's nothing wrong if it stops returning null also, right? We can do better than what the standard requires. So we'll now make both of these functions not return null in any case. So we have this error number that we get. Ignore that bit. It's not about errno. Errno is something else. Let's not think about that right now. So we have this error number from the user, and which we need to convert to a string. We go to the error list. Really, let's not care about the details. We go to the list, and we get the number, and we get a string corresponding to it. And if we don't get a string for that number, then we know that it's an unknown error. We don't know what this error is. If we knew what it was, we'd have it in that list from the get error list, right? So we're in this piece where we don't know what it is. If we know what it is, then we just translate it to the locale that is requested, and then we just return it, right? So this is what the code looked like before. Here on the right side, this is what the code looks like after the fix. Everything else is the same. It's just that this bit where we don't know the error, it got fixed. And so what got fixed there? What got fixed is we were trying, when we know that there's an error number, let's say 999, right? That's what we had in the test. We were trying to return something like unknown error space 999, right? We're trying to create, like on the fly, a string with the number also, so that eventually, when it shows up in the application somewhere, that number is not completely lost. That number is still there. We're trying for it. So what we were trying to do was we're trying to do an ASPrintf, which basically it allocates memory and it prints into the memory whatever you want. It's basically like printf, but it'll create its own buffer and it'll print into a string, right? So we call ASPrintf, and whenever ASPrintf returned -1 because it couldn't allocate memory, we were returning null. Okay? And what we do now is, okay, so we tried to return unknown error 999, and ASPrintf failed. So, okay, Florian changed this a bit. We were looking for a -1 for failure. Now we are looking for greater than 0 for success. Why is that? Because ASPrintf returns a number of bytes that were written. So if it wrote a few bytes, we know that it succeeded. If it wrote 0 bytes, we actually know that something went a bit odd there, right? It didn't write anything. And if it returns -1 or any negative number, then of course that's also an error condition. So, so that kind of got reversed, right? Now we had the error condition first, and then we had the success case. So we changed this around a bit. So if we succeed, we set the return string to the one that we got from the printf. But if we fail, what we do here is we return simply unknown error without the number, right? Which is a static string. We don't need to allocate anything for it. It's just unknown error. It was part of the binary anyway. It's just going to get returned. So that's the fix, right? That's the fix. And now we look at this and we're sure that we're never going to be returning null. Okay. I do want to pause here and ask if this is completely gibberish or it kind of made sense. Kind of made sense. Are there any sort of let's say C beginners here who see this and feel like, okay, that's not too hard. It's not arcane magic, or maybe? Okay, I think that's what I was hoping for. I was just hoping to show that, you know, a glibc patch is not all that, right? It's not all that. So that's the fix, and that is actually the entirety of the patch. I know I kind of formatted it and showed it in a slightly different way. That was Florian's patch, which fixed this bug, and that's actually like what I really wanted to make a point about. Now I want to talk about what you could do to contribute to glibc as a, well, even if you're super experienced in something else, or, you know, also super experienced in glibc, but you're bored of doing something that you usually do, there are a lot of things that, require relatively less knowledge of the internals, where you could make a difference. So the first one is that you could write new tests, and you could improve old ones. For example, we have so, you know, Fedora. I'm also a Fedora contributor. So we have the Fedora glibc package, and then we have some CI behind it, which runs a lot of tests. Some of those tests actually I wrote a few years back, and didn't upstream them for whatever reason. Don't hate me. So we run the CI, and which a lot of those tests are not really upstream. The reason for that is that some of them require setup or, you know, altering the system's kind of configuration in some way, and, you know, those are not the sort of tests you want to include in a test suite for an application where like you're messing with the user's system. You probably won't even, it'll fail because it'll try to, I don't know, modify nsswitch.conf, and it can't, right? But since then, we actually have containerized tests in glibc, So I'm going to go back here. So instead of adding an entry to this tests line, you add it to a different line called tests-container, which you can write a containerized test. You can make a little directory containing all the files that you want inside the container. And you can actually write a test that does a bit of setup or has a bit of setup that modifies the system, but it won't modify the system. It'll run inside a container. So you could do some tests like that. You could look at the CI tests for Fedora and then upstream them as containerized tests, for example, right? You could write documentation. I'll come to that. Actually, I just attended a talk earlier today where it was about beginners feeling like how it feels to be a beginner in the open source community. And actually, the speaker there said that we should have good documentation. So I feel bad about that. That I'm saying write documentation is a beginner task. But okay. For people who are a bit into GDB, there's this whole thing called pretty printers. I don't know much about it, but I think it's like a Python thing where you can write pretty printers, and we have lots of like these opaque glibc data structures. Maybe bits of the glibc heap. Maybe there's a way to like walk through the heap. Maybe some other opaque types like a lock. Is a lock locked? Because if you try to see like a pthread mutex type and see what its values are, like it doesn't say whether it's locked or not. It's going to have some numbers behind it. So you could write a pretty printer that actually just prints like, okay, this lock is currently locked or not. Occasionally, when you're just like reading code, sometimes you'll notice like it's changed a bit, so the comment is a lie, and nobody caught it at review time. It often feels like it's not of value, but honestly, it is. Right? It is of value. There's value in fixing that. Obviously, it's not so glamorous, but it helps. We also have a bug tracker where you could sort by new and maybe like confirm that this bug actually happens for you, or try its bugs, see why they happen, all sorts of stuff. Some more relatively more specific ideas. So you could optimize the integer to string conversion in printf. You could rewrite the base64 decoding encoding. We also don't have info pages for dlopen and pthread, a lot of pthread functions and some dlopen and related functions. You could write those, explaining the details of how the glibc implementation handles these things. And we have this mtrace, which is currently a Perl script, but you could convert that to C. So these are like concrete things. I'm just mentioning like which we could use some help with, right? We also have awk and Perl scripts that we picked up at various points of time, and we could kind of standardize on Python and kind of reduce the no hate for these, just reducing the number of things that we need to build glibc. Yeah, so a lot of things to do. I promised to leave a lot of time for questions, and I see it's only 5 minutes. I'm sorry about that. But I hope some of you will stay and keep asking. I'm here to answer anything that I can. Final kind of links. We have a wiki. It's very out of date, to be honest, but it's still useful. We have the bug tracker. And we have the development mailing list, and then this one is, I would say, really nice. libc help for people who don't want to don't feel so comfortable like posting a patch like from the get-go, but need help with something. Like maybe you want to ask what you could work on. Maybe you want to talk about something you're trying to work through, but you're having trouble. So like everything libc related is sort of on topic here, right? You could write there and ask questions. You could also, hey, like just sort of a beginner here myself, to be honest, right? It takes years working on this stuff and still feeling like you don't know much. But you could write to me, and if I don't answer you, I'll point you to someone who can answer you. So now, questions.
So my question is like, first, this is a really inspiring talk, actually. I never thought of contributing to libc or that it was even possible until I watched this.
So my question is like, for like a new application, it's quite likely that someone is going to be seeing the source. You know, they want to dig into it. They go to like GitHub or something, or GitLab.org, wherever it is. For libc, I feel like people take it for granted, so maybe they're not like seeking out the source immediately, and they're not seeing that like contributing.md or whatever. So I guess my question is like, besides this talk, how else do you hope to maybe like pull in potential contributors?
So I'm just going to repeat the question, which is that for a lot of application level stuff, there's you know, a more modern, I guess, repository, and like a contributing.md, possibly on GitHub, and glibc doesn't have that, and also a lot of people take it for granted that, you know, it's probably works good enough. I guess that's what you want to say. And so how do we hope to have more contributors? To be honest, this is a question I do not have an answer to. It is quite an old piece of software. It is well established. The truth is that there is, as I said, over 1,000 commits a year. I actually checked. Maybe not like, not every release is 500 plus commits, but the average is like over 1,000. So it's happening. I think a lot of the contributors do tend to be full-time employees of software companies in this field. That is quite true. It's a hard problem, really. I must say, it is a hard problem to. I know it's just not as like it's also not as glamorous as the kernel, right? I don't know the solution to this. I don't know the solution to this, but. You're right. I think it is sort of harder to get contributors into this than to some other stuff. So I guess that's my answer.
We can take one more question and then the remaining on the pool part.
Sounds good to me. Okay, so two. You can go first.
Okay. My question is, after creating some the patch, and what are the additional steps to be merged? For example, sending pull request to the repository or some uploading patch to the bug ticket, something like this.
Yes. So there are a lot of things you could do. First of all, if you found the bug, obviously you could file a bug report while you're working on the patch. File a bug report, assign it to yourself. You don't have to, but it's good to do that. But literally sending to the this mailing list is all you need to do. You could be a drive-by contributor who does a patch that sort of fixes it but has some issues, and you could just like send the patch here and walk away and never come back if you don't want to. And we might still actually work on it and write ourselves down as a co-author and finish the patch. I've seen that happen at least once fairly recently. Somebody fixed a bug in one of the glibc utilities that ships some executable. I don't know which it was, and I think someone kind of fixed up the patch a bit and then like committed it on their behalf. So like that's it. It's a bit old-fashioned, I will admit. So I use git send email. I also remember that my company actually changed the way like our email provider, and there was like a few months in between where I was nervous that am I going to be able to send patches the same way as I could, and I was like using my private email address to send patches. But it's git send email works for me even now, and that's the one I use. But you could attach it to an email and just send it here, and it should be fine. We don't have pull requests. So.
Sorry, how about the license agreement?
Sorry?
The license agreement, isn't it required anymore?
Aha, okay, good question. I will come to you. So, good question. So, license agreement, I guess you mean copyright assignment?
Yes.
Yes. So, you may assign copyright to the Free Software Foundation if you wish to, but it is not required anymore. You could do a developer certificate of origin. You don't need to assign copyright. So that requirement is gone.
It's a new thing.
Yeah, it is fairly new, yes.
Okay.
So my question is, I've been contributing to some smaller C code business in the past, but when I try to read source code of something big like the kernel or glibc right now in new patches, there were so many function calls that really have trouble making sense of. Do you have recommendations for any kind of preferably free trees and freedom tooling to make understanding this easier when you dive in?
I have the same. So the question is, are there any free tools to kind of help understand all of the function calls that happen there, which are like, you don't know what's going on there? The answer to that is I actually don't. I have the same problem myself. I try to avoid looking at a lot of context and just trying to look at this particular patch, look at this particular bit of code. Okay, I'm out of time. I can continue answering questions, but we will do it off this platform.
Thank you very much.